ಅದು ಕೊಡ್ಬೇಕಾ ಇವಾಗ ನಿಮ್ಗೆ ಆಪ್ಷನ್ಸ್ ಇರುತ್ತೆ I'll change it to
wait. Let it be. We'll just
Polyland linking. This is the link that's right now.
yes.
Okay, good.
Hello.
ಇವಾಗ ನಿಮ್ಗೆ ಆಪ್ಷನ್ಸ್ ಇರುತ್ತೆ
Wait. Let it be. Yes.
Hello, can you hear me on YouTube? Can you hear me, Chetan? Mic testing 1, 2, 3.
volume glass. Hello, hello. Hello, hello. Hello, hello. Hello, hello. Hello. Hello, hello. Hello, 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 hello.
Okay. Welcome everyone. Please settle down. We're already. Yeah, please settle down. I have a few quick announcements to make. You might have noticed that there is no tea breaks. So there is a flowing tea and coffee. You need to go and then fluid yourself if it is required. And then again, quickly join in. Because this is a very jam-packed session with a lot of excitement. So I will start immediately. I'll welcome Professor Srinivasan Raghavan, Chair, Science, to come on the dais and then start with the proceedings with a welcome address and then following that. Okay.
Okay. Can we settle down? Yeah. Okay, great. Very good morning to all of you. We have started more or less on time. So I will not spend a whole lot of time welcoming you apart from saying that thank you all for sparing your valuable time. We have members from the government, the strategic sector, industry and academia. And we realize that when you're welcomed to a conference and you're invited, you have to take time of your busy schedules to think about it. It is a burden on your mental bandwidth and come here. So thank you all. We really appreciate it here in Sense. The other thing that I had wanted to say is normally in academia, faculty members tend to organize conferences. But COSEIn is different in the sense that the Center for Nanoscience and Engineering, CENS as we call it, we have about 200 very highly skilled staff members who run our fab. That is an extremely essential part of the ecosystem that we are discussing today. And over the past many years, even pre-COVID, based on similar conferences that are held elsewhere in the world, and they are not there in India, the staff members who man our facilities had expressed the need for such a conference. We had also appreciated its importance and we had supported them. And therefore, it is their initiative. So it is the staff members in Sense who are very highly skilled and who I repeat are very essential for the ecosystem who are running this conference. So it's not us academics or academics like me, the faculty members who are running it. Okay. Now, coming to the conference itself, we added a small twist to it. So previously it was all about academic fabs and how do you go about running an academic fab, how many HRs you need, should you have 1, 2, and then I believe when one of our staff members had gone to the West, they had said, good academic fab needs at least 5 HRs. So those were the kind of discussions that we would have. But going ahead now, we've realized that these staff members and all of us are going to be part of this important emerging ecosystem. And that pertains to the absence of a fab in India. Okay. And so that ecosystem has to get going. And that is what we are all here to discuss today as to what it is that we need to do. Now, when one talks about the semiconductor ecosystem, the first focus that comes to everybody's mind is, oh, we need a fab. It's all about fab and the absence in India, but fact remains, and there are quite a few documents, but I particularly like one very nicely written report by McKinsey, that fab is one of the many components that constitute the global electronics ecosystem. I mean, there is equipment, there is material supply chain, wafers and such, there is packaging and so on and so forth. And case in point is a country like Japan. It's not that they don't have fabs, they do have fabs, but they don't have fabs of the size that one all thinks about like TSMC or Samsung or an Intel, but they play an extremely important part in the global semiconductor ecosystem. And so India needs a fab. I'm not saying we don't need a fab, but there are other aspects of that ecosystem that already exist in India. I believe we are close to about 75–80% of the way there, that if given a little bit more extra fill-up, we would, I believe, be able to play an extremely important part in the global ecosystem. And if that is a point that can be brought out by all the stakeholders who have come here today as to what is your ask of the Indian ecosystem that will enable you to be a global player, that is a message that we can then communicate to the government of India going ahead. We have deliberately chosen a discussion-oriented format. Okay, it's not just one person giving a talk and so on and so forth. We would like you all to actively interact and be blunt, okay, as to what it is, like I said, you want, what it is that we should be doing. Then you leave it to us to figure out how to summarize it and communicate it to the government of India. We have Dr. Ramana Reddy from the government of Karnataka, who is also with us. And I'm sure based on my interactions with him, he would also want a frank feedback from everybody, because we are all here to enable this ecosystem. So I will just end up by saying that we have Dr. Ramana Reddy, who is our chief guest. And so you will hear kind of from the horse's mouth as to what is happening, if not at the government of India level, at least at the government of Karnataka level. And he has been extremely supportive of the kind of activities we have at Sense, not just for the current semiconductor ecosystem, but also things to look about in the future. Quantum computing, neuromorphic computing, etc. are there on the horizon 50, 20 years from now. And only if we invest in them now, we could expect or hope to become leaders in that tomorrow. I mean, this is what countries in the West did. They are leaders in the semiconductor ecosystem now because they invested in it maybe 40, 50 years ago. So with that, my time is up. It's 9:15 according to the clock back there. Vijayaraghavan, I don't know if I have to hand it over to you or I can welcome Dr. Ramana Reddy, who is the additional chief secretary, okay, of the government of Karnataka, and he looks after IT, BT, and the Ministry of Commerce. So with that, Dr. Reddy, over to you.
Thank you, Professor Vasu, Shri Naukant Bhatt, Professor Srinivas Raghavan, then all the dignitaries present here. Firstly, I would like to thank all of you for inviting me for the conference on semiconductor ecosystem in India. It's always a pleasure to visit IISc. As you all know, IISc is the #1 university in the country. And recently, there was a presentation by director in which it is said that if you take the publications per faculty, if you take it is #1 in the world. So it's a kind of university which has produced Nobel laureates, Bharat Ratnas like C.N.R. Rao. So I am always happy to be here. Secondly, with my portfolio as electronics, IT, BT, and science and technology, I was really very much impressed by Sense when I first visited. So in fact, when the G20 country representatives came here, firstly, G20 RBI type central bank deputy governors and secretaries have come. At the time also, I requested IISc and Professor Vasu that he should host them. Secondly, when the finance ministers of G20 and central bank governors came, again, I requested him. He happily hosted. And he has hosted in such a way that normally scientists and professors, they are very good at their work, but this administrative things and organizing, I was really impressed by Professor Vasu, the way he organized both first when the deputies came and the second when the actual finance ministers and central bank governors have come. And feedback is really excellent. Thirdly, I would like to say that nano level research, nano system scale research, whatever is done here, I have seen 2-3 times. First I came on my own, then twice I came with these G20 groups. I was very much impressed by nanoelectronics research and other testing facilities which are here. As a country, I feel that we should, lot of focus is there these days on electronics, and as Professor Vasu has said, even the chip fab and other things. As a country, I think that we import a lot of things. I am told 25 billion worth chips we import every year. So we should, and recently it was said Once upon a time, 99% of the mobiles which were used in the country were imported. These days, we produce 99% of the mobiles which are used in the country. So my point is, as Professor Vasu has said, ultimately, almost for the last 20 years, we are talking of setting up a fab in the country, but we didn't succeed. So fab maybe, as Professor Vasu has said, it can happen a little later, but other ecosystem is very, very important. This is the first time that Government of India has come out with an India Semiconductor Mission in December 2020. And they have earmarked about $10 billion for India Semiconductor Mission, and they are giving a lot of PLI and other schemes are there for supporting the electronics manufacturers in the country. Karnataka is not far behind. Karnataka is always a progressive state. I always claim that we are first in the country to have come out with the sectoral policies, right from 98 IT policy, then biotech policy, aerospace and defense policy, EV policy. Similarly, we were first in the country to have come out with a semiconductor policy in 2010. And then we came out with an ESDM policy in 2013 and 17. And 2020, when the world was witnessing the pandemic, we were first to have come out with, even before Government of India came out with India Semiconductor Mission, 7th September 2020, we came with our own policy, ESDM policy, where we said we will give up to 20% capital subsidy, 25% subsidy on land, lot of concessions on electricity tariff, PLI of 1%. So these were announced by us in September itself. When the government announced the India Semiconductor policy, we have said whatever Government of India gives, we are not bothered. Whatever we have announced will be in addition to the Government of India incentives. So a lot of interest is shown these days by the electronics manufacturers in Karnataka. In the last 2 years after we announced the policy, we got interest worth about 20,000 crores of investment. About 11,000 crores of investment we have already cleared in the high-level committee and single window committee, and they are setting up, and another 10,000 crore investment is in the pipeline. We are in talks with them. As it is, you know that Bangalore is the one city. I should say maybe we should boast of Bangalore, saying that it is the only city maybe in the world where 400 R&D centers are there, right? Public sector undertakings and also private sector. Many companies even in the semiconductor field have their largest R&D centers outside their headquarters in Bangalore. Take GE, take Intel, take Qualcomm or Applied Materials. They are setting up largest. In fact, yesterday, maybe it is not related to directly electronics also component. There was an article that Boeing is setting up they have taken 43 acres from our government land nearer to the airport. They are setting up their largest R&D center outside their headquarters in US in Bangalore, investing about $200 million, and it will be ready by maybe this year end. We have also set up electronics manufacturing clusters, one in Mysore and one in Hubli Dharwad. We have set up an electronics testing center called Lahari in Mysore, which is being used by the electronics industry there. If you produce electronics products, India is a very big market, lot of demand is there, lot of automobile industry is there, medical devices industry is there, aerospace and defense industry is there. We have one very good, we have set up 11 centers of excellence. One among them, the successful one is called SAFAL. The SAFAL is semiconductor fabless accelerator. And this also has done very well and supported a lot of youngsters in conceiving the ideas and getting the ideas converted into proof of concept. It is a very successful model, and the union minister, when he heard of SAFAL experiment, he said, you give a concept node, we should have SAFAL type in centers of excellence in other states also. As far as ISM is concerned, we also have signed one MOU with ISMC, India Semiconductor Manufacturing Corporation. This is a consortium of Tower Semiconductors with other members. 3 have expressed interest in the country. One has expressed interest, Vedanta Group and Foxconn, to go to Gujarat. Second one has expressed interest in Mysore, ISMC. Third is a Singapore-based company called IGSS, which is yet to, maybe it is in talks with various governments. So I am also saying that fab may not be a great thing, but we should have a fab as a, when we are such a large country. We boast of 85 plus chip design companies in Bangalore, and we boast of so much of R&D. Ultimately, I think Karnataka should have a fab. I'm not saying that fab should produce 5 nanometer chips or that kind of chips. It can be started with, in fact, ISMC Tower Semiconductor, what we have signed is 65 nanometer chips only. We are not saying that analog chips only, but it has a lot of demand in the automobile sector. So either it can be 65 or 28 nanometers, but India should have one fab. That is my thinking. But the other thing which I would like to see is, just like IT industry, software industry, when it came, we were very good, excellent in software. Even now, Karnataka itself exports 40% of software, roughly 78 to 80 billion every year. But it took a lot of many decades or years to produce some software products. Similarly, we may be very good in R&D, we may be very good in the design and other things, but electronic products, we should have electronic products from India. If I may, so Apple iPhones we may be producing, but we are not producing any part of that iPhone. They are made in India, in the sense they are assembled in India, not much of value addition. But what I would like to see in the next few years is definitely one fab, need not be 5 nanometer fab. It can be 28 nanometer fab. But more than that, I want to see a lot of electronics products to be manufactured in India. That is my dream, or that is what I want. So I would like to congratulate Sense for hosting this event, and I hope that it will be a very successful interaction. Thank you.
Thank you, Dr. Ramana Reddy, for the inaugural address, and Professor Srinivasan Raghavan. Thanks for the welcome address. A short announcement. We are organizing a facility tours, which is in Sense, which starts from 11 o'clock. Dr. Ashish there will be in charge. He will, you must have signed up for the batches, because we cannot take everybody at the same time. It will be 20 at a time. So please follow Ashish if it is required from 11 o'clock onwards. Now, I invite Professor Navakanta Bhatt, the moderator for the next session, which is setting up large-scale fabs.
A very good morning to all of you. Thank you, Dr. Ramana Reddy, for sparing your time. It's always great to see you with all the support that you have been giving for the whole ecosystem. Sense is one part of it. It's been amazing over the last few years, and we really hope that we are all set to have an exponential growth going forward. So one of that requirement for that growth, as was mentioned earlier, is to have our own fabs. Not academic fabs, but fabs which will bring out commercial products. Okay. So this panel discussion is setting up on large-scale fabs, and we have excellent panelists for this panel discussion. Let me welcome the panelists first onto the dais. Mrs. Deepten Kundu Chowdhury, who is a CTO of Aman Grade Clean Room and Engineering Solutions. If you can please come on the dais. Then we have Mr. Raghu Tatachar, who is Deputy General Manager, Tata Power Solar System. As you know, we already have major solar module production fabs in the country, and Tata is one of the key players, and Tata has also recently set up Tata Electronics. I think we will also discuss about that during the panel discussion. Then we have Mr. Rajendra Kumar Das, who is Vice President, Projects and Engineering, Sun Pharma. You may be wondering why do we have a person from pharma? Of course, Sun Pharma is a leader in pharmaceutical, production in the country. What we thought is that, pharma is a great sector to look at for us, for those who are in semiconductors, in the sense that pharma has now grown to a stature where large number of products are exported from India, and they're all manufactured in the country, and Sun Pharma is a leader. And pharma industry also needs clean rooms, right? Although perhaps not the kind of clean room that you would see for semiconductors, but nonetheless, clean room construction and operation, and ensuring that the yield, we will talk about that going forward. Yield is one of the holy grails in semiconductor manufacturing. Maintaining that yield day in and day out, how do they achieve, and how they have grown to this stature is something for us to learn and see whether we can adopt some of those good practices. And we also have Dr. Sunita Verma. Is she online? Can we get her on the screen? Dr. Sunita Verma is from Ministry of Electronics and Information Technology, Government of India. She actually heads the whole electronics R&D, and she's in charge of nanotechnology initiatives of the Ministry of Electronics, as well as all activities related to chip design. Recently, there was a road show which was conducted in Bangalore, in IISc, in J.N. Tata Auditorium, which was launched by the Honorable Minister. And I think Sunita Verma was instrumental in getting that roadshow organized and getting it off the ground. I hope you can hear us, Dr. Sunita.
Sorry, sir, she'll be joining in 5 minutes.
Okay.
Just 5 minutes.
Fine. And we also had one more, panelist who was supposed to be with us. We were really excited about that. That's Mr. David Reed, who has recently taken over as CEO of Vedanta Foxconn Semiconductors Limited. You may have seen that in the program, if that program was circulated earlier. But unfortunately, at the last minute, he was called for a meeting with the chairman, we are told, and hence he has expressed his regret. So he is not able to join. But it's very important development. He has just taken over as CEO just last month, I believe. And he comes with an amazing experience in running semiconductor fabs and leading semiconductor products at Texas Instruments, at NXP, at Global Foundries, and so on and so forth, right? So he has just taken over as CEO of Vedanta Foxconn. That's one of the players, as was mentioned by Dr. Ramana Reddy a while ago. And we believe that we will be able to have him here on some other occasion and get to know more details about Vedanta's foray into semiconductor manufacturing. So with that, details about the panelists, let me take a couple more minutes to set the stage. We always give this analogy that if you look at the worldwide electronics market, it's as big as India's GDP, about $3 trillion, right? And if you look at what is India's share in that, it is just minuscule, right? Maybe a percentage or so. I'm talking about the entire electronics manufacturing, right? It includes starting from materials all the way to systems, right? But one of the key factors here is semiconductor fab, because what happens is that when you start producing the chips, right, there is a downstream and there is an upstream, right? And downstream industry is extremely important, which includes chemicals, materials, and all other related ancillaries that we will talk about during the panel. And there's also upstream in the sense that you make circuits, you make systems, you provide services, and so on and so forth, right? If you look at the whole pie, it's huge pie, right? Unless you have every element of this pie, right, you will not be able to become a global leader, right? And that is why, even though you may not have 5 nanometer fab, which oftentimes is called not leading edge, but bleeding edge, because it really bleeds you down, okay? because not just setting up that fab, but also running that fab is really an uphill task. But you should have reasonable fab, whether it is 65 nanometer for analog and mixed signal, or 28 nanometer for a variety of logic products. These fabs are very important, and India Semiconductor mission that has been announced, where all of us are very excited about, is something that really trying to squarely address this problem, that the fact that we don't have fabs, and because of COVID and Ukraine war, we have seen this issue with the supply chain. Everybody understands that there's something called chips, although Intel had this famous ad, Intel Inside, which meant that chips are inside every product, but it was forgotten for several years. Now it has come to the fore, right? So it's very important that we are aware of this important fact, and we try to address this and come up with our own giga fabs or mega fabs in the country, right? That's the goal. But the return on investment on these fabs is always a tricky thing, right? Typically, you need to invest a couple of $1 billion in state-of-the-art fabs, and you will perhaps become break-even only after 7, 8, or 10 years, right? And that's where a lot of subsidies are required. And Government of India now has announced subsidies, capex subsidies up to 50%, and there's also a lot of opex subsidies as well, right? Now, this is a great opportunity for us, because in the past, over the last 2 decades, I have seen this whole ecosystem and a lot of government intervention. We started with what is called a Special Incentive Program, SIPs, then MSIPs, which was Modified Special Incentive Program, but they were not attractive enough. But I think today, I believe that we really have very attractive subsidy program. And what is more important is that states are competing with each other to top up that subsidy of Government of India through the state subsidy, right? So I believe that, the stage is very well set, and, we will hopefully have this fab, but there are a lot of challenges, right? The intent of this panel is really to discuss and deliberate on those challenges and really bring out some issues to the fore. And then, as Vasu suggested, we could perhaps come up with a summary and submit it to both Government of Karnataka and Government of India. So that is the bigger context. So the way this panel will run is that, first 45 minutes, of which I've taken, I think, about 5 to 6 minutes already. The panelists will make an opening remarks, 5 to 10 minutes, each of them. You can give little more introduction about yourself and your organization, and, tell us how you think from your perspective, your organization or even the bigger ecosystem, whether it's ready for this, massive challenge ahead. If not, what else do we need to do? So that is the first part. And after that, for another next 30 minutes, I will be asking a few questions to each of the panelists. And then we will open up the discussion for audience question in the last 45 minutes or so, right? So it's a total of 2 hours panel. I hope we will keep you really excited and interested, because 2 hours, 120 minutes is a very long time. So with that, maybe we can start with Deeptin, if you can give your perspective. Yeah.
Good morning, everybody. All the dignitaries, all my fellow eminent panelists, and esteemed professor or moderator, Mr. Bhatt. It's really honor for us that to be a part of this panel discussion for this setting up large-scale semiconductor fabs in India. And we are really grateful to IISc Nanoscience Department for inviting us. So just to introduce myself, Deeptin Kundu Chaudhary. I am the Chief Technology Officer from Avant-Garde Clean Room and Engineering Solutions. Brief about our company. This Avant-Garde Clean Room and Engineering Solution, the company formed in 2010, is one of the leading EPC company who serves the niche product domains, niche market domain of pharmaceuticals, biotech, foods, beverages, FMCGs. And coming back to this similar type of trades, what we are talking in this forum of the semiconductor, we are into this solar photovoltaic cell and some of the integrated manufacturing facility of ingots, wafers, cells, and modules, where we are doing a couple of projects for solar cell manufacturing facility that clean applications and HVAC and other mechanical and electrical utilities. And also we have started our foray into this semiconductor, not in sense of the fabs, but in terms of the electronic component manufacturing, who are doing the contract manufacturing for high-end iPhones and other products. So that is the brief about the company. And if we want to talk about a little bit of our accomplishments in past 1 decade or so. So we have done one prestigious project for an integrated vaccine complex projects at Chengalpattu near Chennai, which was Ministry of Health projects, which was having an integrated campus of having multiple vaccines. When government wanted to make their own campus, initially they were doing all these, some selected manufacturing units of serum and others. So that was one of the projects. And the most challenging time during COVID time, we did one projects for one of the contract manufacturing of Sputnik vaccine. So that was also one of the achievements. Our few other achievements was we set up one very large scale mechanical utility, chiller utility plants in Bangladesh. And also the solar cell projects for 2 gigawatt cell line for one of the leading companies in India. And also we are doing 2 gigawatt cell line and the module line for another 2 gigawatt line for the another companies and couple of other electronics applications. So we are just waiting for the market to be ready. So when we can engage ourselves in the true sense large semiconductor fabs, for which we are waiting for last 2 decades. I think now, should I continue?
You have some more time.
No,
if you want to.
regarding introduction part, I have explained.
Thank you very much. And Tata is from Tata Power. Please go ahead.
Yeah, good morning, Professor Raghavan, Dr. Reddy. Glad to be here. I think for us, IISc has a very deep connect to Tata's, and we know why. And it feels great to be here. I've been long since we've seen our children come here for various events, and it feels good to be here. Along with panelists, I think if you can play, I have a small video on the corporate, which you could perhaps play if it's not too much. Yeah, thank you. So as a business, we are a part of Tata Power. So early days, Tata Power, pioneers in electrifying the country. Of past few years, the stress on renewable energy has caught up. So we now have a vertical within Tata Power called Tata Power Renewables. And of Tata Power Renewables, Tata Power Solar is an organization. Tata Power Solar has been in the business of photovoltaics perhaps for the longest period, not only in India, but anybody closer to here, because we have been in this business for close to 3 decades. And we have been manufacturing cells and modules for more than maybe 2.5 decades now. I myself have been with the organization for 2 decades. So it's been a long journey, and we do understand the pains of coming from where we were in a 500 meter square clean room to where we are going, maybe 60, 70,000 square meters of clean room areas. And the challenges, it is not the ecosystem, but for manufacturing, what is required is what we should be talking about, right? More than just the fabs. So there are a couple of things that we learned on the way. I mean, we started a journey where some of the machines were not even there. So you have to build your own machine. Pretty much like what maybe you do in your labs, professor. Some of the machines we did build, and in those days, there were no standards. So we grappled standards, and we were lucky to have a partner who was from the US and could bring in a lot of technology and standards and stuff like that. And over the period now, as the industry has grown, I think somewhere the pain point that we have seen in the growth, I'd say, is where we got taken away by our neighbors in the mass scale progress of this industry. From an industry perspective, especially for semiconductor, we know why it's so important and how much of our forex is being dependent on it. Every day we get up and the first thing we see in the newspapers as business people is the forex and the value of our currency versus what we are going to pay when we buy stuff from outside this country. And that I think is the biggest pain point that all of us have today in business. And I think that is the biggest pain point also for this country to bring down our spend in a foreign currency. And that is where semiconductor pitches in. It's sort of a game changer. If you could develop the ecosystem in this country, if you could do, if not all, cherry pick what could be done and cherry pick what could be the vital few that can take us beyond what we are doing today. That is what I think is we are here to share about. As we go today through the next half an hour, I think we can share a couple of things that I'd like to share, especially at academia, is in the early days, what we did, I think something that you can replicate here at IISc is, I do not see what earlier days, let's say what NREL used to do with industries in the US, is not something that we are doing with IISc Bangalore today. Like I don't see IISc Bangalore giving out, they don't have this partnership with industry, because you might not be able to buy the whole infrastructure here, correct? You might not be able to resurrect the whole fab here, but a part of the job, what you want to do can be done by the industry. And you could have an academia industry partnership. So that is one thing that can be done without any intervention of the government. And those kind of programs, the more it happens, the more it will benefit both the academia and the industry. On the larger ecosystem, we'll speak as we go around, but happy to be here and like to contribute to today's session and learn from you guys. Thank you.
Thanks.
There is a small piece of video which I'd like the team to see, because this is what fabs today are at the world-class level. If you can play that, it would be great.
Oh, okay. There's one more video. Okay. Yeah.
It's a complex superhighway most of us have never seen and will never travel. It's more than 27 miles of multi-level thoroughfares on which 1,700 autonomous vehicles shuttle Intel's most precious cargo. This is the Automated Material Handling System, or AMHS, Fab D1 in Oregon. Intel runs overhead transport systems like this in every single one of our 6 chip fabs worldwide. The boxes you see scooting along are FOUPs, or front-opening unified pods, which carry as many as 25 wafers on their weeks-long fabrication journey from blank silicon disks to wafers, each containing hundreds of Intel chips. Let's take a closer look at Oregon's wafer superhighway that connects 9 buildings, including D1X and D1D factories. These two factories together are about the size of 12 American football fields. 24 hours a day, 365 days a year. Foods start, stop, swivel, turn, lower, raise, load, and unload. Every hour, the 1,700 move at least 16,000 times. They take wafers to the manufacturing tools that create the interconnects, the metal layers, and the often billions of transistors that comprise a single Intel microprocessor. The 200-pound pods travel at about 7 miles per hour. This is a master brain, an air traffic control center minus any humans. It makes sure each food stops at the right tool at the right time. It sits in the data center just outside the factory. AMHS engineers loaded with algorithms transmit directions to over 100 smaller control centers scattered across the RA factory complex. This tool, called a train, is 48 feet long and is equipped with two 28-foot-high robots. The robots move back and forth on a track and use their robotic arms to grab foods scheduled for departure to the next tool. The train is large enough to seat about 1,000 foods. Many of these tools, including the train, were designed by AMHS engineers to store and transport foods more efficiently. What engineers design, deploy, and learn here in Oregon, because it's a development fab, as well as a high-volume manufacturing facility, they transfer and share with other AMHS teammates in our factories around the US, Ireland, and Israel. The worldwide AMHS team lives by the motto, the heartbeat and blood flow of the fab.
So here the idea is just to show you guys that look not very different, right? Some of the things that you heard, and as we discussed, something I like to refer to solar as a poorer cousin of the semiconductor fabs. So a lot of flavor exists, so we can be assured on that front. Thank you.
Yeah, thanks, Mr. Raghu, for that introduction. May I request now Mr. Das to present his experiences and how are we positioned?
Thank you. Yeah, thank you, Professor. Good morning. Yeah, it's a great privilege to be here today with such a great conference. You may find me a bit, out of the track guy to be here. Being from a background of pharmaceuticals, but we do work with a lot of clean rooms, which is I'll say the previous step of fabs what we are talking about. So about me, my name is Rajendra Kumar Das. I'm the Vice President and Head of Engineering and Projects for Sun Pharmaceuticals. Sun Pharma, I hope many of you heard the name. So we are the #1 pharmaceutical company in India and 4th largest in world. And we have around 40 manufacturing facilities across the globe. As part of our development, research and development, we closely work with IISc for different initiatives, and so that's the reason my colleagues were connected, and I got this privilege of being here today. Being a mechanical engineer from start of my career, I'm continuously working in clean room, building clean rooms and constructing clean rooms for pharmaceuticals. And always I found myself jealous about one thing, like whenever I refer industry which better clean room than pharma, so it always comes the semiconductor. So it is always a thought like, okay, there is something which better than us, like in clean room environment. And that's another reason I'm very happy to be here today. and share my experience on clean room and fab, and it looks very interesting. But till the time COVID came and the whole semiconductor supply chain disrupted, as a normal citizen, never realized the supply chain of semiconductor in India and how it works. And but when we started facing problem, like even if any project we manage in India, other than semiconductor, I think everywhere today the chips are going. And when we found the supply chain disruptions, then we realized how important it to have semiconductor supply chain built. And India as a country being self-reliable on semiconductor. So though today we don't have a fab in India, I'm confident with the type of focus coming from last couple of years and type of engagement happening between institutions, government, and the corporates. Very soon will be leading this path. If you'll see, as a pharma, India is leading the world. So India is being called as the pharmacy of world today, because almost 20% of generic medicines are being manufactured in India, and pharmaceuticals is one of the leading export component for whole Indian foreign currency earning. So similar way, I think with increased focus, semiconductor is going to catch up, and we are going to have a great years ahead. Coming back to clean rooms and fab, of course, pharma have a leisure stringent requirement as far as specifications as concerned, but pharma is growing at the rate of almost 10 to 12% year on year. And there's a lot of manufacturing facilities are coming up every year. So today we have around 10,000 odd pharma companies in India, and there is 30,000 plus facilities. Each pharma facility contains a clean room. Of course, as I told, it's not that stringent as that of a fab needed, but there is a background to it. So my colleague from Avant Garage, they're in the panel, they work very closely with us. They continuously work for pharma clean rooms. And the only thing is that, again, within pharma also, there are different layers of clean room requirements, depending on the dosage forms. Like when we manufacture solid orals like tablet capsules, the type of clean room we need is different. When we manufacture something which is inhaled, the type of clean room we require is different. But when we manufacture something which is injectable, which directly goes into the bloodstream, so there the requirement is highly stringent. So the clean room which required for the injectable manufacturing is, I'll say, somewhere in the starting point of semiconductors. So, and another difference between semiconductor and semiconductor fab and pharma clean room is more of a on the cleanliness point of view. When we talk about fabs, we are talking only about the particulate matters, the non-viable particle matter. But in pharma, we are talking about microorganism as well as particulate matter. So though those are interrelated, but in the higher end of the pharma clean rooms needs nil microbial contamination. So, so as far as pharma clean rooms are concerned, and supply chain and fabrication is concerned, there is a long way we have came across, and we have improved a lot with over the years, and with a lot of stringent requirements and new technologies coming in. Similarly, I think going ahead, the whole clean room industry and fab facility in India can, pharma and semiconductor can complement each other and go further. Thank you.
So, Dr. Sunita Verma, if you can hear me, if you can come in and give your perspective, you've been instrumental in running the SMDP program, which has done wonders for chip design ecosystem. And now, the Nano initiative and the bigger scheme of IISm itself. If you can present your views, that would be excellent.
Yeah, thank you. First of all, very good morning to everyone on the dais and after dais, the dignitaries there. My apologies for not being there personally in person due to some commitments. And I'm at present heading the R&D activities in electronics and in IT, besides looking at the National Language Technology Mission also. And in the course, I have been associated with the various sectors of the ministry. But there are a lot of activities which are going on in the ministry on the e-governance side, digital electronics, digital payments, and other facilitation for the masses. But I'll restrict myself to the semiconductor since this forum is for the semiconductor ecosystem. So in the semiconductor ecosystem, I think we have been working for last 30 years on the various sectors, that is right starting from the skill development, that is various programs we have for skilling or for capacity building. The chip to startup program, which is now in its 4th phase, where we have training manpower on various institutions for design. It started with around I think 17 institutions, and now we are at 100 institutions. We are targeting 100 institutions with 85,000 manpower, which will be skilled in VLSI from end to end, right from ideation up to the fabrication of the design by the students. And in that, we are giving them the EDA tools and fabrication facility also, some FPGA boards, and mentoring of the faculty and the students. And another program that we have is for the INUP, the National, the Indian Nano Users Program, which is under the Nanoelectronics initiative, where wherein we had earlier 6 nano centers had been established at various IIT and IISc. And using these facilities, the training on the nanoelectronics perspective is also going on. So this is another very good initiative where we are only looking at the capacity building, but also supporting the startups ecosystem. We want to bring the industry and the academia together for research. So this under the C2S and INUP, these are 2 initiatives where we are trying to make this possible. Besides the capacity building, we are also looking at research, R&D in various sectors. So microelectronics or semiconductor is one of them, nanoelectronics, then medical electronics and health informatics, system design and applications. So material research. So all this research is somewhere leading to the growth of the ICT sector that we are looking at. Besides research, we also have some dedicated schemes for startups, where the startups are supported through the accelerators or incubators. We have the Mighty Startup Hub, or we are coming out with another program, Genesis, where the startups would be supported to a various degrees and for scaling up the technology readiness level in the different areas. And also hand-holding, mentoring them for taking their technologies up to the products to the market. Various initiatives have been taken by ministry. Ministry itself has specific initiatives in the ICT domain. Then with the startups, then now the focus has also, earlier there were some initiatives for inviting fabs in India for manufacturing. Now, under the ISM, the India Semiconductor Mission, we have now consolidated all of it to develop a complete ecosystem where the chip to startup program is for research and capacity building. There is another program for startups, that is for Mighty Startup Hub is there. Under ISM, we have initiative for for inviting the fabs, major mega fabs in the country. And then for compound semiconductor fabs, the display fabs, then incentives are there also for the OSATs and ATMCs. And finally, for upgrading of our semiconductor lab. So these are some of the components of the ISM that that are covered in the $10 billion scheme, which has been announced recently by the ministry. And this is to actually look at the complete ecosystem so that there are no gaps as such left in wherever the efforts are required that can be done to be initiated to complete the to make it happen. So in a big way. Besides the $10 billion initiative that we already have, as Professor Navkan Bhatt was also telling in his opening remarks regarding the various other initiatives that ministry has for production and capex linked incentive. We have the SPEC scheme for passive PCBs, for sensors, ATMPs. And also for the sub-assemblies, we have the production linked incentives, where it is a capex linked incentive for various sectors. And also for finished goods, we have a production linked incentive where for mobile phones, tablets, servers, laptops, automotives. So in overall, there is a $30 billion incentive given under the various schemes of the ministry for the complete ecosystem and enablement in the semiconductor electronics domain. Regarding also, I would like to tell about the other initiatives in the ministry, which are actually also very, I'll say, in sync with what is happening in the globally, because after the semiconductor shortage, the scheme was announced. So this the semiconductor ecosystem or the ISM is unique in a way for us, because earlier it was just the fab incentives or for the display or for some ATMPs we were giving incentives, or for the components kept scheme, spec scheme. This time we have brought all of them together so that we get a very clear perspective of where we want to be to complete the ecosystem. And if we look at the objectives of ISM, it is with a vision to build a vibrant semiconductor and display ecosystem to enable India's emergence as a global hub for electronics manufacturing and design. And the perspective or the targets that we have is enabling a multi-fold growth of Indian semiconductor design industry, and also enabling cutting-edge research in semiconductors, formulating a long-term strategy for developing sustained semiconductor and display manufacturing facilities and semiconductor design ecosystem in the country, which is in consultation with the industry and academia all coming together. So ISM is not, we can say, just a government initiative, but we are closely associated with the stakeholders. We are looking forward to actually close consultation with all the industry associations, the academia, to build a vibrant semiconductor ecosystem. So this is briefly from my side on just a brief introduction of METI Semiconductor Initiative. We have a lot of more initiatives which we can go on the website and see for ministries, other initiatives, but I'm restricted to semiconductor. Thank you.
Thank you very much for that, great perspective from the ministry. So let's now, begin the, some specific questions. So my first question to Mr. Kundu, in your opening remarks, you did mention about various clean rooms that you had set up, in particular the vaccine centers and pharma. and maybe some semiconductor clean rooms also. But when we are talking of large scale fab, it's really, we do have fabs like Semiconductor Complex Limited, now SEL, Dr. Huda is here, and we also have a couple of other fabs, GATEC and all that. But now we are talking of really big scale manufacturing, wafer starts of the order of 30,000 per month, that kind of a scale. Do you think we have expertise to build such fabs in the country? Or do we have to acquire even those expertise to build such fabs?
So thanks for the question. Just to start this answer, see, if we split this whole systems into the multiple aspects, like first stage comes with the concept design, that the basis of design. So if it is in that terms, perhaps that skill set is not there if we talk about the large scale semiconductor fabs. Now the next stage, when this block flow diagrams and then PNIDs and schematic flow diagrams, those conceptual things and detailed facility utility matrix are developed. So there also we might need the global expertise. The third stage, when it talks about the detail engineering, yes, in India, we are having that skill now. So provided the other two are in place, like the concept design and the basic designs is done by the global peers, like companies like Bechtel Corporation, Flood and Hill, Excite. So the third level, what we are talking about, that infrastructure is presently available in India with lots of companies, those who are tech-enabled companies working on 3D beams, and they are having the CFD analysis platforms and a lot of tools, software tools to do the detail engineering to make the back-end design. So I can give you my perspective when I started my career with Development Consultants Limited, which was purely a consultancy firm who did the detailed engineering part for the semiconductor complex and GATEC, where the principal engineering was done by the global peers like Anderson, de Bartolo-Pan and CRSS Serin. So similar fashion, the detailed engineering can be done by the Indian companies. And when that detailing works are done, like the tender drawings or GFC drawings and the complete detailed layouts in 3D Revit model, then comes the question of the execution. So when it comes to execution, that EPC companies, there are a couple of good Indian EPC general contractors are available, like Larsen & Toubro is there for instances. Tata is one of the Tata projects. So likewise, those kind of companies, when GCs are on board, so they can take the domain expertise in the specific domain, because if you see a large semiconductor fabs, which comprises of different subverticals, like there is clean room envelope system, that is the clean room panel system, access flooring system, ceiling system, then HVAC, that heating, ventilation and air conditioning and general utilities, chillers, UPS, electrical from the transformer side, DG side. So that can be undertaken by the different subcontracting companies. Like from our companies, from Avantgarde, we execute the clean room envelope part and the HVAC part and the utilities part and the electrical part from the pole to point, and couple of the low voltage systems. Yes, there are few packages like specialty gases, specialty chemicals. So those places, I think some expertise, and in some cases the global expertise, teams involvements are required. But when it comes to the bulk gases and other non-critical areas, those areas can be well taken care by the Indian companies. Now, this type of high-end semiconductor clean fabs, which requires, I think, the clean room envelopes and the clean room internals is a major part, because you need to have a very high grade of clean room to the tune of class 10 or even class 1 as per Federal Standard 209E, if you talk about the old concept. So that requires a specific design in terms of the design philosophy, in terms of the construction of materials. So those ecosystems are still not there in India, because we have been instrumental in setting up a small scale fabs, you can call it a mask fab line at solid state physics lab. So even those days also we had to import the entire things. And even the today also the scenario is same, because the specific requirements of a semiconductor fab is somewhat different from the traditional this pharmaceuticals, oral solid dosage, or the sterile facilities, because here the products need to be electrostatic, and then if there should be static electricity should be controlled. It should be non-particle shading. There should not be any outgassing. The photosensitivities are of great importance in this electronics fab, like for the photolithographies and other things. Vibration controls is of a paramount importance, which requires lots of specific design, because your lithography machines or the mask aligners, that's required a separate piling. So those type of design skills and sets are possible is not there. But yes, once that detailed drawings and other things are in place and installation guidelines are there, and government gives some good incentives in the importing of this clean room envelope system, because till today, if we talk about the clean room envelope system, that aluminum honeycomb panels or the ceiling level, whatever items are required, like terminal HEPA filters or ULPA filters or the fan filter units, those things are still not there that much, because for pharmaceuticals and for other application, we can still go away with this GI powder coated, but for the semiconductor, it requires very specific applications. So those ecosystems are not there, sir. But yes, installation techniques, that skills are there with the help of the global suppliers representatives. So that is how we can execute these fabs. And then now when it comes to the other part of the systems, like these tool hookups, the commissioning, validation, there also, I think that skill set possibly is not there. So there also, we require that support from the global company and the actual tool suppliers representatives involvement, which will give us this on ground, that training part, and that technology transfer part is very important.
Thank you for that detail. So Mr. Raghu, you made a very interesting comment in your opening remark, and you said solar photovoltaic fabs are poorer cousins of CMOS fabs, right? Now, but there are also a lot of similarities, right? You need to run this fab 24/7. You need all chemicals which are of high quality, high grade, and yield is paramount. Of course, you have larger panels as opposed to wafer sizes, but maybe, the complexity and the feature sizes are not as stringent. So what do you think, based on your experience running a solar fab, what can we learn from that, and how can we sort of, get prepared for the CMOS fab?
Yeah, a couple of things. If you look 10 years from now, the amount of silicon that was being used for semiconductors was much higher. And if you go to the genesis of solar itself, we used to run solar with rejected silicon. Today, solar uses more silicon than semiconductors. That has been the game changer. So solar has grown into space where we can now produce our own metallurgical grade silicon. We make the sizes are still the same. We're still working on 210. Intel works on a 210 size chip. Solar has come to a 210 size chip. But here the 210 is one device. Intel there might be millions of devices from the 210. So what we can learn is fundamentally, like our panelists is saying, that the lower level things have to be upgraded. Of course, some of this abilities are not there. The ecosystem is not there. But what we can learn, or what I can share, is in 20 years from what we were importing in terms of chemicals, today we don't import chemicals. We have been able to bring that ecosystem in India. Of course, it will also depend on the agility of the industry and the participation, because any manufacturing, the main and the most important thing is bringing the supply chain up front. So if you want to prepare for the semiconductor ecosystem, you have to identify that part of the supply chain which you can develop, which will be in some nascent stage. Chemicals, you can do it. Chemicals definitely is a game changer. Specialty gases, he mentioned. Specialty gases, of course, bulk gases, you don't have a challenge. Specialty gases, you might have a challenge. Even a simple gas like ammonia today, we are not making it to the grade of purity we need it. forget what semiconductor needed. So those are the areas where we are there, but we need a little push to go there. So that can be done. So in terms of the ecosystem, in terms of gases, in terms of chemicals, it can definitely be done. Now the bigger question is on the other part, which is the most important part of the wafer and the wafer fab. Of course, that is a long way to go and it requires a lot of investment. But having said that, I think the focus has to be on building the supply chain infrastructure before you get in the fab chain.
Thank you. So, Mr. Das, I'll come back to this pharma industry. You've been with this industry for more than 2 decades, as you mentioned. Whenever one talks about semiconductor fabs today, there are a lot of naysayers. Even those who are hardcore semiconductor people, they say that we should not get into the fabs, right? We should just focus on design. We are leaders in that. We just tape out the designs elsewhere and, get the chips made from outside. Perhaps even for you, when you are getting in this area in pharma 2 decades ago, there perhaps was a lot of naysayers. So what was the barrier? How did you have to sort of convince and go over that barrier? And looking back, what are the lessons that we can adopt and maybe, convince these naysayers in semiconductor industry?
Thank you, Professor. Very interesting question. And I can share a few of my experience in managing clean room projects. I remember today in clean room, Mr. Chaudhary spoke about the clean room envelope, the construction material. So we have in and out for pharma clean room or ISO 5 clean rooms. So we have a lot of options today. So if you go to any city, major cities in India, today we'll find manufacturing companies doing it. I remember around 20 years back, there was no one in India. We used to import it from Dubai, UK, and countries like that. And you have to do detail engineering, give detailed specification, and you have to import a container, get it here, install it. If you need a piece of 1 inch, you don't have a choice. You have to wait for another couple of months to get another piece to fix it back. So many people was not interested to go for a modular clean room concept because the technology or the supply chain was not available. And working with people manufacturing a construction material in a different time zone in some other country, interacting with them, sharing the CAD drawings, giving approvals, and getting it here in India was a nightmare. I remember in one of my projects, I finalized a drawing which is 22nd revision, and when I got the container here in India was the revision 0, which was manufactured in UK. So at that point of time, it was a disaster. It was a small project, but it was a disaster. Your timelines are going to hamper badly, your commitments are going to fail, and then that give us a thought, why not making it here? So though as a company, as a organization, at that time I was not part of Sun Pharma, I was working for a different pharma company, but the thought came, why not start manufacturing clean room partitions in India? And I'll proudly say the company got engaged, got technology, started manufacturing. That company is still running today and is one of the leading clean room contractor, EPC contractor today in India. And there are a lot of options today, and that continued. So there are another company who is to give a specific material, construction clean room material, which was from Dubai. We used to import them. We used to, if we need to do any changes, any modification, any on-site alteration, you need to depend highly on them, and you have to request them. Getting things done was difficult. So I was part of a initiative engagement with Indian company to develop it indigenously, and I'll proudly say today we have around 4 or 5 options in India to manufacture such things. So in my opinion, it is not difficult. Only thing it's more of a mindset and type of vibes. What I got, the type of corporates getting engaged with semiconductors from last couple of years. The horizon is not far. I see very soon India will have a fab. Just out of curiosity, since I was coming for this session here, I was just browsing through, and I found a search result saying that Karnataka is going to get the first fab in India. So, so I was happy and proud to see that, and I strongly believe it is not far off. Even for pharma projects, we got today also, as Mr. Chaudhary and my other colleagues spoke about supply chain, getting material, getting specific chemicals, specific components. Yeah, today also for my projects, I do get sometimes for a critical project 60 to 70% of material from outside. So we do depend on imports, but it is very much possible to have alternate and start developing them internally in India and start producing them. So initially it might be little challenging, but once we'll start making it, it will be definitely going to happen. And it is difficult, but it is not impossible. That's why my belief is.
Great, thank you. So Dr. Sunita, based on what the panelists have just mentioned, I see that there are two important points that are emerging. One is that, if you want to set up the semiconductor fabs of large scale, there are still a lot of materials that need to be imported, right? And, in that context, what is Ministry of Electronics doing in order to enable ease of doing business as an ease of doing imports, for instance, to begin with? Are there discussion with Ministry of Commerce? And, that is one aspect. And in a longer term, a lot of these materials and, the chemicals or gases, what have you, should be created and manufactured within the country. Again, here, I think a lot of interministerial dialogue may be required, maybe, with Ministry of Petroleum and Chemicals, with Ministry of Heavy Industries. So my question to you is, are there a lot of interministerial dialogues going on in the context of Indian semiconductor mission?
Yes, Professor Nakkan, but Ministry has been actually taking it up in a very proactive way. It is not just that after the announcement, we are waiting for the fabs to come here. It is very important to build confidence in the fabs which are invited in the country, to tell them that, yes, we have the wherewithals or the complete facility, the environment for them to set up a fab. And the raw material, the supply chain is a very critical part of it. So starting with the land identification, that what land has to be given in which state, and talking to the states and getting their availability of land, right from Dholera to maybe Andhra or Karnataka, all of them. We are also looking at what we can give them in terms of custom duty or and also regarding the supply chain, we are also looking at the suppliers of the raw materials, the clean rooms, and the various industries which are already in it, or some foreign industries, companies which can come and start their facility here. Besides this, yes, the ministry is very closely in consultation with the Ministry of Commerce, DPIIT, and with the MEA, with the heavy industries for any requirements or any hiccups that which might be there. We are closely, very closely consulting with all the stakeholders for what is the requirement, and then getting back together, all the ministries are getting back together on how that can be facilitated. So and there have been series of these government to government engagements. It's not one time. So so as to say, see, when we had floated under the ISM, the scheme for compound semiconductor, where we had said that 30% of the incentives will be given. So with the stakeholders consultation, we have increased it to 50% of the incentives. So it's not that, and we are also open to the idea from the companies and the other ministries on what needs to be done. So I think from that point of view, we are ready. We are engaging with partners, talking to the technology partners also. When we have, so we floated the expression of interest for expanding the existing semiconductor wafer facilities. That was in March 21. And then inviting the EO for setting up the LCD, OLEDs, AMOLEDs based fabrication units. That was also then, that was followed up by promotion of the stakeholders engagement. So right from the awareness up to the facilitation, ensuring that whichever fab comes up does not face much of a, but having said that, the first fab which comes in would always have that teething problem, because after that it will be easier for others when they know that the supply chain is already built up, or the incentives which are there, that they can see what the incentives are given. And if we compare what the offerings are of for the fab setup by India compared to other countries, I think we have 50% incentives which we are giving on pari passu basis, and on top the state government is also giving some incentives along with the different incentives of capex under our various other schemes, which comes to amounts to around 70% of the incentives for the total amount of capital. And then I think that is something that we have worked out in consultation with the Ministry of Commerce and with heavy industries also on what incentives or what wherewithals are required for the complete system.
Thank you. It's very nice, heartening to know that there is a cooperation between different ministries. And I think that will really be a great enabler going forward.
One point I think I missed out was also on the skill development. So it's not only, which is a very important resource, I'll say, for any industry. So for setting up the fab, this was an important point I missed out, that for the skilling is one very important part, where we are closely working with Ministry of Higher Education and skilling also. For right from level of technician researchers, we have the expertise developed for manning of equipment, for the taking up IPs research, and process and research to enable the growth of the fab. So whenever the fab comes, we are ready for that.
Thank you. Yeah. So Mr. Kundu, we have been hearing a lot of announcements, Vedanta Foxconn in Gujarat and ISMC in Mysore. But do you see anything happening on the ground? Are you getting some, expression of interest request, some other feelers to, get going on this on the ground? Anything happening?
As per this ISM's recent this Philip what has been given, subsequent to that, couple of announcements are there. So we will just tell a brief about that. So first one was that Vedanta and Foxconn, which is a 60-40 joint venture, where the technology partner is there, and then the financial part is taken care by the this Vulcan group, which is some holding companies of Vedanta, and where technology partner has been introduced as ST Microelectronics. So they are aspiring for this 28 nanometer semiconductor fabs, and also the display fab part of also there, the OLED and AMOLED, and also that packaging facility that is under that, which is possibly going to take off the first part. followed by the other one, which is the ISNC, which is a venture between Tower Semiconductor, which they are bringing the technology part, which is now under Intel. And along with this Next Orbit Ventures is the Abu Dhabi-based fund managers. So they are there. So that possibly formal announcement is yet to come. Coming back to the third one, which is IGSS Ventures, along with this Rajesh Exports, which is possibly slightly lagging behind, with still some technology partners is yet to be finalized. So these three are the major budgets which are going on. And the fourth one is the recent announcement of some SOPs will be given to the semiconductor complex to the tune of 1.25 to 1.3 billion US dollar to commercialize that up to the 28 nanometer fabs. Now coming back to the inquiries level for the GCs level or as a subcontractors level like us, yes, we have not still got that. But one more thing which I want to add up, which perhaps not much of the media announcements are there, that is one IDM, that Micron, they are possibly going to set up facilities. So for which some working on ground has already started. And some of the GCs are already bidding. So that is one good step, like governments are should try to attract these IDMs, because when we talk about the fabs, I'll just tell a very brief about these things. So what are the subcategories and whom should be attracted so that it will be a reality on the ground. So first is this fabless chip designers. So they are basically don't have this fab of their own. They just get it contract manufactured outside. They do the design part. Then comes the IDMs where this Micron kind of companies are there. Like this, typically for these IDMs, there are basically these subcategories like memories, like this analogs, this kind of features are there. So this, in terms of the memory chips, this Micron possibly might get landed much before this larger scale fabs, what is being discussed. And then the foundries. Now India may not get the foundries immediately like TSMC or Samsung kind of things. But yes, if IDMs can be approached now, so those things will be possibly coming up in India even much faster than the fabs, which is under discussion. And as regards this fab, the timelines, what has been announced so far, what I hear from the media, that possibly the Vedanta Foxconn has set up a very, very ambitious target of 2 years, which is very, very tough target compared to the global global benchmarks even. Forget about the countries like Singapore, where possibly they can afford because of the fantastic ecosystems developed. They talk about 13 months to 15 months for setting up a fab. But if you really see the global level, it takes 3 to 4 years. And then resulting the yields might take another 3 to 4 years. So possibly the time span is 8 years globally, where Vedanta Foxconn on paper has shown about 2 years. So let us hope some tenders will come because the technology partner is in place. So possibly the main engineering consultants will be also on board, and possibly will be also started getting involved gradually. But yes, as I have told, IDM from the IDM side, I think much more faster response might come, as Micron is already coming in the state of Gujarat near Sanand.
Great. It's good to know that Micron is also perhaps going to set up something soon, and I hope that you will start getting inquiries very soon. Mr. Raghu, Tata Group is an amazing group. Talk about diversity, anywhere they put their hands turns gold, right? So there are two recent forays are Tata Medicals and Tata Electronics, right? And Tata Electronics is set up in Hosur. Of course, they're starting with, making enclosures for electronic product, but Raja Manikam has been on board, with the successful Tesol, success story. So what do you think going forward? You already have this Tata Solar with semiconductor related activities, with Tata Electronics coming. Next 10 years, what is your prediction as a Tata Group? Maybe a loaded question, but nonetheless.
It's too big a question for me to answer. I can tell you that. I remember this question was asked to during the BP days, and Lord Brown was asked, what's short-term, long-term, and mid-term pricing of oil? He said, I can tell you the pricing, I cannot tell you the term. Okay, something like that. So, of course, group is diverse, group is focused, and the way it's going, I think sooner or later, what we are seeing or what we hear, because a lot of things happen very quickly nowadays. I think that is one thing that I've seen is change, and that is what I like about it, is things are happening faster. And we are, I think, looking at a scenario where in next 2, 3, 4 years, there should be forays. I would not be able to vouch on that, but the way it's going, I think there'll be forays into this domain. One point of the whole manufacturing piece, I think perhaps I forgot to mention, is while the ministry and the academia does a lot of work or talks about these big things, the design philosophy, the chip and all, there's a lot of small areas of pain which a manufacturer has, which is not looked into, which needs technology support. For example, any fab, even solar, you have a lot of water consumption. Then there's a cradle to grave process. Now, the Ministry of Environment will always tell you that you can't send a bit of water out of your facility, use facility. And the last bit of water management, you want to create a zero discharge, liquid discharge plant, you want to do effluent treatment plant. These are areas where still there's a lot of work to be done at the academic level also. While most of this work is done by the corporates, various corporates who do water management. But this is a good piece of work where you can find a sweet spot to bring in value to the corporates, and that will help. I do, you can correct me if I'm wrong, but I do hear about fabs in New York being put on plans and then being pulled away because water was not able to be managed. Right? So these are some pain points which you should be looking at. But on the Tata story, I think much more will unfold, because even as Tata Power, EV is a big subject today. So EV, motors, and electronics, we'll see something hopefully.
Certainly, in terms of management of water and other things, there could be a lot of things that can be done. And one very important point I may bring up here, the fab in sense actually uses STP water as input to generate the most clean water. And a few years ago, we had also made some studies when Karnataka government had asked. We had demonstrated that in Mysore area, if you do rainwater harvesting, that's more than sufficient for your fab requirement. I think a lot of very interesting things can be done. I hope there'll be a lot of closer interaction, as you said, between industry and academia going forward. Now that also brings to a last question for you, Mr. Das. Now that pharma industry is fairly mature, the clean room commissioning and all that, do you see a single window operation? Do you see a lot of regulatory hurdles even now?
There are, but there is a significant improvement. Of course, there are a few things could have been better. Just my colleague spoke about water management. So there are, if you go to abroad and almost all countries, for all industrial area, there is a central water management, wastewater management system. So industry need to focus on core. They need not have to focus on secondary things. But in India, it's a requirement, of course, for environment. It is very much essential. So, but if you say a semiconductor industry managing wastewater may not be a core subject, and it become a challenge for them to put resource there. So that could have been eased by central systems, what he was correctly mentioning. But as a company, if I'll say pharma, we be evolve with time. Now it has become like part of our project management to manage our own wastewater. I personally work a lot on water recycling and water conservation, and so there are a lot of technology has come, and as you correctly told, there are a lot of academia. I like from IT Mumbai, a lot of department work on water. They come with a lot of technology which isn't the thing. But in past decades or so, there are a lot of support coming from government. The government supports are very focused and very, it's my personal view, and the industry, especially for pharma, it has become easier to manage project in various, there are various state governments came with single window system, a lot of supports in terms of tax rebates and all. And if you see, there are clusters in pharma in different part of India, which has grown up. So that's because those state governments as well as along with the central government have worked closely with pharma companies. The SEZ was another very attractive scheme where because pharma was highly into export market, that gives a lot of leverage, and a lot of equipments, as I told you, during initial setup comes from outside. And so when you go for a special economic zone where the zone treats is tax-free and anything comes in, goes out, it become easier. So I'll say the government has done a lot, and with recent experience during COVID, there is a PLI for pharma. For API manufacturing. So we were dependent on for specific molecules and active ingredients is to depend on China. So with PLI coming in, so that gap is getting filled. So there can be a lot more can be done, but there is a significant support from government, both state and central government, to fill this gap. That's my senses.
So that's good to know. So before I open it for audience, Dr. Sunita Verma, just one quick question. A lot of people are saying all these announcements are okay, but when are we going to have a financial closure? Because unless they put in funds, they don't get reimbursed in capex, right? 50% will come as reimbursement for capex, right? Do you see any of these proposals coming close to financial closures? Because you are the one who is sort of evaluating them very closely. If you can give your perspective, that would be great.
Yes. So under the ISM, we have the design linked incentive scheme for the support of 100 fabulous startup companies. So startups. So in that, we already have around more than 100 applications which have been registered. And out of that, 23 applications have been received. 3 applicants have already been announced, and 8 are more in the pipeline. So around 15 are there in the DLI scheme to start with, and who will be we'll start dispersing the funds to them shortly. So that is with respect to the fabulous startup companies under the ISM. The second one, yes, the major part is for the semiconductor or compound fabs. So as I think already said earlier, Micron is one of the prospective companies which is coming and is setting up the fab here in Gujarat. So that is slated, and I think you'll be able to hear the announcement soon. We are in the process of finalizing on one of the fabs. So maybe by end March or first week or somewhere in April, we are expecting some closure there for the fab, major fab.
Okay, excellent. That's great to know that it's happening very soon. So now we will open it up for the audience to ask their questions. My request is keep your question very brief, to the point. Introduce yourself. Some volunteer will bring the microphone to you. I will just request you to ask the question. Yeah, please go ahead.
My name is Jaydev. I am a consultant for clean rooms and utilities. I was former AGM Semiconductor Division, Bharat Electronics. My question to Mr. Kundu. So he was telling apprehension on design of the clean rooms. Second is the construction. As you told, construction, a lot of materials have been imported. But my question is, we recently involved in designing a clean room 30 feet below the ground in Bangalore, in NMTC concept campus. That is CMT campus. This is for nanotechnology characterization as well as manufacturing. So we have a lot of design capabilities. But problem we're facing is that the raw materials required, like aluminum honeycomb wall panels, graded flooring, with ESD controlled surface, zero outgassing rate from the puff panels, not puff panels, but it's aluminum honeycomb. So if possible in India, for puff panels is to make ESD coating and to control proper ESD controls. Is it possible in India?
Thanks, sir, for your nice question. Coming back to the first part of your question, that capability, without undermining anybody or any consultants, when we are talking about the very large scale fabs, which requires this $1 billion of investment, we talked about that one, where a lot of technologies are involved, very complex tooling layouts are there. So on that perspective, we talked about the concept design and the basis of design. Till date, what we feel possibly there is some lacking. Even if we talk about the companies like Jacobs or the Flow, they might not be also doing indigenously. They have to take the support from the Portland office or from the backend office.
There is a fine tuning, like you're fine tuning the controls.
Yes.
And okay, so international level, if say we are able to design at least 80%.
Yeah, maybe let him complete, you know, go ahead. Yeah.
Because sir, with due regards, when you talk about the facility utility matrix, typically what you see in pharmaceutical, we call it as a room book. Possibly that ends up in an A3 sheet. But for a semiconductor fab where hundreds of the specialty gases are there, the horizontally, if you move, we possibly will not be able to take a printout. It has to scroll down from the extreme right end. There's so many aspects. Forget about the standard part of the HVAC utilities or uninterrupted power or the standard items. So there lies the challenges and the criticality part where we talked about the basic and concept design, the block flow diagram. But yes, we have already expressed that when it comes to the detail engineering part, yes, we are having that capability. There are a lot of companies where they are having that tools, sophisticated tools, 3D BIM modeling, they have the CFD analysis skill, and then PipeNet software. There are so many softwares. We talked about the very large scale, but when you talk about the medium scale labs and research centers, yes, that capabilities are already there. So for which you are already doing couple of projects. So possibly it will be the case-to-case basis on the what is the criticalities part of things involved, what is the critical tools are involved, that will govern whether it will be able to be done indigenously or we need to take the help of the tooling vendors or from the global side. Now coming back to the second part of your question, if we talk about the semiconductor fabs, as you know, as some of you might be knowing, that it requires a special type of material. The material should be dead material. When we talk about the dead material, this aluminum is one of the parts. And most of the clean rooms, the basic difference between a pharmaceutical clean room and a semiconductor fab needs to be modular, non-progressive design. Because today you are having one tool layout, which might be requiring class 100 facility. Tomorrow there is some technology upgradation for which you require to move the tool. So all the systems, the clean room fabric envelope systems need to be demountable and it needs to be non-progressive, localized. You should be able to take that. So the aluminum honeycomb panels, still India, there is not much supply. Now coming back to your question, the puff panels, lot of cases the puff panels are not internationally acknowledged because of puff is a toxic material, because of the toxic fumes generated. Even in pharmaceuticals also, a lot of customers, if you talk about the US-based customers or pharma, some flame-proof areas, they also recommend that Rockwool or other product, because puff part possibly we may not use for the semiconductor. Puff has got an inherent disadvantages because the panels should be able to shift very easily. Puff is inherently very weight is much higher as compared to the aluminum honeycomb panel. So we talked about the wall part, that is again imported. Another heart of the system for class 100 or class 10 clean rooms or even class 1, that access flooring system, which is the die-cast aluminum. Till today, India, there is no manufacturing facility. When you talk about the clean room sealing system, in many projects, you require a fluid seal sealing system where you require to put this ULPA filter or the HEPA filters. So even the tool development cost is so high that unless some special incentives comes or some large scale fabs are announced, possibly the Indian standard aluminum extrusion manufacturers who regularly supplies for some industrial applications or the pharmaceutical application might not be interested to develop those tools. So that is how we talked in the previous part of the session, that we are to a great extent depending on the global supply chain. Almost 90% of the products are imported from this global sourcing, either from USA, Europe, or for some part of the Singapore or Malaysia. So there lies the challenges.
Okay. Yeah, we need to go to some others. We need to give chance to others also. Yeah, over there. Yeah, please introduce yourself and ask the question.
My name is Kishore. I run a company called Global Marketing Services. I'm more into the semiconductor ecosystem equipment and supply to all the research labs in India. A couple of questions like to the ministry as the first question is about import of raw material. You know, let's say we need one of the basic materials like gold wire, and we are not allowed to import gold wire. It's under a banned category, and you know, to get for a license like for gold, we need to apply a license and takes time and expensive for small users. So we need to find a way to get this sorted out. We can ask the ministry, Dr. Sunita, if there's any way that we are looking to kind of look into this problem.
I was not able to understand.
Yeah, so what he's saying is that the question he's asking is, gold wire is an important consumable in semiconductor fabs, and he is a supplier. Actually, he has to apply for a license to import the gold wire. That takes a lot of time. Is there something that can be done with intervention from ministry? This is just one example. There could be many such examples, right? Where, silver, yeah, Mr. Raghu is taking the same is true with silver also. So can something be done to ease this whole process? That's the
Sure.
question.
I think sure. We are going to have, in fact, I'm part of that committee where we have to look at the ease of doing business for the fabless. So the similar way, we have another committee which is looking into the fab also. So I can give these inputs to them, and we can have a stakeholders consultation meeting to see what can be done. So those things, we are open to these, I guess.
So Kishore, you can put down those points and share it with Mr. Vasu.
Yes.
And we will include that in our summary. Yeah.
Yeah, the other point was about.
Quick.
Okay. The other thing is that, semiconductor equipment is capex, very, very high capex investment in terms of equipment and so on. And also this equipment requires a lot of spare parts and so on. And trying to, every time we need a spare part or something, you need to go, we cannot send this part back and get a new part. So when we buy a new part, we have to pay a custom duty, and it's very expensive. The machines are itself are very expensive. And then buying parts for that and trying to stock it here is also an expensive affair. Is there any way that we can try to reduce the way we can try to work around for the supply chain, and so that the cost of inventory can come down for operating these machines?
You want to take? Yeah.
So, Mr. Suresh, unfortunately, today India didn't have a solution for this. So, there are foreign companies who have franchises in India and they sell equipments. When we ask them to keep spares in stock, because of taxation and present taxation rules, it is not possible. It will be double taxed if it will be transited on that channel. So either the equipment owner has to keep, otherwise wait for the whole supply chain to execute, which will be a couple of weeks time for getting a spare, and machine will keep down. The point is very good, and if something can be done by ministry on this, will be a great help, not only for semiconductor. I think in all industries, whoever use imported equipment face the same challenge.
Mr. Raghu, you wanted to respond to that as well? Yeah.
I think it's very, very good question, because a lot of the uptime of all manufacturing fabs in semiconductor will depend on availability of spares. Right? Two things we have been doing traditionally is one is tying up for a long term of AMC so that spares can fly in quickly. So they have a spare location somewhere close by, let's say Singapore, and then you can access it in one day, you can monitor that. That is one thing we are doing. But like you rightly said, there has to be some policy on the spares. The support that you can ask government is whether you have some kind of a clause in the customs where spares can be stocked without costing them and can be sent back. That would help a lot. Having said that, it will not going to solve the entire problem, obviously, until you know what is going to fail when, which is the bigger piece of the puzzle. Do some AI.
Yeah. Ms. Krishnamurthy, please.
Good morning, sir. My name is Krishnamurthy from IISc. So I have two observations and then a question. First of all, IISc conducted a deep study last year on the supply chain of the materials required for a fab. 150 chemicals, 50 gases, and 30 plus minerals is what goes into a fab ecosystem, which is not FinFET node, above FinFET node. Below FinFET, I mean, 16 nanometer and below, it may be even more. And then we also found, to the credit of Mr. Das and their industry, 35 of them are used in the pharma industry in the country at different levels of quality, not still up to the level that is required for semiconductor fab. So working with the Ministry of Industry and Commerce, we have created a scaling committee, which is looking at these 35 first and see how we can up-qualify them so that when the fabs come in place, these are available in the country. And then, of course, the remaining 35, 36, 37 will start. And my thoughts go back to the very old days before Maruti started making cars in Gurgaon. That whole place was mustard farms, right? There was no Faridabad, there was no Gurgaon. So I'm sure the same thing will happen in Dholera also. The second observation is about the water. I think every time somebody talks, and I know I have faced this multiple times in multiple forums, the moment I start talking about semiconductor fab, I hope there's no media here because they are the ones who jump up and start asking questions on water. So I think we need to publish some white papers. Taiwan and Israel are smaller than many of the Indian states, and they have managed water in the semiconductor fab. So this is not a new problem to be solved. And I'm sure, I think Professor talked about the study they did in Mysore, how the rainwater harvesting can be used. So my suggestion is maybe we need to come together and publish some very clear white papers so that this concern goes out of the mind of the policymakers. Now my question to Madam Sunitaji, neither in METI website nor in Industries Ministry's website or Environment and Forest and Climate Change website, we find specifications for the environmental, the treatment plants, ETPs, right? What do you call ETPs or ETFs? I think we need to come up with some standards and publish it in public domain so that this will not become the next debating point or talking point. Now, if I do the same search in Singapore or China, you have it readily available. So water and effluent treatment, if we can come up with some standard model of design means specifications. So if you're going to do, I mean, yesterday we were searching it specifically for somebody who wanted to make 10,000 square meters of high density interconnect PCBs. What is the effluent treatment plant required for a plant of that capacity? There was no specification available anywhere in the Indian government network. And tomorrow we go and build it as per an international one, and then it does not get certified or qualified, then it becomes a big operational problem. So this is a request and a suggestion to the ministry, if this can be done. Thank you.
Thank you. So I think your suggestion is well taken. It is not there on the website, although the proposals that have come in on setting up of apps and other facilities, we are getting them evaluated ministry and with the Ministry of Environment and Forest both together. We are looking at all the parameters of the for being environment friendly and compliance standards are there. So maybe we'll pass on to the Ministry of Environment and Forest to put that on the website also. So there are very stringent norms, and one of the US apps that would be coming in is that it will be using more of green technology and will be more eco-friendly. That's what we want. That is the whole, one of the objectives of the apps. So we'll get it published on the website. I think that is something that we would require. But internally, we are reviewing all the project with respect to the standards that are available.
You also want to?
Yeah, so I think Department of Environment has a discharge norm being specified, which quality of water can be discharged to the ground, and and a lot of it's more of a state government has different rules. Some of the state government has come up with zero discharge policy, like all the wastewater being generated from industry needs to be recycled, reused, and nothing can be put back to ground. And if you're putting it in the ground, there is a norms like what are the parameter needs to be met. I believe in semiconductor, heavy metal will be a challenge, needs to be control and treatment and removed, which will be meet the specs. I think more fabs coming in, the system will be more mature slowly.
Yeah, before we take the next question, a quick announcement. I think some of you have signed up for 11 a.m. facility tour. So those can report to the front desk, right? Yeah, we can go to the next question. Yeah, please go ahead. Yeah.
I'm Dr. Krishnamurthy from Horiba and Alvac. Before my question, I just added to that point. We use that as an opportunity. Actually, mass flow controllers are very important, the important component, and going back and coming is a problem. So we convinced Horiba's Japan management to make a plant in India. So we'll be producing mass flow controllers in India. So sometime we can also utilize that as an opportunity to do something in India. But this question actually, I was not confused. I mean, I was confused whether it has to be to another panel, but because the solar cell and Madam is here, I had this common thread. See, one thing which is common between, apart from other things, is silicon wafers. And the solar cell announcement is very clear. They have to, the top tier one should make the silicon wafers here. And similarly, of course, all the fabs needs silicon wafers. And is there any effort by the ministry to upscale this silicon production in India, which is solar cell grade, to electronic grade? Of course, totally, it requires a lot of additional efforts to make electronic grade silicon wafers. But why don't a kind of a combined work happen between a solar cell industry and fab industry, so that is a focus point for the future?
So, Dr. Sunita, you want to mention anything from government side, and maybe Raghu then? Yeah.
Yeah, not that I know of any specific incentives for this, but yes, under the various incentives that we have, we are open to that idea. It is not that if somebody has a proposal for putting up this type of facility, we'll welcome that. I'm not able to hear you.
So is that correct? Is that a requirement for solar? Yeah. Yeah.
I think what Krishnamurthy is referring to is the fact that in the MSIPs or the SIPS, the qualifier for being the tier one is having a supply chain which begins from silicon, then you do the ingots, wafers, cell, and the modules. While in the semicon policy, I have not gone through the ISM, sorry, but what he feels is not articulated to that extent. And that's one part of it. The other part is, if not so, then could there be a proposal somewhere in the government where wafer manufacturing itself could be either for electronics or for solar as a separate pitch? Can we do it? That's I think, if I can ask.
Okay.
Actually, yes.
Yeah.
Sorry, ma'am. Yeah, there is a possibility of the scheme which has been flown by mighty Dr. Sunita Verma and his team, her team. That is actually, they have launched the SPAC scheme under which this task can be taken up front for supporting the wafer growth facility from nugget to the final wafer. It is on any wafer scale size, any material which is required for semiconductor manufacturing, even the MFCs or raw material or spare, that can be leveraged by that scheme straight away.
Okay. Yeah, go ahead. Yeah.
Thank you. My name is Simran and I come from the General Group. My question is, since goes into the equipment, we have a very concentrated supply of these equipments. So we have talked about the raw materials, we've talked about the design. What about the capital equipments? Is there some work around that, building that ecosystem? We heard in the news, that China now has limited access to the equipment, compromising its semiconductor industry. So how are we protected on those fronts? And if I'm permitted another question, a different question. So we say that, we are very well set in the design space and a lot of R&D in India. But how are we in terms of the IPs? Does India today hold those IPs? And if a fab comes up, the orders, the input orders for supply would be coming in from these design houses. So how do we get that from within the country today? We have a lot of end consumption today in India, but what about the ordering and the decision making? Whether is it happening from India?
Okay. So, Dr. Sunita, you want to take the first part of the question? Equipment manufacturing indigenously. That is the question for semiconductor fabs.
Yes. So yes, there is a special incentive that we are giving for indigenous development of equipment. So right from R&D up to the manufacturing, if there is any proposal, we are ready to take up. So the special incentives are there for this. In the R&D, under the ISM, we have around 2% of the 96,000 crore, which is for the R&D. These funds, around 500 odd crores or more, will be for manufacturing, will be for R&D related to anything for the fab. So for process, maybe equipment, for anything else. So I think we are open to that idea and taking it, and we do realize that indigenous equipment ecosystem needs to be developed, and that will be taken up. Second, regarding the IP, what she said, I think if we look at even any other fabs in other countries, it's not the IPs from that country which are looked at, the IPs or the fab is coming from across the world to the specific fabs. We should not be very worried about, loading the fab with our own IPs. So that is there. Having said that, we are also looking at how to, the DLI scheme that we have for the fabless startups is one of the incentives that is for promoting our own IPs, developing our own IPs, and but not per se for the fabs that will be coming up. So with our capacity building and the R&D initiatives, I think, and the semiconductor R&D funds that we have, so those will be channelized towards creating our IPs.
Thank you. Anybody wants to, add on or?
Time of these capex equipments, which actually adds up to the project capex cost, and the first-hand equipments like the global leaders like ASML, LAM, this kind of, so that might be a quite time-consuming and very, very capex driven. So is there any policy for refurbished tools to be incorporated in this kind of fabs with some third-party support? And what are the challenges for the third-party, this support and refurbishment instead of the first-hand capex equipment from the global leaders?
Yeah, go ahead. Yeah.
Thank you. Actually, the first question which ma'am was asking about the semiconductor equipment, over the night we cannot develop the ecosystem for manufacturing equipment for semiconductor process, number one. And number two, of course, they are the world leader who has proven in this market from long. And anybody who is establishing the facility won't compromise with the quality of equipment with the start with. the kind of a nature in which we are entering for manufacturing is a high-end process where you need to control the process up to the Six Sigma. But of course, there's government policies which are being initiated in a way. They are encouraging the people of the manufacturer to establish the spare part and consumable part designed and developed within the country to start with. Of course, if everything goes in the right direction, crossing our fingers, that may happen in near future. And we have to leverage the kind of a facility and policy to the world leaders who are the players to do this kind of establishment within our country. On the part of IP, of course, 97% IPs are held by US companies. And making them ready for load these IP in Indian foundry services or IDM is a big challenge, really. And that's what actually a bottleneck really in terms. But of course, there is a gear shift in that, which can be leveraged for at a starting point. And government has given the incentive to the startups to develop the IPs, which can be loaded straight away into the fab, depending on what market and domestic or global segment they are targeted for. On the part of semiconductor equipment manufacturing and a kind of a supply chain which we need to ensure, that is a quite high lead time available in that. And the lead time is directly associated with the kind of a nature how globally is turned up for making the fabs right now. People are talking there are 97 fabs are coming continuously, around the globe. And we have not yet started. So in the supply chain, we are at the lowermost. And it is not the way that we can start straight away today itself. It will be, delaying our, process of establishing the manufacturing fab in country. But sir, your point is well taken. And of course, that we have to think in which way we can make it successful for our country so that every bottleneck need to be addressed, need to be focused, and need to be solvable. That's what the approach we need to take. Thank you.
So I would like to give an opportunity for online participants to ask questions. Are there any questions from participants online? If so, you can turn on your camera and introduce yourself and ask question. Okay. Yeah. I can't see that. Oh, it's there. Can you read it? Okay. Yeah. Yeah. There is another question here. Okay. Is there any focus on packaging facilities? Anybody wants to comment on that?
But what we understand that
Yeah, I can take this question.
Yeah. Is there any focus on setting up packaging facilities? Have you got peelers? Yeah.
Yes, definitely. So again, one of the facilities that we are open to is for the packaging. And regarding, I think Jaya ma'am is sitting here. So regarding the skill development also, we are looking at various courses in terms of packaging. And with the, I think SCL also will be looking at the possibility of setting up some center for packaging.
Okay, thank you. So, yeah.
Here I want to add, I think under ISM, apart from the semiconductor fabs and display fabs, the third category where the compound semiconductor, silicon photonics, and OSAT and ATMP is also under the third category. So that there also, I think 50% on the capex. I think it is not on the total project cost. It is on the capex is already announced. So it is already there.
Yeah. So we can come back to audience in the room. Yeah. In the last bench over there. Yeah. Please go ahead. Introduce yourself and ask the question. Yeah.
Hello, everybody. My name is Ankit Tiwari and I am a project assistant at SENS. So my question is that now that we are coming up with fabs in India, so in the recent trends, we have seen that new materials, new processes are also coming up, which are showing much better efficiency in solar specifically. I work in large area perovskite based solar cells. So we have now we have achieved a single cell efficiency of 25, 26, and sometimes even 30%. So the question being that how people are these new fabs to actually incorporate the upcoming new type of solar cells that we are experiencing in the next 10 years?
Yeah, I think a bit of clarity on your question. I think looking at the efficiency and technology of solar cells and fabs, what you are talking about, technology that you are speaking about is a technology that will come in at a later stage. Solar cell fabs, when they come up, over the years have been a progression of technologies. Some of the same tool sets have been used, and in some cases the tool sets have to be changed. And this is from the lab to the fab, the journey is pretty long. Okay, so now what we are seeing, the latest prevalent technologies, if you look at the TOPCon, that is the TOPCon technology, which is going to come in, or the mono-PERC technology, which is very much prevalent. These are the two main technologies on the anvil now, mono-PERC being the front leader today. So what technology you are talking about, when they come in, the fabs can be used, but we'll have to go for a change of the tool sets and maybe the sizes. So we'll have to look at it, and what now looks to be very doable, perhaps, which is within reach, is a layer of perovskites on one of the layers of the current technology, maybe AJT or something. That might come up. But for your question, you can have the same fab, maybe, and then change the tool sets, and some modifications can be done.
So we need to say tandem silicon perovskite solutions, or
Tandem is a different ballgame. So when you understand silicon, you understand two very clear things. We are on wafer based, and then we are on amorphous based, right? So when you are doing something which is close to amorphous, then it's a different ballgame. So we are more, India is today more, or the globally the more, 95% of production is still with wafer based screen print technology, what we call it, what we are doing today. So that's a different ballgame. This will call to full
Thank
change
you.
of equipment.
I need to leave now for some parliament briefing.
Okay.
Thank you for giving me this opportunity. Yeah.
Thanks, Dr. Sunita. We will send you a summary of this panel
Yeah, sure.
for things to be implemented from the ministry side. Thank you again.
Thank you.
Yeah. So, yeah, Manish, please go ahead. Yeah.
This is about the refurbishment of the capital. The capital investment required for this semiconductor manufacturing unit on the equipment part side. If we are going for the refurbishment, equipment from the third party, there's a big issue. One thing which we need to focus on, sir, that what is the residual lifetime of that equipment is, and its performance over the time, that has to be guaranteed. It can be guaranteed only through the OEM. If the vintage of the equipment is very old, then managing the spares and consumables for the equipment over the period of time, because at least if I am putting a fab today, it has to work for next 15 years. This is the target. That is another level of challenge. Of course, that commitment is given by the OEM, then it is okay. But if I am going into the third party from the open market, then the OEM used to say that there's no license agreement with you. If in future the third party vanished and we have to maintain the equipment by our own, then it was a big challenge to, source the spares, consumable. And sometimes, sir, if it is the IP related issues of the equipment, OEM says you have not buy the equipment from us, so we are not the owner. And they never support you on the spares, consumable, and IP side. And the third party, they have the limited access to the systems. They cannot guarantee you on the IPs. They cannot guarantee you on the software skills which are implemented, or firmware skills which are implemented on the equipment. But this is the biggest risk in going for the refurb equipment from the third party because of non-support for the long-term reliability of the equipment. Then we have to consider it in another way, either support the refurb equipment from the OEM side or go for the new one. Thank you, sir.
Yeah, so I think we are sort of running out of time. Maybe one or two questions and then we will have a quick recap. Yeah, please. Yeah.
So first thing you told about the residual life of the machine, but when it comes the guarantee from the OEMs, why OEM should be interested? They will be more interested to sell their first-hand equipment. That is number one. Number two challenge, possibly what we are hearing from different media, if we use the refurbished tools or government allows, it could be a dumping ground. People can inflate the price of the refurbished tools, get the subsidy, and then the user departments will be facing these challenges. So there lies also the challenges. So this is a question of overpricing.
But OEM do have the target of the refurb equipment. Nowadays, since they are fully flooded with the new equipment, they will not support.
Yeah. So one last question. I mean, you can, yeah.
I am SLN Murthy. This is regarding electronic packaging. In fact, we conducted the first continuing education program through IEEE, EPS, and Institute of Science in 2005. But after that, it did not take off. Because whenever we talk about electronic packaging, I get a simple reply. Why should we bother about cardboard packaging, thermocol packaging? So that's what people understand about electronic packaging. And we have been spearheading this skill development because it's not a great skill, but it's a question of understanding the intricacies and the design requirements and the simulation and modeling. And this area has to be addressed because this is the easiest to implement from the point of view of CapEx and other things. And this is the bridge between the silicon and the realization product design. And there are a lot of product design companies in India, and it can benefit. And a couple of companies like HCL, Chesal have been involved in activities. I feel that it is very important that as a university education program, where Krishnamurthy with IISc and Dr. Rao Tumla, we have been working on this to have a curriculum as a part of it. And way back in 2018, we set up a Vidyavardhaka College of Engineering with the support from Mentor Graphics to set up the first packaging training program from 5th semester onwards. It was an optional course because they become the deemed university. I think we should adopt this across all the colleges and engineering colleges, make it mandatory kind of a thing if we have to build the ecosystem for the semiconductors.
Okay, thank you. Completely agree with you. Packaging cannot be an afterthought. In fact, today the leaders are talking about chip package co-design, and heterogeneous integration is really one of the key things. You know, IEEE is championing that. Absolutely, I think we need to look at all aspects of the ecosystem. So I think we are running out of time. I'm sorry to cut short this discussion. I will give an opportunity to the panelists for 1 minute perspective from each one of you.
Yeah. It was a nice session, and only a few points to supplement here.
You can bring it closer. They're not able to.
Yeah. So while there has been so many buzz about this,
very, very important part.
Yeah. So there has been a lot of work has been done on the IP core and the EDA part. But this, when it talks about this hardware part, actually a lot of things to be done. And we have to think about the total ecosystem so that it supports the domestic industries. So in a semiconductor fab, there has been so many interrelated activities, whether it is a clean room, whether it is an HVAC utility, bulk gases, and this effluent treatment system, waste handling system, recycling. So if those can be brought under the purview of these incentive schemes, so that domestic industries will be beneficiary. Another part is that the globally lot of countries has utilize their experts like China. So those expertise, whether we can implement in India so that we can get their knowledge sharing. And also what we feel that in the expert committees, if we can induct those veteran people, those who have run the fab from the semiconductor complex or the GATEC, who is having the first-hand exposure in the lithography tools or the how a facility or fab is run in terms of the utilities management, the risk management. So that way it will be beneficiary. So these are my concluding remarks on this panel.
Thank you, Mr. Raghu.
Yeah, I think I learned a lot today. Like I said, we are the poor cousins, but what I take away and what I see is sharing my experience from solar is initial years are going to be tough. But I think those are the years where more agility is required from the government front. I say this is a bit of pain because had this happened in our sector would have been very different. We didn't have the vision to see it maybe, but and also to bring a point today, the 90-95% are neighbors doing this technology is not homegrown even for them. This began in the West. This began in Europe, in US, in Russia actually. The wafer technology that's been done today for solar is from Russia, and they were smart enough to, adopt it and make it their own. So there will be a lot of initial pains when we get into this, but I think we are poised now, and there's a lot of learning you can take from people within such sectors as solar, especially on the learning portfolio that you're talking. Safety being a very, 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 very important part of it. I think as we grow in these industries, safety is going to be a critical parameter, which the government should also look at how it can be shared across platforms. And then I think the main challenge will be the first fab getting on. And once the first fab gets on, the rest will follow, and the things will start mushrooming on its own. That's all you need to do. So thank you for having me here, and it's a pleasure being here. Thank you.
Mr. Das.
Before concluding, I'll quickly like to answer the earlier question of equipment manufacturing and equipment ecosystem. So what I've seen, if you consider pharma to be a mature industry, so the ecosystem will follow. The moment we'll start, initially we may import and set up the fabs here. Once we'll start manufacturing more here, the equipment manufacturer will follow us. So that's what happens naturally in all supply chain, all manufacturing industry, and that's what is going to happen in case of semiconductor as well. That's my belief. Regarding my concluding comments, I'm very optimistic. So I see this is an area where I think India will quickly catch up with and be a world leader on semiconductor. Though initially it looks difficult, there will be always there will be a problem in the startup, but starting something new, but type of focus. I'll say this is the best example today. We are 200 people sitting here and talking about it. So maybe I believe down the line, next 2 years will be in a very interesting phase of semiconductor industry in India. Thank you.
Thank you very much. Sunita has already left. I'm supposed to summarize the panel, but it is very difficult. We have had very interesting discussion, long-ranging discussion. But I just want to tell you that, I've been in this space for more than 20 years now. I've seen things, happening in the country from late 90s, and we have had many failed attempts to get the fab going off the ground. I still remember a meeting with Dr. Chidambaram, Principal Scientific Advisor to Government of India, early 2000s. He made a comment, we have been successful in atomic energy. We have been successful in space because we had mission mode programs. We never had mission mode programs in electronics. And today, in fact, the program is called India Semiconductor Mission, right? So I believe that this is indeed a mission mode program ready to take off, right?
I'm extremely optimistic, having seen this, as I said, over more than 20 years. I've had many discussions with Krishnamurti, with IISc. I think the stage is set, and let's hope that we will have the first fab very soon. We need to have that prime mover advantage. But it's not just setting up a fab. You see, the reason why this industry is so difficult is that technology keeps changing every 2 years, right? You have to be at the forefront. You have to continuously have your R&D, right? That is where this close cooperation between government, industry, and academia is extremely important if you want to not just establish a fab, but be successful in this domain for next couple of decades, right? So let's hope that this kind of cooperation will emerge in the years to come. And I would like to thank the organizers for thinking about this excellent panel and organizing it. And as we have promised, we will make a summary of this and share it with both Government of India and Government of Karnataka. Sunita Verma was here, Dr. Ramana Reddy was here, as you know, and we will indeed follow it up and make sure that things will indeed take off the ground. Thank you. And I believe there are some gifts to be handed out to the panelists.
Indeed, you all deserve it. So actually, thank you very much for the token of appreciation. Thank you very much, everyone. Navkant, thank you very much for really moderating. You're a very busy man, and then all of you are here. So somebody has to appreciate that, right? So please, thank you very much. Thank you, everyone. I think we just about 5 minutes over. That's wonderful, actually. We still have some questions, but they're online, so we will collect them and then put them across. In some way or the other, we'll communicate. So we'll move on to the next panel, which is actually also very busy panel. It's on human resources. Yeah. So, yeah. So, Vishwabha, can you hear me? Yeah. Ladies and gentlemen, I said that it's jam-packed. So you don't have the respite. Some of you can go out and then have the flowing coffee or tea, but now the next session is already on. Sushovan. I invite Professor Sushovan to moderate this session. You have the script, you know the script, so please go on.
Yeah, thank you. Thank you, everyone. Kindly settle down. So this is the panel on human resource. The basic theme of the panel is to answer 3 fundamental questions. Question number 1, what is the workforce needed for to support the upcoming semiconductor manufacturing in India? And we are talking about manufacturing, not design. Then what are the skills needed to build and operate a fab? I think one of the things that will come across is the interdisciplinary nature of the skills required. It's not just one engineering, it's often multiple. And finally, what are the academia and the government doing to address those needs, either in the form of a certification program, diploma programs, degree programs, etc. And to help us answer these 3 fundamental questions, we have an extremely illustrious panel. I'll just call them in alphabetical order. So Professor Akshay Naik. Akshay is a professor at IISc Bangalore. He runs the INUP program. I think Dr. Sunita Verma mentioned it earlier. He can give us more details about what INUP is and how does it help workforce. We are supposed to be joined by Mr. Ashwin Gowda from Government of Karnataka. He got called for a ministerial meeting just this morning, so he sends his sorry, but he has instead asked Mr. Srinivas from KSTC to represent him. Then we have one participant online, that is Mr. Vinod G. Nair. He's a senior director at Global Foundries. Vinod actually was one of the people in the talent committee that was set up by Indian Semiconductor Mission. Is Vinod online? Hello, Vinod.
Yeah, I'm online.
All right.
I don't know
Hello.
if you can see me.
Yes, we can. We can hear you and see you loud and clear. Thank you for joining. Then we have Ms. Jaya Jagdish, who is the country head for AMD India. The committee on talent development I was talking about, Jaya actually led that committee. And if there's anybody who knows about talent development and government programs on talent development, it's Jaya. Then we have Mr. Rangesh Raghavan. So as was said earlier in the panel, Rangesh is the corporate vice president and general manager at Lam Research. So the semiconductor ecosystem is more than just fab, and OEMs are a big part of it. And we are very happy to have Rangesh on this. And finally, my friend, Professor Shiva Ramakrishna Vanjari from IIT Hyderabad. Shiva actually leads AICTE's efforts to develop new curricula for semiconductor manufacturing. He actually led the committee that has defined a model curricula for both diploma holders as well as degree programs in semiconductor manufacturing. So with that, we'll get started. I think I come here. I don't. It's okay. So the plan is fairly simple. Unlike the other one, we actually only have 90 minutes and I'm between you and lunch. So I'll be very concise. We'll just have 35 minutes for opening remarks. I request all of you to make 5 minutes of opening remarks. And then we'll have a focused discussion where I ask the questions and then we'll throw it open for all of you. So with that, Chair, let me invite you. You can make the opening remarks. So what do you think about talent development, especially in the context of semiconductor manufacturing?
Sure. So, I had the honor and privilege to chair the Committee for Talent Development. The committee was really an initiative of ISM, India Semiconductor Mission, and it was set up under the guidance of our Minister of State, Shri Rajiv Chandrasekhar. So the committee itself comprised of eminent leaders from academia, industry, and the government. And it was a very talented, well-rounded committee that brought in experts from various sectors in the semiconductor industry. So the approach that the committee took was to look at the entire ecosystem, including manufacturing, and divvy up the whole sector into 5 different major sectors. I mean, we looked at design, system design, foundries, ATMP, and display. So we looked at, the first thing was to look at the demand and supply to arrive at the gaps. So the demand is something we had to arrive. We had to build a semiconductor roadmap for India based on the investments that are out there and the potential investments, and kind of backtrack how much talent we really need to be prepared for the next 10 years, 5 years, 10 years, or even longer than that. So with all this exercise, one thing that came out very obvious was there was really no gap in terms of headcount. We have more than 500,000 engineering graduates that come out in India. So honestly, it's not a headcount problem that we were looking at. It's really the skill set problem. When the students graduate and come out of academia, there is a gap. They're not entirely industry ready. And the recommendations from the committee focused on filling this gap, the skill set gap. So we took 2 approaches to this. One was the short-term approach and the other one was the long-term. Long-term really focused on curriculum changes and introducing VLSI major courses in relevant institutes and making it a very popular stream for the students to approach and build their careers in. And the short term, of course, any curriculum changes will take time, and we need at least about 4 years for the students to graduate and come out being industry ready. So we need to do something for the short term. So we looked at certified courses, training institutes that can provide these courses, and also looked at government programs and initiatives and integrated those into our recommendations. Another aspect was R&D. While these training courses and curriculum changes can focus on employability of students and creating more jobs, R&D becomes hugely critical for any growing industry. We cannot ignore that. So on that aspect, we have looked at, we have recommended a semiconductor research center modeled after Albany Nanotech or IMEC that can become a hugely important asset for the semiconductor industry in India. And we also looked at the Penang skill set development centers, likewise, which could potentially become a benchmark for us to follow and create something similar in India as well. So overall, it was amazing. It was a great learning opportunity for each one of us, where we learned so much more about the other sectors that we were not part of. And we submitted a 70-page report to ISN or METI after 3 months. It required a lot of weekends and holidays because all of us had day jobs, and this was kind of coming from time outside our regular jobs. So it was really the weekends and holidays that we put in the effort. And I really want to thank Vinod, who's a co-panelist here. A big shout out to Vinod for being pivotal in coming up with the manufacturing recommendations.
Thank you. Thank you.
That's pretty much what I had to say. Thank you.
With that, actually, I invite Vinod to make opening remarks. Vinod, if you could talk about the requirements for semiconductor manufacturing, which I think you are an expert in. And also, by the way, thank you for being here. I know it is very, very late in New York, so really appreciate it.
Okay, thanks. Hey, thanks for inviting me. I think it is an honor and pleasure to join this conference. And also very nice to meet you all. I hope that I could meet all of you in person next time. And also nice to meet Jaya Madam and also Professor Shiva, at least connecting after some time. So let me just introduce myself if you're not familiar with my background. My name is Vinod Kumar Nair. I actually work in Fab 8, Malta, New York for Global Foundries. As you know, Global Foundries is a world's leading semiconductor foundries, and we specialize in differentiated solutions. So my entire career in semiconductors and in wafer fabs more than 27 years. So when I got opportunity to work in the talent development committee, I thought it is a great privilege, and also to use whatever I learned over past years working in different parts of the world to use it into action, and hope to see a fab in India at some point of time soon. Okay, so then talk a little bit about the fab. As you know, this fab manufacturing, it is once a design comes to the fab, the skills required to turn the designs into products, right? As well as how to run this manufacturing in the fab, physical, very diverse skills. So if you look from the fab, you can look at, basically you can tear it down to different levels. Number one is, for example, if you can look at the department level and with the specialization, or you can also look at what kind of job nature you do. For example, you can be a technology development and research, then you can look at a fab engineering operation, then you can also look at the technicians. So Madam mentioned about Penang, the skills development center and all. That's primarily for the technician development and all. That's all. The whole ecosystem need to work in terms of the available talent development, as well as how they are uniquely or specialized training required to run the fab. So looking at a fab, for example, typical fab can require around 2,000 to 3,000 people, right? It depends on the technology, the volume, as well as the automation. And this, how you split between these three categories, on whether it's a technology development or engineering and other operations, depends on all these factors on technology as well as the automation requirement. At the same time, along with the fab operation, there has to be a strong ecosystem to support, right? For example, equipment suppliers, maintenance of the facilities, and associated jobs also will be generated. So typically, if we say 2,000 people working in a fab, the number of jobs created around that has to be multiplied by a factor of X. Depends on it is a matured region or something which is newly developed region. So it's create a lot of jobs. Then what kind of talent required for this? So if you look at the technology development wise, it is primarily masters and PhDs. It can come from various different specializations, and it can be electrical engineering, material science, chemical engineering. Depends on the specific specialization, whether you are working in device engineering, device architecture, or is it process development, technology, different aspects of the technology development, or even with some design background is required. Then if you go to the the fab operations, again it depends on the the speciality, because even if you look at the facilities, you definitely require people with the background on chemical engineering, chemistry, then civil engineering, construction, many other aspects. Then you come to the fab operations and engineering. It's about electrical engineering, physics, chemistry, chemical engineering, material science. So it's a mix of things, I would say. But the important aspect of all this is for the engineering function is that along with whatever the specific specialization you have, I think some courses on semiconductors will be very useful so that you can bridge into fab operations. Along with that, along with all the technical courses, there are several other aspects in terms of understanding the manufacturing operations, the economics behind running the fabs. All these things will be very useful because everything you do, you need to prioritize on a daily basis what you need to do fast. So that is also helpful. On the technician part, I think it is a very specific skill in terms of whether it's a maintenance technicians or not. Hands-on experience is also going to be critical. Those typically the maintenance technicians from the Indian context, I would say there's either a diploma in engineering or a BSc, but people need to go through really hands-on training. So that's a sort of very high level of summary. In general, I think people, when I look at my own background, studied in IIT Madras and going through this, different fabs, I think we do have a system, so has a very strong foundational courses, but I think getting the hands-on training and getting the bridge into the technology and the high volume manufacturing is something which required. And I think hopefully with the fabs coming in, I think people will have more exposed to all these things.
Thanks, Vinod. With that, I'll actually invite Rangesh and actually have sort of 2 sub questions for you in your introduction itself. So as an OEM, what sort of skills are you looking for out there in the market? And more specifically, do you get all the you need?
Can you hear me? Yeah. Yeah, first of all, I'm Rangesh Raghavan. I work for Lam Research Corporation. This is my 30th year in the industry. I'm a native of Bangalore, and I spent the first decade of my career in the fab as a process development engineer at TI. And TI was one of the pioneering companies in this space from the 60s. And, many people, in the industry joke that TI should really stand for Training Institute, because there are, a huge number of luminaries in the industry that have started their careers at TI, ranging from Maurice Chang himself, founder of TSMC, to, Wally Rhymes, the founder of Mentor Graphics. So, the industry is populated with people at TI. And this topic, I think, my own experience at TI, I spent 10 years. I was part of the team that set up the first fab in Singapore. And this was the Tech Semiconductor fab, which was building DRAM chips. And at that time, Singapore only had packaging facilities. They had no wafer fabs. And so I was there as part of the expat team from TI transferring technology to this fab. And so I got a firsthand look at how you start in a new place and actually make it work. And we also started an effort with Alpha TI, which was a Thai company. It was very short-lived. It died during the currency crisis, but we TI had a joint venture agreement with them as well. My observation is that we have a pyramid problem in India, and what do I mean by that? When I entered TI, I was one of two NCGs that hiring class, and there were 150 seasoned, trained, industry experienced veterans in the fab, right? So we were two learning from 150. My own experience here is completely inverted, right? It's basically you're lucky if you have two who have been there and done that, and you have 150 newbies who don't know anything about your space, right? So it's very, very raw talent. I think so. Coming to so Shobhan, your question, my experience, and I think the experience of the new fabs in India will not be very different. It'll be this challenge of taking very good raw talent, because I'm sure that we're going to hire the brightest and the best, right? We have 500,000 engineers, as Jaya said, and I think we'll have no problem finding 1,000 of the very best among those. But they'll know nothing about building and running a fab. And even if they're given a complete recipe with the full process flow, they'll know nothing about how to solve the yield problems, the excursions, and the challenges that happen in the fab to get to yield. And that's where the experience comes in handy. So we will have to start with a whole bunch of expats. And I think that's how Taiwan started, right? It was being able to attract people of Taiwanese origin to come back and contribute to the growth of that industry. There was both a nationalistic element, and there was a clearly very good compensation connected with it. So I think we'll need to appeal to both of these things to build a kernel of leadership that then around which we can start to build the rest of the team, and it'll still take time. So my own experience as an OEM vendor, which is the other side of the industry, is very much the same. We rely on a handful of our key leaders who have been in the industry for years, who then train and coach and develop. And it takes years. We've been in India for 20 years. And I can say finally that there are many, many aspects of the system that we own completely out of India. We work on 2 nanometer, 3 nanometer. We work on all the technologies, and there are subsystems that we own completely out of India, but it's taken 20 years. So short thing is it's not easy.
Thank you. So we have heard from the demand side of the equation. So now let's hear a little bit from the supply side. So now I invite Shiva. So maybe Shiva, you can talk about your own efforts with ICT. I see Mr. Rameshji sitting in the audience. Thank you for joining us today on what we are doing to develop programs for BTech manufacturing. And I think Shiva has some slides.
Yeah, I have a couple of slides, and a priori I'll announce that the last slide is much more important for discussion. Okay. Whenever I come to Bangalore, it feels like a home because I have done PhD here, right? So I saw when Sense came in, right? So that's my. So 2 slides about IIT Hyderabad and why I'm here. The first thing is IIT Hyderabad is the first thing to actually launch a BTech program in IC design and technology, right? So why did we do that? I'll just explain in a moment. And also we have launched 2 programs, one on MTech in packaging, the other one on MTech in semiconductor materials and devices. So one gives a complete packaging perspective wherein you are going to actually lead, right? See, all the way till now, we are actually being a lagging game because we are actually at the crisp of getting into more than more, right? We have to actually get into advanced packaging a lot more, and then take it as a pioneer rather than being guided by somebody else. And that's the reason why we ought to actually take it right. Okay, I'm not able to see my slides. Okay, I'll keep talking till the slide comes. Okay, so what we have actually looked at, I've been privy to the committees of ISM, right? And I had enough interactions with Binod on a regular basis. Right, what we have actually done is we have created a curriculum based on the recommendations of the committee itself, right? So, and what we have actually looked at is a balanced curriculum which focus only, both on fabless, on the fab as well. right? I mean, if we actually give it to the industry right now, they would actually look at fabless is actually more, and there is a demand for fabless manpower. But as a curriculum perspective, we have actually focused a lot more on both balancing the curriculum in terms of fabless and you can actually move further, please. Proceed. Right. So what we are actually focusing on is, if you look at our curriculum, I mean, our manpower per se, right? Everywhere for industry, you need a pyramidal man structure. You need a bottom layer, a lot of manpower. And then top, you need a small little manpower. But unfortunately or fortunately, what has happened all these years is you have only a kind of a vertical structure wherein you have an MTech and a PhD, but not many manpower at the BTech level, and these are the workhorses, right? So you need to actually develop the workhorses. And the contrary point that used to come every time is we need that expertise. I mean, you need that much time to actually make it. What we actually argue is right now, when you're actually going to a JEE exam, you are actually feeding a 11th class student with an MSc syllabus and they're able to crack it. So you never tried it out to actually give a challenge to all the undergrad students to pick up that level. And if you give that particular challenge, I'm sure they will be able to do it, right? Go to the next slide, please. Right, so this is what we have actually looked at. It is imparting fundamentals of hardware, and what is focused is on end-to-end learning. Unless or until you do a tape out, until you touch a wafer and you actually do a processes, you become dirty. You don't know what you're actually getting into, right? I mean, learning theory and imagining theory does not work out. So you have to actually get into a phase where you have to dirty your hands up, right? And that's where it's actually incorporated. We'll quickly move on, please. Right, so the overall philosophy is fundamentals we'll actually give. Applied knowledge, we also have to actually see how do we give it. Go to the next slide, please. Right, move on. Okay, this is the committee, and these are the this is the committee that Madam has headed. Right, so you can actually see there is a balance between the government policy makers, a lot of industry who is who, and then a lot of academia who is who, right? It's I mean, the amount of effort that they have put in is unmatchable. One word. Okay, go to the next slide, please. So this is curriculum to be for a degree specialized in VLSI, and that's the reason why we have actually launched a BTech in electronics engineering with VLSI on February 18th. The curriculum is officially launched in Bangalore. Right, and we have also created a curriculum for diploma in IC manufacturing. I'll not go into the details of the curriculum, but essentially what you are actually looking at is whatever the committee has suggested, we have incorporated in the curriculum to the extent possible. Only things that we have not included is the embedded software, which would actually go as an elective part. Otherwise, as much as possible, we have actually put in the curriculum, right? And I mean, we are happy to announce that our first batch of IIT students are actually getting undertrained. I mean, in 4 years from now, you have 20 people who are actually well trained in an IIT system as your manpower. And at the same point, can we actually go ahead, please? Right. So this is what I have actually given a jinx. Whatever recommendation that the committee has actually given, vis-a-vis what we have actually included. Right, so proceed further, please. Right, so all these concepts of fab and fabless we have incorporated. I would like to point out two unique courses that both Shushoban insisted and we included. One is semiconductor equipment manufacturing, and the second one is semiconductor materials and characterization. This perspective we've actually put in so that people would actually know how to actually repair the equipment, or I mean, you need manpower to actually cater to that particular segment as well. Can we go to the next slide, please? Right, so we also have created a similar set of structure for diploma holders, wherein we actually looked at each and every operator and their duties and what needs to be done for that. Move on, please. Right, so all these things we have actually taken care. Go to the last slide. Right, this is the committee. I mean, you actually see all the professors, but in the hidden side, what we have is everybody has some expertise in foundry or design. Right, everybody has worked in either a clean room or actually did hands-on. Right, go to the next slide, please. Right, now this is my last slide. Okay, so what what do we need to do right now? I mean, it's very easy to define a curriculum. I mean, not to take our efforts out, but it's reasonably easy to define a curriculum. It's definitely tough to actually sustain it. So our efforts right now ought to be sustaining those curriculums. And one of the things that we need to do right now is we need to win the perception battle, right? And everybody is aware that machine learning, artificial intelligence, everybody wants to take. But those concepts exist 50 years before, right? Why are they not being, I mean, VLSI made it happen, right? So in some sense, VLSI is the backbone and it deserves that particular attention. So what we are planning to do, I mean, I'm actually taking Ramesh as yes, right? So what we are planning to do is for every course, there will be a MOOC lecture that will be made available for public. And then we'll also do a lot of train the trainers, faculty development programs. And we need to ensure that every student does a tape out, right? It can be a simple differential amplifier. It can be a ring oscillator. Does not really matter. From end to end, they should actually do the stuff, right? And what we have actually done, and I'll announce here, is that IIT Hyderabad has actually requested AMD. AMD has also is collaborating with us in teaching. People will actually come and teach at IIT and then take them, right? So you can actually create a seamless teaching internship, and I actually call it by the industry for the industry. If you want, you train, you take them, right? So that it's as simple as that. And what do we need to actually do right now is like, if you look at Microsoft certifications, they value a lot, right? I mean, somewhere down the line, a BTech student who has actually graduated, right? He will actually, do a lot of struggle to get a Microsoft certified Java, engineer, right? And that gives them job, right? What we need to actually do here right now at this particular point is come up with certification programs wherein that certification, if done, the student gets a confidence that he's going to get a job, right? That's the most important point. So unfortunately or fortunately, job market is actually driving an education sector. So we need to focus on that, right? I mean, I would actually say education market is actually driven by job market. So, I mean, we have to somehow get the perception right and ensure that we move together and we create this perception that this is a job creating field. This has a lucrative, career ahead, right? I'll actually stop at this particular point. Thank you.
I was going to start ringing the bell. I think a lot of people have already mentioned they have very important hands-on aspect. We'll come to that actually later, but now let me ask Mr. Srinivas. The lower end of the pyramid, especially diploma level programs and training, can you talk about GOK's efforts in that?
Yeah, good afternoon, all of you. I think I would like to start here with a statement, which I'm very fond of, right? So it's work until you don't have to introduce yourself. I think this is something which I always, it's in front of my eyes. And the panel that I'm a part of today and the August people sitting here in the gathering, I think many of you are there where you do not need an introduction, but definitely I do. I am here, I'm Srinivas, I'm representing Mr. Ashwin Gowda, who is the MD of KSDC. Unfortunately, he was unable to make it today. And I am a passionate engineering professional who also happens to have had the opportunity of implementing capacity building and skill development programs at a national level under the aegis of the Skill India mission. There is also another point that I would like to highlight here. As I said, August gathering and people have already put the effort. One of it is being the last speaker. Right? Being the last speaker, everything's already covered. So I do not have to reiterate everything again. But one thing which I would like to highlight here is, one is problems have been identified. Solutions have been proposed for the problems, which have also been discussed. And the key aspect is there is also a lot of things which is already implemented and actioned. So that's wonderful to hear, wonderful to know as a part of the effort. But I would very briefly tell you what, as a part of government, we do to enable this and probably add some numbers to this effort that is going in for capacity building. So if we look at the entire life cycle, I think we always start from a demand-driven approach. So the first activity which actually happens is we interact with the industries and try to understand at various levels what is the forecast of manpower that is required. This becomes the first step for us. From here on, the next thing is to build a skill matrix or a career matrix or a career progression, because it needs to be aspirational. We understand that we have a lot of people at the bottom of the pyramid. They're supposed to join us. There are workhorses. All that is great, but he also has an aspiration. He needs to know where he's starting today and where he's going to be at the end of 5 years or 10 years. Pun intended. I think with today's industry situation, we don't know where things are going to be at the end of 5 years and 10 years. But even with that, I think this is an information which every candidate deserves to know. So as a part of the government's initiatives, the first effort which goes is to understand the quantum, which is the quantity of people required at various levels. And the next effort which aligns with that is over a period of time, what is the career progression of this candidate and what is the skill which needs to come in at a lateral level to ensure that he climbs this ladder and he's able to build a career out of this, right? So this is the first effort. And once these are defined for each position of this skill matrix, we go to the nitty-gritties to the level of understanding what is desired as an outcome from this candidate. It can be his knowledge base, it can be his performance criteria, his etiquettes, the way he presents himself, the way he talks to people, understanding shop floor requirements. It can be Kaizen or 5S or any of these, right? So end to end, all of these are defined for each level of the job in the industry, right? And it's not only this. Once you define this, you would also need parameters to assess these people, right? So one is people who can assess, second is parameters of assessment. So the government works to develop a parameter of assessment against each of these roles. So if I add a small number to all of what I'm talking, from the electronics domain itself, across the service, design, and manufacturing segments, we have close to about 160 such qualificational packs, which are also what we define as curriculum, content, which are already in place, which is driven to a large extent across the nation through the Skill India mission. And these qualificational packs, I think the next obvious question is, where do they come from? They come from the industry. I think the August gathering here is a part of a committee which is working at a very high level, giving the right direction to all this effort. I come from a part of the ecosystem which is one level lower, where we drive the operations of all these inputs that we get from the industry. So we have further subcommittees which are represented across each division from the industry and a representative from the respective industry segment. We sit and define each of these parameters and criteria which needs to get into an ecosystem. What's the theory? What's the practical? What's the weightage for theory and practical? What's the infrastructure required for this? What are the other behavioral aspects required for a candidate to undergo? All these are well defined, documented, public documents available. All of you can look at the NSDC's website. All of these are documents which are available publicly to everyone. And these are revised once in 6 months, which means this committee meets every 6 months. Anything that is an advancement to this is incorporated as a change, and that further drives or dwells into the ecosystem. So with this context, I think, as I said, I comprehend and acknowledge the efforts which the industry has taken in this, and look forward to a continued and sustained effort, which I'm sure at every level of penetration will ensure that you have the required manpower for the industry. Thank you.
Thank you. So, okay, so we are running behind, and since you're the last lecture, you get only 2 minutes. So introduce yourself. We have all discussed the importance of hands-on training. So in that context, maybe introduce INUP.
Okay, can you hear me? Can you hear me? Okay. So we discussed the requirements. So what I'm going to say is there are 2 things or 3 things that were mentioned. One is the manpower. The second is the R&D that's required in this area, and hands-on skill. Those were the 3 things that I picked up. So I'm happy to tell you that we are working on it, and we've been working on it for about 10 years now. So I'll tell you about the program that we've been running, and that's called Indian Nanoelectronics Users Program. So the program started immediately after the fabs were set up, the facilities in sense were set up, the facilities at IIT Bombay were set up. So the question was very simple. Look, we have set up this facility that has a state-of-the-art equipment to do fabrication, to do characterization. How do we ensure academic users, right, who want to work in this area are able to access these facilities, right? That was a simple question. And how do you ensure the barriers that are there are reduced? And these barriers could be many, for example, financial. In India, unfortunately, except for maybe IISc and top IITs, the funding level that's provided for R&D in this particular area is not very high. Okay, and if you want to do research in this area, it's expensive, right? It does cost a lot of money. So how do we do that? If we say, look, you can come and pay and use it, we've already eliminated about 99% of the people, right? So we wanted to say, look, we shouldn't do that. What we do is, you come up with an idea, okay? We will provide all the financial support that you need. All you have to do is say this, look, I want to work on this particular aspect. I want to fabricate this particular device. We want to grow this material and characterize this material. Okay, you come up with that idea and we'll help you. The other question is, look, I have an idea. I can fabricate these devices. I know how to fabricate it. I don't have a hands-on skill. I don't have the training on how to use this equipment. How do you address that? So we said, okay, you come up with an idea. You come here, we will train you. We will train you on all the equipment that you need to execute this project, right? So we tried to reduce as many barriers as we could. The entire financial burden is taken up by us. The entire technical requirements that the user might have over the course of executing this project, we take it up, right? Our staff, including the people who arranged this conference, take that up, help the users. They come here, they get trained on the equipment that are required. Then they come here again to execute the project that they want. Okay. Now at this point, they publish a paper. They have a patent based on the work that they do. In all of these papers, all of these publications, all of these patents, none of the faculty members of our department are authors. They have the IP. They have their paper. Their names are there. We do not become co-authors. So that's something that we do with INUP. We train people. We help them do their R&D. And we give them the guarantee that, look, just because you're coming and using our facility doesn't mean we have to be co-authors on this. So it's a very open facilities that we have. So this program started about 13 years ago. In the program, we've trained about 8,000 scientists from around the country at various levels. About, Sushovan is looking at me, I'll just give a few numbers and then stop. About 600 journal publications over the last 10 years. And again, none of us are co-authors, right? All the IISc publications are separate. This is users coming from different parts of the country, okay? Again, you pick any state in the country, we have a connection there. You pick any district in any state, we have a connection there. We are connected to about 700 institutes around the country. Okay, so I'll just stop here. If you have a specific question, I'm happy to answer.
Right. So let me move on to the more direct question part. My first question actually is to you, Jaya. You come from a unique vantage point because you had a design company, but you also now understand probably fab. Can you discuss the differences in training the workforce for fab and design? Because one is software tool heavy, the other is hands-on heavy. One is probably just EE, one is interdisciplinary. So how should the talent policy deal with those two differently?
So both these sectors are different in terms of talent requirement, and also not just the talent requirement, but it's about the maturity of each of these sectors in the country. I mean, design really started almost 3 decades ago, and we are a pretty mature sector. I mean, like AMD, many of the MNCs have invested, and there are many local companies who do design of semiconductors. So the talent requirement is a lot of organic growth happens. I mean, AMD itself, they've hired over, 2,000, 3,000 graduates over the last 20 years that we have been in existence in India. And we have pumped enough talent into the system. So there's a lot of organic growth that can happen and will happen going forward. And when it comes to design, you can really get your entire design completely done, verified, and ready to tape out with a PC, with a laptop. But manufacturing is a different ball game altogether. And one fundamental difference, of course, not talking about the maturity of the sectors, but the fundamental requirements in talent is different. While manufacturing has a larger spectrum, starting from high school graduates all the way to PhDs, design is a lot more focused on engineering graduates, mostly with masters and PhDs, whereas there is a little bit of layout and other work tasks that are done with diploma holders. So that's the fundamental difference. And also the maturity comes into place. While we believe there is enough and more organic growth that can happen in the design sectors, and the focus will be on more advanced roles like architecture, and now we have AI space that can redefine the way we do design. So it's a lot more focused on these emerging technologies and advancements in design. Manufacturing, we are at a starting point. So we really need to have these partnerships with established foundries and maybe outside India who can help us train and build this talent on various levels. So there is a fundamental difference, and we have taken into account into our recommendations from the committee. And these differences are well noticed, comprehended into our recommendations. Thank you.
Thank you. My next question actually is to you, Vinod. I think there are some very exciting jobs at the interface between fab and design. Now, given your experience, which is easier, start with the designer and teach them fab, or start with the fab engineer and teach them design? And for youngsters in the audience, what skill sets would be most valuable to be at that interface?
Okay. I would say, where do you want to start? It also depends on where you want to end, right? What do you want to be at the end, right? For example, if you want to be a design engineer, with you also interested in the technology, I think starting with the technology, right? Get a few years of experience in technology and fab, then going into design space, I think that would be very helpful. Because a lot of times what we interface with the customers and all, what we see that bridging between the technology, manufacturing, and design, that is extremely critical, because in terms of how fast you can get a product into maturity, it depends on, as you know, now we have this DFM and others, but that is a very important aspect. So in my view, it's depends on that individual, what their end goal is, and having an exposure, whether even if you're working in a fab, if you have a design experience prior to joining the fab, also will be very useful, because there are several cases in which you work in either product engineering in the fab, or yield engineering, or process integration organizations. I think understanding the product and design concepts will also be very useful, because you can always link the issues you see to design blocks, or how the process and product interactions much better. I think it comes to the case in which that specific talent will be used for understanding product process interaction. That is a very rare combination, and having experience both sides will help. So you can be in the, so it depends on where, what your end goal is, But anything in this industry, as you know, it never get wasted. You'll use it for sure somewhere in your career.
Thank you. My next question is for Rangesh. See, LAM India has been trying to increase the portfolio of work that is being done in India. You actually have a swanky new facility where you're trying to do a lot more things. Can you talk a little bit about that learning? And while we all agree that there are shortcomings, can you tell me one competitive advantage that India has regarding skill?
Can you hear me? Yeah. Well, one competitive advantage India has is tremendous amounts of raw talent, right? Like we said, we are able to ramp up human resources in India for, as we say, the bottom of the pyramid tasks, right? We're able to ramp up much faster than we could elsewhere in the world. So that's really why we're here, right? I mean, we're not here for cost, actually, because ultimately cost is just an outcome of access to talent. And if you can scale talent, there's the benefits of that far outweigh any cost benefits that you might get. It's nice that we have a cost benefit, but we all know that we aspire as a nation to be a fully developed nation, and any cost benefits we enjoy today are we're working to eliminate by taking all these actions, right? Because we want all of our people to sponsor and enjoy a high standard of living. So from my perspective, that's really been the competitive advantage. Our own learning has been that it takes time to really build, and they referred to 30 years of design in the country is why we're so mature and able to do things at a higher level of abstraction than we were, say, in the early years of the industry. I'm sure we started with layout, and then we are now at architecture. So in the equipment industry started later than the semiconductor industry. And again, we started with software, and we started at first with writing automation scripts for those QA tests that you have to run and automate factory automation things. And we started with the simpler things like one can imagine. We are in that journey, I think, advancing quite rapidly in that journey. But what we don't have is the luxury of time. And let me tell you why. What's changed is we see, and I think you talk to any analyst, it's $1 trillion semiconductor industry by 2030, right? You take your pick. It's the minimum is $1 trillion, ranges to 1.3 trillion. We're at 550 billion today. And the capital equipment industry has grown even faster than the semiconductor industry because of the intensity of capital needs at lower design rules. So we expect to at least double, if not more than double our size as an industry in the next 7 to 8 years. We need a lot of people to do that. And we can't afford to wait for the historical pace at which we developed our India teams is not going to be good enough because we don't have anywhere else to go and acquire that talent either. And so it's great to see these efforts like formal curricula being introduced. Professor, it's great to see IIT Hyderabad doing this program. But I would like to see that program across the country in multiple universities because honestly speaking, probably 80% of those IIT graduates go to banking or to Google or something. And what have we invested? And this is one of the kind of elephants in the room is if we invest in this talent only to lose the talent to other industries, we need to find a way to get that talent to stick with our industry. And so I find, and our own experience has been, it's far more practical for us to recruit from other institutes than from IIT because we get far more better stickiness. So, I'm sorry to be brutally honest, but it is a fact. So as a nation, we need to invest in developing this curricula and these methods, and IITs can pioneer, but we need to push them all the way down into the entire university base, and then we'll all benefit from
that. Thank you. I actually now have a question for you, Srinivas. You see, as it has been suggested that one of the challenges with training in fab is capital intensive. You need the same tools to train the people that you need to manufacture, and everybody knows semiconductor fabrication is expensive. So with that in mind, how are you actually training people at a diploma level? And how are you making those capital investments, and what is the GOK doing to enable that?
Thank you. Again, I think the question is well thought through and a difficult one to answer, but I can answer by giving a couple of initiatives which have been done till date, which can serve as a model for the fab industry as well. So there are two critical pieces of this puzzle which is addressed by government. One falls under the ambit of CSR, one falls under the ambit of a grant. So I will come to where and how we have used both of these policies, especially for providing skilled workforce for the assembly line level operators and technicians. So equipment which is required for assembly line, if I take an example of the entire SMT line in itself, is a pretty expensive affair to set up as a training facility in itself. And you would not find any private player who would look at this as a lucrative business model to set up a training center and start to earn revenues out of it. It's practically impossible. I think you may train all the people in the world, but you may not be able to even break even at some point of time. Right. And on the contrary, at the same juncture, this technology evolves quite rapidly, which means that equipments are upgraded pretty often. And you have a set of old equipments which may or may not fit in the purpose of your assembly line. One of such initiatives that we have done is with the depreciated value of this, it is booked under CSR and a training facility is set up with that equipment. And government from its side is able to give the operational expenditure in the form of a grant for training, which covers the end-to-end operations of delivering the training. So from one perspective, a CSR model for infrastructure addresses this need. And from one perspective, for the operational requirement of running the training center, there's a grant from the government to take care of this. Right? So keeping both of these or adding both of these together, I think it's a more sustained way of looking at empowering people to technology. Again, this comes with its own star mark, which is every industry or every company has its own set of standards, has its own set of procedures, has its own set of way of operations. And that minute level of training has to be imparted upon onboarding the candidate. However, the majority of the skill development can happen as an activity outside the industry through this kind of a pattern. I can cite one or two examples where we have done this. One is in LCA, which is the electronics cluster in Electronic City. We have a cluster based common training facility, which is developed there. And the infra is taken care by the industries in LCA, and the operational requirements are from Government of Karnataka. Another such initiative has been driven well with Keynes Technologies. I think Mr. Ramesh was here, and that is in Mysore. Very similar model. Infrastructure comes from Keynes, and operational the fund comes from, grant comes from the government. I think an approach like this, and I'm not sure what is the current status of one initiative which we started with Infineon quite some time ago. This was to set up an ATMP facility specifically for training purposes. And the last update that I had, of course, now I'm not with the government, so I'm only representing the department. The last update that I had is is pending because of customs and import duties which are levied on equipment which are coming all the way from Taiwan, right? So that's the last update I have. However, these are things which needs to be ironed out. But to address this issue of a capital intensive model which has to be scaled, I think a cluster oriented central training facility where the infra gets booked under CSR and government supports with grants for training is a very sustainable way of looking at developing manpower. Thank you.
Thank you. That was a very interesting answer. Thank you. Akshay, now I come to you. Shiva, you have to wait. You spoke too long. You have been punished.
Oh, this puts a lot of pressure on me now.
So one of the things that we are trying to do to scale up is to do industrial training, because that gives you the manpower today. Because while we like Shiva's program, he will generate output 4 years from today. So what are you doing? What are the various models that industry can use to get trained at various facilities?
All right. I mean, so unlike academics training where we provide them a uniform training, we tell them, look, these are the equipment that are available at our place. These are the devices you can make. This is how you use each equipment. This is how you use each equipment to characterize devices. That's okay for an R&D because that's an open-ended question. For industry, typically the questions are more specific. For example, look, next year we have to develop this equipment. For that, our engineers need to know, how does this particular unit work? For example, how does this RIE work? How do you generate plasma, right? How do we make it more efficient? So from that perspective, the questions are very specific, right? So we work with industries. We typically ask them, look, what are you looking for from the training? We work with them and we come up with a module to train according to their needs. There have been instances where industries have come to us and said, look, we want to provide training, which is a very broad level training for our managers, right? They don't need to know what happens inside the equipment, how is the plasma generated, for example, but they need to know how the overall operation happens, right? So we also tailor our training according to those aspects. So at this point, we are fairly open in terms of how we engage with the industry, right? If you have a requirement, we are willing to work with you. We want to work with you to understand your requirements and accordingly tailor the training program.
So we are almost at the end. I just have a very quick question for Siva. So we already discussed this stickiness issue, right? Especially with BTechs from IT. I know, I was one. So question for you is, are students enthusiastic about the program in IC manufacturing, or will they go to banking?
Okay. I'll give you my experience. I was also a JE chairman, and we actually conduct an open day. See, students are well aware of what's happening, right? So in some sense, when we conducted open day, people came and asked, are we actually learning this? So people, the younger generation is far ahead in terms of learning things. And the second point is, the reason why we carved out a branch separately is that when they enter with fresh minds. But seniors, they'll actually say, hey, A elective acha hai, A elective acha nahi hai. So in that particular sense, everybody will actually go towards job-oriented electives in machine learning, artificial intelligence, communications, any stream for that matter. So when we actually say that, look, there is a separate branch for you, and since JE is so popular, right? Anything sells, right? So you actually are making them focus in a particular area and giving them an end-to-end learning. So this approach eventually would actually give a change in the perception. Right now, machine learning was not there 5 years before, and it is actually popular right now. Only reason is job. Jobs exist and everybody can vouch for it, but the end learner does not know it. So it's incumbent on us, both industry and academia, to actually propagate this message that there is a job, and after you get trained, you're well placed. So if that message goes in, I'm pretty sure there is a factory of students that are going to.
Thank you. With that, I'll open the floor for discussions. Again, I would rather have a lot of questions. Please be brief. You want to say something? Oh, you want a question? Please be brief. Introduce yourself within 1 minute. Not so much comments. Questions, please. Thank you.
I have a quick question, because you just raised this topic. So because there is an opportunity for a job at the end of any computer science or any software related degree, people are taking that. So if somebody graduates in exclusive semiconductor fabrication kind of a degree, will they get a job in banks? Because probably that is one of the interests, because in case I don't get a job in the semiconductor industry, I still have the bank to go to. So maybe there has to be also a bank related, semiconductor related course also, so that you can tell them that you can invest, you can bank, you can go and then solve a bug in some software somewhere. Probably that will attract more number of students.
Okay, the answer for this, they're actually getting into banking not because of their knowledge, but because of their talent, inherent IQ. They're not looking at the courses that they will answer. They have actually looking at how is the person actually looking at it. So, I mean, the moment a student gets into a good university, there is a job assured, right? So there is a bottom of plate that's actually full, right? What are you actually filling up is what matters a lot, right? So we are not going to actually cater for that. The reason why we created a separate branch and doing all these things is to create a perception, right? We have to win the perception battle at any cost and show that there are jobs. And once that perception is changed, right? So we are actually solving a catch-22 situation and chicken egg problem, right? Which is first, right? Job is first or learning is first, right? So we have to actually work through it. And in this particular period, we have to actually train manpower for global system, right? When we actually make, at this particular point of time, we don't have manufacturing ecosystem in India. Train for abroad, no issues. They go to Taiwan, and when it comes back, I'm pretty sure they'll come back, right? 100%.
So here.
Yeah. Okay, good morning. So I am Bijay Krishnadas from IIT Madras, and it's a nice discussion. And particularly Siva is just a hero almost, I think, for starting the BTech program specialization. And also IIT Madras also, we are lauded because we have started BTech program jointly with Purdue University on semiconductor technology. That is also being lauded. But as a teacher, I have a slightly different concern. So specialization in MTech program is fine. But when a student comes just after +2, they are very much open. And right from there, if you just say that, okay, you stay here, I will be training you, I will be giving you industry ready. So I think probably we, instead of scaling them, perhaps we are killing them. I think traditionally, what we observe, what we actually target, that we should prepare them with solid foundation, and industry come, interview them, and train them according to their requirement. Why academic institute should come forward to get them ready for the industry? Thank you very much.
Okay, this is where I actually hard fought with several traditionalists in some sense, right? See, we are not actually deviating from the fundamentals, right? That is assured. See, first 2 years is fundamental learning. See, if you look at any curriculum over the past decades, the way it evolved right now is first 2 years, you're actually taught each and every aspect, fundamental aspect that's required. And after that, next 2 years, people are actually taking electives. It is with this that we are actually moving around and playing around and say that please take VLSI electives and learn chip design and go end to end, right? We are not actually depriving them of fundamentals at any point of time. So that is assured, right? In some sense, you ask for control systems, that is there. You ask for network theory, it's there. All the without basics, you cannot even learn VLSI, right? Forget about anything else. So in that particular sense, first 2 years, hardly there is a difference between an EC branch and electrical branch with some minor variations here and there. But absolutely, there is no compromise on fundamentals. But the applied part is actually going by the perception, right? Right now, if I actually learn ML interview, I can actually crack a Google job. I mean, in the 6th semester, that's what they look for. Now we actually say if you learn RTL coding, AMD will is going to give an offer for you. Right? That's the only difference. I mean, we are not, I humbly submit here, we are not actually trying to cut the base in terms of the foundation is still solid, right? And I've actually seen in IIT system, I've actually done my BTech in a non-IIT system. and I'm actually teaching in IIT system. The one fundamental thing that about IIT systems is a non-linear learning. In each and every course, I mean, you have 5 chapters. No professor cares about what the chapter is, right? They'll actually only speak on what the fundamentals are required, and then after that, you learn applied, right? I don't care. So that's the teaching that we're actually imparting in the fundamentals as well. Now, after that, now when we actually send them to the industry, right? There is a gap there. Now, if you look at it in AMD or any other institute, there are several PhDs who are actually doing it. There are several masters who can actually teach. They have a passion to teach. Allow them to teach in academic environment. Create a lectures wherein they can actually impart the knowledge of industry in academia, in academic environment. What would happen is they'll also enjoy, we'll also enjoy, and it's a win-win situation. Thank you.
Can I add to this? I'm sorry. I actually think it's a great idea to have a major in semiconductor technology. And I'll tell you, I have not seen it anywhere else in the world, right? This is the first. And why I think it's helpful is when I look at my own team here, I have physics majors, I have chemistry majors, I have material scientists, I have mechanical engineers, industrial engineers. And if you look at a fab, it's the same way, right? It's a truly multidisciplinary operation. And what happens is the traditional path has been, you come from one of the disciplines and then you learn the other things when you come into the company. When you have that, previously I mentioned the pyramid, right? When you have a pyramid where you're 10% of the cohort and 90% is teaching you, that system works. When you are the inverted pyramid and you have 90% of the folks who don't know anything about any part of this, you need a way to speed it up. And that's what I said, we don't have the luxury of time. This kind of a curriculum gives you a broad-based exposure to everything aspect of this industry and what you need to learn. I hope you include in there statistical process control. I hope you include in there things like the things that matter to run and operate a fab, including industrial engineering aspects, right? And one other thing that I will mention we should definitely make is one of the cultural challenges I face in India is we have some good things in society like respect for elders, etc. But I want my people to check that in at the door, because when they come in, I want them to challenge me. I want them to challenge the status quo. I want them to bring new ideas. I want them to, push for their innovation. There's a huge gap I see in the willingness of NCG or new college graduates in India to push for their ideas compared to what I see in the US. And I think if we can also impart that drive for innovation, that drive for creativity, and say it's okay to ask tough questions, even if this person is your boss, we should also build that in. So those are my 2 cents. I think it's a great idea.
Just to answer. Okay. Why should academia really train, and why shouldn't industry be responsible for it? I mean, honestly, it's a battle that's out there for talent. The industry becomes so competitive, and we really don't have the time. If there is someone who needs 2 months of training versus 1 year, I'd rather choose the person who needs 2 months and not 1 year, right? In spite of all the academic training the student receives and the certification, there's still a corporate level training that they have to go through. I mean, like what was just mentioned about corporate culture, how to interact, how to, deal with that kind of a pressure before a tape out. I mean, it's huge. There is enough and more things that they still have to learn in the industry, but these trainings and certification actually enhances their learning, right? They have that base from the theory. And how do we apply it? Actually running a practical PNR cycle or creating a small test bench that for a feature that goes into a chip. It's a very different experience than learning theory. So I think that's what we are looking for. If that gap can be closed, it just helps the industry to train them faster and make them industry ready that much faster.
Vinod, do you want to add anything to this?
Yeah, I think this is an interesting topic where we spend a lot of time in the talent development committee, and I also like to thank Jaya's great leadership driving these things. I think Rengesh, you mentioned some topics on other courses or skills need to be developed, and I opened a report and looking at it. Basically, for the manufacturing, we divided into three sections. Other than the foundational courses, one is basic VLSI design and test fundamentals. Then semiconductor technology, where you talk about technology architecture, how you move from one generation to next, and what are the key things you need to be mindful of, because that will be extremely important, because people go from every 2-3 years, you jump from node to node. What are the things changing? Why are we changing? Where is the focus? And those kind of things. Then it's good, like a power performance, those kind of things. Then some analytic skills, right? Yield engineering, some basic things, reliability and all. Then the third part is about the high-tech manufacturing and some basic business fundamentals. So this is where we talk about people need to understand a little more factory physics, quality system standard, design of experiment, basics on supply chain. Because when you run the fab, as you know, right, it's a supply chain and all these things you need to know very well. You cannot run shut down the fab for half an hour. So it's a different thing. So and the project management, and also I would like to highlight that Jaya actually insisted quite specific skills on time management, communication, and many other things. You just talked about how do you work in a multicultural environment whereby you should be able to challenge each other in a very constructive fashion. And at the end of the day, we had to get the best result from the team, right? And how do you create an environment for this? I think it was a great discussions from people from academic as well as from the industry during that. And a lot of these things are actually indicated in the committee's report itself. There's a specific section about the soft skills to be developed when you enter the industry. I think during some of the discussion, that was one of the another gap we found. And for example, if you look at the companies like maybe Lam or Global Foundries, when you recruit into Bangalore, of course they need to work with Germany, US, Singapore, all different cultures. So we also had to go through a cultural sort of bridging training, right? So it's very, very important to have all these soft skills along with the technology courses.
So Krishna here. So I just wanted to make one simple observation, because there were multiple comments about escape to banking, escape to software situations. So we did a deep study. I personally conducted a deep study into the acute talent shortage, which Jaya talked about, because if I get a call in the morning, I'm reasonably certain, and particularly from an MNC head, I'm reasonably certain it is about talent shortage. And I got really, really worried about the situation. So just to give the statistics, which I'm sure most of you may be aware, we have 579,000 seats for all streams of electronics and instrumentation and all together all over the country, out of which about 50%, 52,000, about 10% of them pass out with first class. And the industry takes less than 5,000. So the employability out of this 579,000 is less than 1%. So this is a hard fact. And that's actually what is causing the talent crunch, right? So we are now embarking upon, of course, there's a great report that Jaya's team brought out for the ministry. So riding on that, we are trying to get, how do we get the emerging institutes? I won't call them tier 2, tier 3, which I think is a little demeaning. So emerging institutes, how do we bring them into mainstream electronics design? By even launching a 1-year postgraduate diploma program where we address all these things, fundamentals, which is unless the fundamentals are rooted, there's no way we can teach them anything beyond that. And then actual practical implementation techniques in PNR or layout and things like that, and then in an industry project, all running to about a year. And we are trying to bring in CSR funds for this. So this is one experiment we are going to run. The other one is, the problem is not with the children or the student who comes to engineering. The problems are with the parents. That's again another thing which I'm sorry to say this, but culturally, IT or computer science, US, Google, that's it. The straight line equation. And if you don't do that, you are not good. I think this is something where we are dealing with. So I started a personal experiment, and we are now going to schools, 10, 11, and 12, trying to educate them about opportunities in electronics. And I personally ran at my cost an experiment in a place called Chennapatna, where they make excellent toys, gave them FPGA kits, asked them to create electronic toys. I will share the results in about 3 months with you. You'll be surprised. So maybe we need to go out of the cities and go to those places, challenge those children, and keep the parents away from the decision making. I think we will get excellent engineers.
Just 1 sec. Let me actually piggyback on that question a little bit to highlight a couple of things. So actually, this question is for Srinivas and for Akshay. So what are we doing from our ivory towers to make sure that we increase the base? I mean, a lot of you will go to the facility here. It's very swanky and all, but we need to help a lot more institutes. So what are we doing?
All right. From our perspective, look, one of the things that I think will excite students about doing research or doing work in this area is when they get hands-on skills, right? I mean, if you touch something, if you make on your own, that's when you get excited. I mean, you can see or read a lot of books, you can see things on computer, but when you make a device, that's when you would get excited. So that's one part. The other part, under INUP, what we are trying to do now, in this phase of INUP, there are 6 institutes. So each of these institutes, there are IISc and there are 5 IITs. Each of these institutes will work with a bunch of local universities, right, around that institute. And what we'll do is do a few things. One, okay, they want me to announce something. Okay, I will. Okay, one, what we'll do is we want to work with these universities to set up a facility. It need not be a fab similar to what we have here. It might be a much smaller scale, all right? In a lot of cases, they have funds. What they are lacking is some technical support in setting it up. Sometimes they even have the equipment. It's just that they do not have technical manpower to figure out how to run this on a continuous basis. If it breaks down, what do we do? Right? So we want to work with these universities to help them set up these facilities and run it. Okay, that's one part. The other part is what we are trying to do is, as a lot of discussion is happening, is how do we bring in courses that are related to this area, right? So we want to work with them and say, look, we will help you design courses in this particular area, and you can introduce them to your students. We will help you design maybe an MTech program if you want. We will help you in that also. So these are some of the things that we are doing. So the hope is it works in hub and spoke kind of model where there are 6 IITs. Each of these IITs helps about 6 institutes, and then they go on and help some of the other institutes. That's one of the things that we are doing. Oh, yes. All right. We also have something called Akanksha program that we run from our department. The idea is to bring in, get students at a young age. I think we, school kids, right? Specifically girl students from schools, they come here, spend about 2 weeks learning about the facilities. What do we do? What kind of research we do? How is it useful? So the hope again there is we catch them young, we get them excited when they look at the facilities, what happens, what kind of devices you make, right? Just the feeling of wearing a bunny suit and entering the clean room itself is super exciting. I mean, and we've seen this again and again, right? I mean, they enter, they come out saying, look, we want to work in this area. And I think that's very important.
Add very quickly, one of the recommendations from the committee was to really catch them young, right? Introduction of semiconductor courses in high schools and setting up Atal tinkering labs in the government schools. These were a couple of recommendations we've given, and I've already seen some of these getting implemented. Really happy to see that.
Yeah, it's working. I think it's all, as I start to answer questions, it all boils down to the motherhood kind of problems that we face today on ground, actually. I'll share one small practical experience which I had personally when I was dealing with skilling. The reason why I wish to state this is we need to start looking at things from a very different perspective. I will give you a small example. We did a CSR program with Bharat Electronics, and Bharat Electronics invested thankfully in setting up the entire infrastructure for an assembly line operations. And all the hard work was done. We had our first set of 60 people who graduated from this program. I really don't see a bigger industry who can come and offer them a job immediately. I do not wish to take names at this point of time, which industry or who came to hire these guys. I was really surprised with the kind of questions these students asked the industry person. And somewhere that drops a question, what are we trying to inculcate in all of these guys? I will give you examples of questions asked. What time will my shift start? Question number one. Will I get food, breakfast in office? Will they give me transport if I have to travel from here and to there? Is there a premises available near my house where I don't have to travel so much? I mean, if this is the kind of mindset that somebody is going to come out with, and he is a job seeker, right? I think somewhere we really need to think, what is it that we are setting as a standard for employment? Today, I will tell you, today people are happy going and doing XYZ deliveries, earning this. They don't want to come to an office. People are really not interested to come and work, right? And also there is a false precedence that is set practically on ground. Somebody is not joining you, so raise the bar. Attract them. Somebody is not joining you, raise the bar again, attract them. Is there a rationale towards incentives that are being given to employees at various levels? As of today, it's kind of irrational from an industry perspective, and it's a I would say it's a disadvantage, and it's the whole fact that you're paying more than what you should in itself is something which is defeating the idea or the vision of India having enough manpower, talent at an affordable cost, able to do things affordably, right? So I think it's not a single dimensional issue to be addressed. It's a multi-dimensional issue to be addressed. It cannot be solved by one person. So as rightly stated, it's not the industry, it's not the government, and it's not only the students and the parents. It's all of these three things together which has to come and change this mindset among this generation, saying that please focus on building a career rather than just earning money when you start your careers. I think this is something which needs to be drilled at a school level, and I really thank and appreciate the efforts of Krishna, which he's doing in his personal capacity to do this. And I think this should go more and more and more across schools, across people. I think the mindset is the first thing to change, and from there, everything else changes. Thank you.
Oh, yeah, so I have a question here, and this is the last question. I'm really sorry, but please go ahead.
If I'm audible, I'll go ahead. So now it's working, yeah. So I am Shantanu Sinha. Good afternoon. I'm heading the RF Devices and Packaging Development Division at the Space Application Center of the Indian Space Research Organization. Well, my question partly stems from the fact that I come from a strategic background. You know, we all appreciate that semiconductors is not all about CMOS and VLSI, right? This question is more to the panelists and as well as much to the panelists as to academicians who are responsible for framing curricula. Are we at all thinking about specialty semiconductors at all also? RF, gas, image sensor technology, all these technologies have a very good opportunity for students even commercially. So why is it that we are only focusing on CMOS, VLSI, and not these other semiconductor technologies which can fetch you probably much more than they would otherwise do you in a VLSI job?
Okay, you're blaming. Let me say we are not, that's not what we are doing. We are not concentrating only on CMOS. That's not what happens. In fact, we train our students on every aspect of fabrication and characterization of these devices, starting from how to make devices, all kinds of devices, right? RF devices, gas sensors, MEMS, microfluidic chips if you want, biological sensors, anything that you want. Not just that, not just make devices. How do you test them, right? How do you do reliability tests? Not just that, how do you package them? So in terms of training that we provide a broad level training. If a more focused training is required, a requirement comes from industry, we are happy to provide. But to our students, to the people who come from academia, the training is typically broad level. Of course, PhD students, when they have their own projects, they do something special, but in terms of the training that is provided, it's not very specific, directed towards CMOS. That doesn't happen.
If I may, Professor Vasu has a GaN fab right here producing GaN devices. And I think personally, this is just personal opinion, not speaking on behalf of LAM, but India's opportunity lies in this, to take leadership roles, lies more in the specialty technologies than at the 2 nanometer node, because it's just that much harder. So I think what Vasu's doing here is a great example of being at the cutting edge. It's very much more possible in specialty technologies. And now wearing the LAM hat, we sell equipment for everything. So we don't care which one takes off. So.
Can I make one additional comment? You can also look at the kind of startups our students have come up, right? One of them is GaN, and the other is bio, right? And healthcare. So there is a diversity there. So that clearly indicates you're doing something right.
Added to that, right? Just fun. Go ahead, Vinod. Go ahead.
So even the foundries, right, always diversify, right? The different technologies like silicon photonics, gallium nitride, because now electrification of cars has become extremely critical, right? That is also opening up significantly. That's one of the highly growing areas. So there will be always a diversification. But any specialized field targeting a specific sector, that I think for the foundries, it all depends on the business opportunities associated with that.
Yeah, just one quick comment. We realize the importance of these areas. One of the challenges that I actually see is you don't have, you actually search for digital faculty in digital or RF, right? You don't get too many faculty to teach those courses, right? Because the moment they actually graduate, industry picks them up with 5x salaries. So you don't get a faculty to teach them. And the second point is, even if I want to teach, I'll not be able to match to that level, right? So that is one of the gap areas that exists in academia as of now. One of the solutions is you come and teach, we'll enable, right? Industry should come and teach, right? That's the way that we should actually look for.
So I know we are between you and lunch. So we'll take the one online question. Do you think having a simple semiconductor lab in all the engineering colleges where a student will be able to handle a P or N type doping of silicon, what will it take to be implemented in all the colleges that teach electronics?
Look, setting up fab is a little bit expensive. That's one thing. I'm not saying. I mean, it's expensive, but I guess it's important. I guess the question is, to what level should the fab be? Maybe a simple fabrication. It doesn't have to be require dopings and other things. So that's gets a little bit complicated. But even if you make simple devices with a simple photolithography system, you can make a bit of an FET, you can make MEMS devices. Even that kind of training, if they can get, that would be really nice. I certainly, every engineering college, I think that will be, that will take some time. I don't want to predict how long it will take. That will take some time. It would be ideal, but I think we have to be a little bit more practical.
I have an orthogonal approach for it. I mean, if I may actually come in. See, if you look at it, right, what are we actually looking at in terms of training? You are giving a philosophy of photolithography. You want to actually give a philosophy of etching, and you want to give a philosophy of deposition. These are the three things that you want to do. When we started in 2004, when it was a empty ground here, in the facilities that we had in EC building, now we just did mask cap. But whatever struggle we had, we took an oxide wafer, put a shadow mask, make a mask cap. It does not work. But that's the most important thing. I mean, why is it not working? You explain. I mean, there you will actually learn the philosophies of what is a trap. I mean, what are all the issues with it? I mean, if you give a perfect device, the student will not learn anything. If you give a, not working device, there is a lot more to learn, right? So you should actually look at basic set of equipment, right? I mean, there are single mask. You don't need alignment process. You teach them. Exactly. Correct. Right. So, I mean, we have to actually think orthogonally in terms of getting least amount of equipment in a small little space, which is dirt free. That's all we need to look at, right? When I did my processing at when we started, right, we used to see dust as well. That's okay. I mean, I wouldn't actually pitch more than 1.5 to 2 crores, right? That, I mean, all the universities would have that money. I'm pretty sure about that.
So, okay.
It's not just, sorry, Sushant, it's not just about money. It's also about having manpower who can run this facility. That will also be an important component. Maintenance is a big issue.
Okay, so there'll always be questions. So let me take this opportunity to make a few comments. Number one, the whole point of this conference is to start this discussion, not end the discussion. So whatever thoughts you have, questions you have, I encourage you to email our website, send comments on email. We will collate all of this into a document that we can all share. That's point number one. Point number two, I think what Shiva is telling all the students out there, so when your stuff doesn't work, it's not your failure staring at you, it is just training. You're just becoming stronger. And actually on this topic of specialty, actually as a training institute, we actually have an inverse problem. So when we tell the MIT or the institute, look, we do training, and they're like, fine, show me, can you make a CMOS circuit? And we're like, we don't necessarily do CMOS, we do specialty things because that is where the future is. And they're like, no, we need somebody who does CMOS. So it's actually, our problems are inverse. We would rather do specialty because as an academics that we would like to do. Last, one announcement, the facility tours are going on. You can go. Lunch is in the science department. You guys should all have a map, so you should be able to walk. There's a photograph at the end of this session. So we request you all to congregate on the steps. We'll take a photograph and then we'll move on for lunch.
Yeah, thanks for that announcement. In fact, you saved my breath there. But there is one more realization together with the announcement. I think the one realization is that we should have a human resource part 2, because it's a very heavy, and then a lot of people have still not asked questions. There are a lot of questions which are coming online. So this is a good cue for our next upcoming conference. So please gather at the yeah. But before that,
thank you very much, all of you. You really, told a lot to us. It's a fantastic thing today. So Shobhan. Huh? Shobhan, thank you. You are the hey. So hold on. Thank you very much, everyone. Really, Sushovan, a script writer also. Like we know we should find out a way to send it to
I will collect from Shishovan next time when I visit him.
So
thanks a lot.
You'll have to come here, I think. Yes, yeah.
Yeah, sure.
So we'll gather at the reception here for the photo session at the front desk, please.
Vinod, thank you so much for joining.
Thank you very much. It was a pleasure.
Hello, mic testing.
ಇದೆಯಾ ಅದರಲ್ಲಿ ಇದೆಯೋ ಇಲ್ವೋ ಅಂತ ಗೊತ್ತಿಲ್ಲ.
ಮೂರಿದೆ.
ಹಾ ಇದೆ.
ಇದು ಇರ್ಲಿಲ್ಲ ತಾನೆ ಇದು ಅದು ಹೌದು. ಡಿಸ್ಪ್ಲೇ ಇದಕ್ಕೇನು ಇಲ್ಲ ಲಾಂಗ್ ಪ್ರೊಸೆಸ್.
Mic testing. Mic testing. 1 2 3. 1 2 3. Check. 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 Audible. Switch it on. So it's on the YouTube too. So one.
Hello. Hello. Am I audible?
Please, guys, this is not working.
This one should be on.
Good afternoon. People will trickle back from lunch over the next few minutes, but I guess we can get going in the interest of time. We are already at about 4 minutes past 2:30. My name is Vasu. I'm chair at the Center for Nanoscience and Engineering. And it's one of the few things I like to harp about the semiconductor industry is, as I said in the morning, that while the fab is important, there are many, many things around the fab that are as important, if not more, And the country that stands out as an example, for instance, is Japan. They do have fabs. It's not that they don't have any fabs, or they have not had any fabs. They've had big fabs in the past. But presently, even though they don't have fabs which are as big in volume as, let's say, TSMC or Samsung or Intel, they still control a big part of the supply chain. And that supply chain includes upstream activities such as materials, equipment supply, and so on and so forth. Then all of that feeds the fab, and then the chips come out, and downstream activities, the packaging industry, and so on and so forth. So it's a huge ecosystem out there. And of course, the supply chain also includes manpower, if you ask me, and that was the subject of the previous discussion. So to debate these points, especially pertaining to supply chain and consumables, we have an eminent panel with us. I can't think of a better group of people to debate these points. And as I had discussed with them in an email this morning, two of the questions that I asked of them that I would request them to touch upon as well is that to let us know as to what your ask is of the government as far as where you are and what is it that you would like to see so that you can better cater to not just the Indian, but also the global semiconductor ecosystem. So with that, what I'll do is I will start inviting the panelists in the order that I have on my page here. The first of these is Dr. Ashutosh Bhabe, who is co-founder and CEO of 14SI Solutions. Ashutosh qualifies chemicals for the semiconductor industry. And Ashutosh, if you could start from the end so that it'll be easier for the others to see me join. Yeah. And probably is among the very few people in the world who understands how if there is a contaminant in HF, how it could possibly come all the way from the ore from where the HF started. Mr. Digantas Sharma, who's the regional business head of Inox Air Products. We rely on them quite a bit for many of our supplies. Pierrick Godinat, application manager at Pfeiffer Vacuum. For a long time, Pfeiffer was the only company that serviced turbo pumps in India. I'm hoping that's still true. And otherwise, the bearing went bad, you had to send the turbo pump outside. Prashant Shakamuri, who is the managing director of the Hind High Vacuum Company, and they've been battling on the equipment front. I make equipment myself. We built quite a few reactors of various kinds, and I know how challenging it is even to build a research grade equipment, let alone something that can be sold commercially. Ravi Bhatkal, Managing Director, India for McDermott Alpha Electronics Solutions. I don't know if it is the biggest, but one of the biggest companies in the global supply chain for the semiconductor industry. Subrata Ghosh, who's a professor at IIT Mandi, and they have been developing photoresists, not a very easy task locally. Okay. And last but not the least, our good old friend Vikas Dabir, who's a senior director, India site operations at Applied Materials. So please join me. So it's a great panel, and we are here after lunch. So you have to give them a big hand. Great. So what I'll do is we can get started in the interest of time. We go 5 minutes per head. In case you have slides, I hope it has been shared with the team so that they can flash it out there. And so quickly introduce yourselves. We already know who you are, but more so your perspective on the problems we are facing as far as supply chain consumables go. So Vikas, why don't I start with you?
Hey, thanks for inviting us, and more important, setting up this whole audience, right? I attended the sessions in the morning also. It's a pertinent topic. I've been tracking this from 1999 when the first time I saw the rumor that Intel is looking at India. I'm still hoping it will happen, and I'm seeing a lot more traction. And I think somebody in the morning mentioned this is now in mission critical mode or something like that. But just a little bit about myself. I've been in semiconductors from 1994, spent many years in Texas Instruments in the back end, doing flip chip technology, and then did a few years in solar, like many of us, and then came back into applied materials to take care of the front end. I moved back to India in 2013 and did a lot of business development work. That's when I used to interact with a lot of the IITs and India Institute of Science. And for the last 5 years, I've been taking care of India operations. Applied Materials, as many of you know, is one of the largest semiconductor equipment and technology provider. In India, we are 20 years old. Some of you have attended my operations conference that we do every year. I do look to invite a few of y'all again this year. But we have grown as any other multinational in capability and numbers. I use the word capability before the numbers because the way we do it is we develop a particular capability with a proof of concept and then allow the business units to expand that and add people to it. So we are more than 7,000 people now. I'm very proud to say that every product group of Applied Materials, every business unit, or even KPU, the key product unit, has an engineering presence here. So they do have a presence. And now off late, like I said, after I started the operations, we started, due to the pandemic, supply chain organization. Before going to supply chain as such, so the value for any semiconductor ecosystem, if we look back at the history, right, I spent a lot of time during my TI days in Taiwan, Philippines. It is not rocket science. It is possible. They did it. And in the supply chain that I started after the pandemic, we are able to do it from here. So what it takes is patience. Semiconductor industry by far is the most conservative when it comes to change. Nobody likes a change. It doesn't matter even if it's a one-on-one replacement, our customers are scared about it. So it requires qualification. And this goes all the way in the value chain. So very, very important to understand is it takes patience, it takes time, but then the ramp or the hockey stick that we say is possible. So from the government, as we think about it, right, and I've been in multiple such panels saying the similar things, we need to think about it from an ecosystem, right from when you start with a bare wafer till a chip goes into your cell phone or your laptop or something. There's a big value chain there. And supply chain, as has been very evident in the last 3 years of the pandemic, plays a very critical role. So the government of India should think also on the same line, which they have started thinking. The most important part of it is to get the private players to think of the global market. The local companies, whether it's in Taiwan or Philippines, that support the factories there, and not all fab, even the assembly and test, they're local players that supply the goods. They started off on small scale, they grew into volumes. You need to be competitive in the world, and that's where we should look at. So it's very, very essential to spend time in identifying what is required and then developing it and have that 3 years patience. And that's where the government of India could, if anything, support in giving that guidance, that support that is required to get it qualified into a fab or an assembly test site globally. It doesn't have to wait. You don't need to wait for India fab. You don't have to wait for another Tata Electronics backend factory to start. You can start off now with the AACs of the world. There are a lot of assembly test houses in the world. Go start working with them. There's a big ecosystem here. TI is a big player here, which does get all the stuff done in Philippines or Taiwan. Even they have a couple of sites in China, big players. All the design houses are here who get all their stuff done. So you can get the contacts. Several of us who have worked on both sides have those contacts, have that experience. We'll be very happy to help support that ecosystem to get it there. So just now, switching to what I have done in Applied Materials, right? This all started because of the pandemic. And I actually attended a webinar that Gadkari was holding, where he made a statement that if there is any industry wants to relocate because of the pandemic situation, now it has even converted to geopolitical situation. If they want to relocate, the government of India is very willing to support. And that's how I took it to my leadership and said, hey, why don't we look at India's suppliers to support? So you can, we were, as every other semiconductor company, very concentrated in the Bay Area, Singapore, Malaysia, China, elsewhere. So why don't we look at that? And that's when I started looking at suppliers here. I did several conferences. I spoke at the CI conference, and actually we were able to get around 10, 11 people who were interested, out of which now I'm happy to say 4 are qualified and shipping parts to our factories outside. We don't have any manufacturing here, but they are shipping parts to our factories in Singapore and US. So it goes to show that if they have they all took time. It's not an easy industry to get in, but if you have the patience, then the hockey stick is very wide, very steep. I mean, sorry. The moat around it is very important also for you as an advantage. If you have the patience and can get qualified, you have an edge over somebody else who wants to come in. This is not a commodity business where every day based on the London stock market, commodity market, your prices change. It is not like that. It doesn't matter. You have to get qualified. And like I said, it is one of the most conservative company when it comes to change. We are the most dynamic company when it comes to change of technology, but very conservative when it comes to making a change in a process. So that's my 2 cents. Happy to be here and see all good young, some old friends and new faces.
Thank you. So over to you, Digantas.
Good afternoon, all.
Yeah, sorry, go ahead. Yeah.
I'm Subrata Ghosh.
Subrata, sorry. My apologies. Yeah, Subrata.
Yeah. So I'm serving IIT Mandi as faculty since 2010. And IIT Mandi is a new institute established in 2009. It's only 14-year-old institute. And it's sometime in 2012 that we started working on this area of developing photoresist. And it's not me alone. There are a team of 4 faculty, myself, Professor Ken Gonzalez, Professor Satinder Sharma, and Professor Pradeep Parameswaran. We have different expertise, starting from synthetic organic chemist to inorganic chemist to material scientist and electrical engineer. We work together, and then objective is to have some indigenous product. So initially started with the funding from Intel, and then target was to develop some EUV resist. But later we started interacting with SCL Mohali. And then it was very active collaboration, because when the objective had been to develop resist, then first, we need to understand the need of the country. So when we started working with the indigenization team headed by Paritos Jain at SCL Mohali, we understood that the urgent requirement is resist for deep ultraviolet lithography, DUV, and then I-line resist, as well as electron beam and helium ion beam lithography. So along with the UV, we also started developing indigenous product for those lithography system. And it's not just developing the prototype. Our, as I said, the objective had been from the beginning is how to scale up. And we have panelists here who will say, will comment on the quality and then the qualification. This is a very stringent criteria, metal contamination, many other contamination. So a whole lot of parameters we had to consider. We have reached to a stage where at least in a lab scale, few compositions we can make starting from few liters to gallon. But of course, we have to see how can we scale it up further. We are also thinking of a startup to now take those prototypes to the commercial level, and it's not just the photoresist now alone, because as Dr. Huda is here can say, in SCL itself uses more than 35 chemicals, and in one of the previous panel we heard that even ammonia, like the representative from Tata Power said, that even the ammonia, the quality we need that is not being produced in India. So it's like that level of purity we need, and as I know, probably all 35 chemicals are being imported at the moment. There is no indigenous product, but yes, the indigenization group with active collaboration with many academic institutes, they have come up with good number of chemical which are now at least the prototypes pilots are ready, and then next step would be probably taking up to the commercial level. So it's not just the photoresist alone. We have started also working with anti-reflective coating materials, some high purity solvents. There is another team at IIT Mandi, they're working on the slurries. So there also good development has happened, and probably the next task is to take them to the commercial level. So with this, finish here and then.
Hello, everyone. And Vasu, thank you for, and Tulsi, thank you for inviting me to be part of this panel. My name is Ravi Bhatkal. I run the India businesses for a US company called Element Solutions, which is our parent company. We have multiple verticals. The largest vertical is in electronic materials. We are sort of unique in the sense that we go from chip to box, from back end of line silicon, the copper damascene chemistries, the copper pillar bumping, all kinds of different bumping materials, packaging materials, spheres, IC substrate, interconnect materials, and all the way down to board assembly materials, PCB chemicals, and even the materials for box build. So it's truly chip to box. So we have a unique perspective on. Hello? We have a unique perspective on how the electronics industry functions from semiconductor all the way down. We are in 50 countries globally, including India. In India, this is our 92nd year as a multinational. We were set up in India in 1931 as a manufacturing unit of an old British company. And we started smelting operations in India in 1931. So we have a long history here. And we've sort of grown up with the electronics industry here. We are one of the largest, I would say the largest player in electronic assembly materials and interconnect materials in the country. So I am a material scientist by background. Graduate school, I did a lot of projects. I was telling Jaya Jagdish that I did a project for AMD developing CMP slurries when I was a graduate student. Anyway, long time ago. And I think, I've sort of evolved now. I'm on the business side, running our business here. I came back to India about 6 years ago. And since then, I've been bringing all our businesses and technologies to India. And we are a very technology rich company. So the way, I'll talk about localization, so to speak. We've been systematically localizing our technologies. And as far as, my view on how this will evolve, India started really in electronics manufacturing with final assembly. Then we've moved to board assembly. Then now we're moving more into packaging and then semiconductor. So the timelines are probably the near term evolution will be more in the packaging area because it's easier to implement. And then, of course, it's inevitable that semiconductor fab will come here. The ecosystem, as Vikas mentioned, needs to be built first, probably before the fab comes, because if the fab comes, you need a whole ecosystem around it to be built in order to support that. And that, when you really look at the key elements in any of these links in the chain, you're basically looking at people. The previous panel was talking about that. You need equipment, materials, components, and then the activities being design, modeling and simulation, the manufacturing process itself, and the knowledge of the deep knowledge of the manufacturing process, and then testing and reliability. Those, if you look at those as the key elements, then you basically need to have the entire ecosystem built around that. And that includes, not just, commercial entities, but also research entities, university-based research programs, research institutes, and technology centers, which really help develop both the technology ecosystem as well as the people. So we, we are a global company. The metric fundamentally for us, business metric, is as long as there is a financial return that can be demonstrated, the company is open to doing business. We've been in India for a very long time. And so obviously our management is quite comfortable with it. We have our global R&D center here in Bangalore, not too far from here, where we develop very advanced materials and technologies. And so the company is very sensitized and comfortable with India. So I personally, I'm very, very bullish about India and where we are going as a country. I've actually been spending a lot of my personal time building up these centers for advanced electronics manufacturing. We've set up one at IIT Madras, one at College of Engineering Pune, and the third one we're looking at in IIT Kanpur. We're also working with Basu and his team here at IISc. In fact, we started our R&D center here on campus 2003, 2004 timeframe, and then moved offsite. So, you know, I can say that there's a lot of like-minded people globally who can and will contribute to developing this ecosystem. I think it's just we need to come together and build it. That helps.
Okay, Prashant. Good afternoon, and thank you, Professor Vasu, and thank you to the CNSC team for having invited me to be a part of this panel. In fact, small Indian manufacturer in this eminent panel. So it's we've been around for a while. My name is Prashant Sakamuri, and I'm the managing director of Hindhai Vacuum Company Limited. This company was born out of the institute in 1965. So it started out as that, but though I've been working with them for about 37 years, but it is far older than me. But the challenge which Hindhai Vacuum had was that very few years after it was born, India went through a embargo at that point of time because of its then nuclear policy. So a lot of, if you look at our position today, because of various challenges that we have, it was basically related to a lot of things to do to a significant amount of time that the country was embargoed for technology flow into this country. So this was a time which actually contributed to a lot of capability building inside the country. We have to sometimes look back that a poor country like this in the 60s, in the 50s and things like that, why did it invest so much into technology and build a whole array of people? Because we could not build machines, we could not get machines. The next thing we did was, at that point of time, we created a whole lot of people and exported them all around the world. And today, a lot of them are coming back to give back to this country in some form or the other. That's probably one of the early exports this country had as far as technology was concerned. And for small companies like us, like we're a small company at the time, this thing, word vacuum was there. Nobody probably had an internet at that point of time. So they realized any company with the name vacuum, put them under an embargo. So that was there because they were associated with atomic energy. And that was the saying there. So that's how the saying probably the American administration of that time, which is there. Life has since then changed significantly from then. Today, the whole geopolitical situation has changed. You have this thing, we have a huge market now. Everybody wants to come and do business in this country, and this thing plus leverage this country to export to the world. So it is automatically business for everybody. So at the same time, this thing, it's also going to be business for us in domestically, and we need to create the right platform, employ a significant number of people to do things in this country. Because today, when we look at manufacturing, we're hardly about 16 to 17% of manufacturing, makes up the Indian GDP, which is significantly small for a country of our size, and trying to make a presence in world markets. Because initially we thought we would be a services company, then realized that if we have to employ the masses, we need that. And then it's a question of having the right skills and the right capability. Semiconductor, basically, when you look at it, the fab is one part of the whole thing, which is there. But the kind of jobs and the environment that it creates in its whole ecosystem is enormous. Because one is building the semiconductor fab and populating it with the machines, but it starts with right down from people who can make small machined parts, to people who can do piping, to various kinds of people who water manage. To the spectrum is extremely wide, and the minute you start taking up things up the chain, then, and basically, this always reminds me of something like, if you remember that at one point of time, the tiger was under, it was extinction in India. So there was a program called Project Tiger. The whole program was you protect the tiger, the rest of the whole food chain develops all around it, and the whole ecosystem of the forest to everything grows. Similarly, a very similar analogy would be setting up a fab, where then all around below that, the whole ecosystem develops in a very different way. So it's like people would say that, what do you get first? Sometimes the government makes the investment, get the fab. So a long back, the investment was made by the government. It was not that SCL was started, which was an investment which was started out to set up a fab in this country. It had its own challenges because the public sector, the way it is this thing, and the way knowledge was disseminated, and also the challenges of getting equipment into that. Then similarly, we had two other small fabs which came up either in Getek or in Sitar, but these were more for strategic business. So companies like us who are small tool manufacturers would probably leverage out there, learn a little here and there, and then we were in the process being instrumental in building a lot of university level tools which were used in university basic research, which were there, tools for things like PCVD, RIE, which was there for, and now we're even building ALD tools. But one of the big learnings which came out for us from our journey was actually how to take things from a lab down into production. We did that very successfully as far as solar was concerned, because in India, we were one of the leaders in doing research at one point of time in the mid-90s in amorphous silicon. And amorphous silicon was something which was done well. And we as a company were associated with the lab which was doing this work in Calcutta. And with them, we built a pilot plant, which then subsequently went on to build a production line. And this was a very, very cost-effective production line. But then the whole technology changed, and then, well, we parked it away. But the interesting thing is, this technology now comes back in another form in solar with the heterojunction technology. So in the heterojunction technology, now you have the solar silicon wafers now being coated with amorphous silicon, and you're back in business. So that's one of the new things going forward that we are working on. And our whole activity of getting into the semiconductor space immediately is going to be by taking baby steps to a large extent. Because like Vikas rightly said, this business has a huge moat around it. It is not easy for anybody to get into. It's this thing, and the entry barriers are so severe that this thing out there that it's worse than the aerospace industry. So it's so from that point, we will have to take small steps to do that. It starts right down. I don't think we have people in this country who can do machining to these standards which are expected to put metal parts into this thing out here, because there are different coolants which are used, different types of tips. These are all things. There's a huge amount of technology which is there even in Singapore or in Taiwan and all these things. So collaborations, joint ventures, having relationship management between various organizations like that, and trying to put up small assemblies together, which in turn will have to work with larger players. That is where the whole role of Indian equipment and tool companies are also going to come about to do these kind of things. So we have some amount of expertise, because the thing out here, we're working with clean rooms. A lot of our optics areas where we work in, and the optics division, they use clean rooms. So people within our group are familiar with working in clean rooms, clean conditions to a certain extent, but not the level of this thing. We work in class 1000 clean rooms. We're not working in class 10 and class 1 and class 100 clean rooms anywhere. There's a big difference as this thing, and every step basically like a hockey stick. It's like, you know, you're this thing as you're climbing this thing, one way is growth, the other side of it is equally steep to climb also. You can slide down very quickly, and that's the other challenge on that side. So, but I think the ecosystem for building equipment will slowly come, and it is very necessary, because we have very clearly seen that what can be done when you are, and if you don't have equipment building capability, you're politically vulnerable also. Because the recent US decision to turn the tap off on China, basically it's If they can turn it off on China, they can turn it off on you tomorrow. It's this thing. It's a decision that can be taken anywhere. It's a political decision. It's not that today we are friends, tomorrow you might not be. That's the thing. So the equipment ecosystem will have to get built up, and it will come and it will grow. And that is how it has happened in Taiwan. It has happened in all other countries around. And that is what probably will happen. And many small companies like us will come up, and all startups, and many more will grow along with that.
Thanks. So Pierre, you want to tell us about
Yes.
Pfeiffer and your troubles with the Indian system or successes?
Okay, so first, thank you for the organization and for inviting Pfeiffer Vacuum. Just a few words about myself, and then I will switch to Pfeiffer. So my name is Pierre Godina. I'm the application support manager located in France for Semiconductor. I've been working in the semiconductor for the last 23 years, starting as equipment engineers, and I switched to a process engineer developing TSVs and MEMS edge processes. And since 2011, I'm working on the pumps, especially on the process support. And I'm managing a team of 6 people working on application for the semiconductor. Pfeiffer Vacuum. So Pfeiffer Vacuum is a 130-year-old company supplying pumps. There is 2 headquarters, one in Germany, manufacturing mainly product for industry analytics and research also. And the second headquarters is in France, located in Annecy, mainly focusing on semiconductor. So this is where I'm located. In Annecy, we are mainly manufacturing and designing 4 types of products: turbo pumps for the semiconductor, dry pumps for semiconductor also. We are also manufacturing a leak detector, not only for semiconductor, but also. And we are also manufacturing some systems to measure contamination in the fabs. This is a quite new activity and very fast-growing activity. For example, these tools now, I mean, some fabs do not start without our tools, which measure the contamination in the clean rooms or in the FOUPs. What to say? So, as I said, 2 main locations for the production, Germany and France. France mainly for semiconductor. We also have other production sites in Romania, in Europe, and a big manufacturing site also in Korea, where are located our major end users. For the support, we have workshop and subsidiaries everywhere where we have customers in the semiconductor. So it means basically in all countries with big fabs, Singapore, Korea, of course, China, Vietnam, Vietnam, Taiwan, Japan, and US for sure. In each country where we have customers, we have workshops to make the support of our product. So all our products are repaired locally for most of the product. And if we switch to what will happen in India, so in India, we have a subsidiary, PV India, which is a 100% of a PV Pfeiffer Vacuum since 1995. There is 25 people in PV India. Sanesh, my colleague who is here, is representing the company. 25 people, among them about 15 people working as a technical support engineers. So today the main activity is to support industry activity, and also an activity which has been growing on the last few years is the synthetic diamond. What will happen with the semiconductor in India? So I'm not really in India, so I'm expecting something to happen. We are waiting, but for sure we will be ready. We had similar situation in the past in other countries. I won't go back to the situation in Korea because it started to be quite long time ago. Huh? It was 15, 20 years ago. We started from nothing. Today, Korea is about 500 people for Pfeiffer with a complete manufacturing factory. But other countries quite be a little bit similar to India. For example, I have in mind Malaysia. Malaysia at the beginning was supported by Singapore. But nowadays we have customers, for example, Infineon, which is starting to be very big. And the deal was that we had to put in place a local workshop close to the company. And this was done, and now it's working fine with Infineon. And I don't know what will happen in India, but this is typically the scheme that we will focus on, is to develop the workshop for reparation of semiconductor product in India. So PV India is located in Secunderabad. Depending on where will be the fabs, we will see where will be located the workshop for the semiconductor products. I think that's it for our presentation. Just one thing also, before there was some comments about semiconductor customers, which are, I confirm, are quite conservative, but it's not a criticism. They are, on one hand, they are very conservative, but on the other hand, they go very fast. They go very fast because as an application engineer, I have to face every day new chemicals coming, new precursors, new gases, and I have to manage this in our pumps. But on the other hand, the customer don't like changes. So we are also very used, for example, to copy exact, especially with OEMs. I confirm, but not only OEMs. Some end users also are using a copy exact, and this is very important to be able to manage this kind of requests from our customers. Yeah, that's it for Pfeiffer Vacuum. Thank you.
Mr. Sharma.
First of all, thank you very much for inviting me here, Dr. Savita and Professor Vasu. Very glad to be part of this esteemed panel, and I've been here since morning. And all the panels have been extraordinary, also the audience. A lot of learning since morning. Let me introduce myself. My name is Diganta Sharma. I work for a company called Inox Air Products. Now, most of you may be familiar with Inox movies, I suppose, in this room. So that is one of our group companies. I'm in the air products business. Basically, we are an industrial and medical gases company. So Inox Group started in Indian operations about 69 years ago. And in 1999, they formed a JV with Air Products. This is a now 25 plus years JV. Air Products is one of the world's largest industrial gas companies, headquartered in Pennsylvania in US. And between Inox and Air Products globally in the semicon and solar industries, there is about 30-40 years of experience in handling supply chain for gases in California, in Korea, Taiwan, China, Singapore. I was based in Singapore for 10 years before this assignment. So I have had very close interactions with people of the world, TSMCs of the world and Samsungs of the world. And I echo sentiments about the conservativeness that you said, and also the opportunity to grow very fast with them if you meet the specs. So in the gases industry, from a gases perspective, in semicon, we talk about PPBV level of purities or impurities. So that is the challenge that we have in the entire supply chain to keep. And of course, you can't deviate from anywhere. So our entire backend of engineering, supply chain, valves, production processes, QA systems, safety systems, emergency response systems, all of these have been designed to cater to these kind of requirements. So coming back to the supply chain issues, specifically of gases. I mean, I can reel off the names of the gases, but primarily you need two types of gases in semiconductors. One we call bulk gases, which are the nitrogen of the world, nitrogen, hydrogen, helium, to some extent oxygen. And then you need a bunch of small volume gases, nitrous oxide, silane, disilane, WF6, so many of them are there. And I also confess that the bulk gases more or less is now manufactured in India, but not to the specification of semicon industries, because there's no user basically in India in the bulk scale. So in anticipation of the opening up of the demand of the Indian semicon industry, we have now started to invest in so-called purification plants of nitrous oxide, of ammonia, of hydrogen. So these investments have started in our side already. Then comes the other one, the small volume gases, which are largely imported into the country. So between Air Products and ourselves, we have supply chain bases and other specialty plants located around the world, in US, in China, one in Taiwan, and one in Korea. So these are our sources of supplies. So from a point of view of able to support the industry when it comes INOX Air Products is, I would say, 90% ready today in terms of the facility and supply chain in place. Of course, the next phase will be when the demand is on sustainable basis, we will have to scale up locally. Now, this is where the chicken and egg story comes, and what is the IRR you get on an investment of a business that you do. And this is where really the rubber will hit the road. So that situation is evolving. We have got RFQs now from two companies in Semicon already. They are in advanced stages of discussions. So we are seeing how the progress happens. But until then, we have the backend import supply chain. So here, in the past, if you recall, just 2 years ago, we passed through the COVID situation emergency when we had huge demand of oxygen, medical oxygen. So if you look at our capabilities, I just bring this example because what we did in that time. So from INOX Air Products perspective, we improved the production of our plants all over the country. We have 45 plants which produces oxygen across the country. We increased the production, we changed the fleet, we improved our driver response times and a lot of other things. We work 24/7 in a war mission mode. And we're very proud to say out of the in the country, there is a requirement, those days requirement of about 8,000 tons of liquid medical oxygen per day. Half of that we met, 4,500 tons per day. And our normal capacity is about 3,000 tons that time. So we moved heaven and hell and everything we did. We brought oxygen by ISO containers, overseas shipping, railway tracks, air freight, with the help of Indian Air Force and a lot of government support also. So what we saw, and my personal experience, the government and industry and people, if we want to work together and deliver something, it is possible. Nobody died because of, at least for wherever we were there, nobody died because of lack of oxygen. So this is a small example of the kind of coordination in supply chain that we could do under pressure. And this is a planned process which is going to happen here. So I'm sure we have in India, we have the capability to anticipate the demand, anticipate the supply chain, anticipate the safety incidents that might happen for gases. And we are handling, for example, pyrophoric gases, silent, disilent, etc. So a lot of safety issues do prop up from time to time, and we have to be prepared for it. From the government side, we are also now in discussion with, there's a central body here, all of you know, called PISO, Petroleum Explosive and Safety Organization. So they are also learning about these semicon gases now for the first time, and licensing process for importation is starting. So obviously here is a little bit of a gray area because many people in PISO are not aware of some gas or what specifications, how to handle what happens in case of emergency. So we are in the process of learning, exchanging information and making this process a little bit more let's say easier to do. Otherwise, this is we see this as one of the bottlenecks in quick import supply chain of specialty gases for semicon in the country. So this, we have started the work, and I'm sure other companies have also started. Most of the clients that we are talking, they know this problem, and we are working together with them. So that part on the regulatory side, whose licensing side, I think it is under control, but it needs a lot of hard work and focus and with a lot of patience, basically, to make it happen. The other point that I want to say is about supply of gases right to the tool, right? So you have the gas cabinets, you have the orbital welded pipes, you have the scrubbing systems, you have all of those things. Yes. So these are the other area that we have been working in the past. So I'm very glad to say when Semiconductor Lab happened in Chandigarh way back, our company did the piping and did the gases and all this. Even Tata Solar here in Bangalore, when they started the solar fab, we were the one who was supplying gases and so on. So we have the in-house, let's say, experience and expertise. And we have another group company, which is also known as Inox India. They are in the business of large fabrication of large fabricated vessels of specialty materials like stainless steel, aluminum, like this. So all the cryogenic gases in the world, helium, hydrogen, all of these things, they handle, they have equipment. And we do in that company a lot of these high-end projects for example, nuclear installations, BRC, or here in Kalpakam, or ISRO launch pad here in Sriharikota was fabricated and delivered by us. And now this company is doing the so-called ITER project, ITER, that you know in France. the whole system of piping of helium, the entire project is with us. So we have the expertise in terms of doing the so-called fabrication of small diameter pipelines that you need for end-to-end supply of gases that is required in semicon fabs. We have another one that I just want to touch upon and close is what is known as total gas and chemical management. So in a semicon supply scheme, what is most important apart from safety is the uptime and the yield. So we don't want any contamination happening. We don't want any supply chain disruptions happening. So the total gas and chemical management expertise is another thing that we offer to the clients. So I'm sure we are in a good place. We are just waiting for the RFQs to flow in and we can start.
Okay.
Thank you.
Thanks. Ashutosh.
Yeah. Good afternoon, everybody. First of all, thanks to the organizing panel for having me here. So it's always daunting to be at the end of the panel. I thought that most of the points that I want to hit would be covered, but thankfully the supply chain side of the semiconductor and consumable side is so vast that I do have a few points to make, which is good. Just giving you a quick background. I'm Ashutosh. I'm the co-founder of 14SI Solutions, which is actually an applications as an engineering service, or applications engineering as a service startup based out of Sense. And we are actually in the world of the very important world of contamination control. Just to give you a brief background about myself, I've actually been in the industry for about 10 years, so much less than most of the people on the panel. But in those 10 years, I've worked in two different roles. So I've worked in the fab, in developing of photolithography processes at Intel for about 3.5 years. And after that, I worked at Integris, which is a material supplier. And that specifically, I worked in advanced filtration and purification, which is where my background for contamination control comes from. As part of that role, similar to Pierrick, I was actually an applications manager, globally managing a team of about 25 engineers. So that's really the long and short of what I've done. The reason why I moved back to India was to basically think about what we can do with the existing talent pool, with the existing knowledge that we have, and see how we can apply to not just global companies, but also apply to local companies. To give you a good perspective of the kind of contamination that we're dealing with, Diganta just mentioned levels of ppBV. In the liquid space, it's actually moved 1 order of magnitude or 3 orders of magnitude further ahead. Right now, the kind of products that you need or the kind of chemistries are used, they require PPT level of cleanliness. Some chemicals, and I consider ultra pure water to be a chemical, with limits pushing to PPQ. So there are companies that actually demand PPQ level of water, or for example, on metallic contamination. And what is also very interesting is that there are sort of 3 trends that are happening in this industry right now. So one is that there's a big increase much as the end product of a semiconductor fab is an electronic product, the building blocks of it are very much chemical and material heavy. It's a process that uses up to 500 unique materials. Chemicals especially are used at 4 million metric tons of chemicals are used annually in the manufacturing of semiconductors, and that's projected to go to about 8 million metric tons. That's a big increase in the next 5 years. And the reason why I'm stating these things will become clear and why it should appeal to the local ecosystem as well. The second point is that along with all of this, there is a tightening of specifications. So there's a big increase in demand, but there's also a tightening in specification. What it means is that larger volumes of chemistries need to be supplied at lower specifications. So what was okay yesterday is definitely not okay today, and will for sure not be okay tomorrow either. So there's a continuous tightening of limits, and people think of limits only in terms of the absolute specifications, but actually the problem is not just the absolute specifications, it's the variation in the specifications. So that range itself is tightening, and that actually is a much harder problem sometimes than just the absolute tightening itself. So you can see larger increase in demand for chemical, tightening of specifications. And at the same time, during COVID, I think all suppliers learned, and including obviously the fabs, learned the lesson that diversification is something that is grossly missing. And for an industry, for most industries, this level of monopolization would actually have not worked. In the semiconductor industry, as has been said in previously, it's a heavily monopolized industry. There have been consolidations, and every single parts of supply chain, for example, are owned by companies. So there's a big there's sort of a big moat around these industries. But at the same time, in the chemical space and material space, there is a big request to diversify your supply chain, because people were scrambling to get even the simplest of materials, like even a simple PFA valve or PFA fitting was impossible to find during COVID, and the lead times were in years in the peak of COVID. So what's basically happening is that these three sort of trends are starting to converge at once, and this actually, in my opinion, provides a very unique opportunity for non-incumbent suppliers, because at the end of the day, there is a push towards localization, or at least go into a friendly, quote unquote, friendly nation, or friend shoring, so to say. So there is a unique opportunity for Indian suppliers to really think about what they can do and how they can contribute to this ever-evolving industry. There are a few challenges, obviously, but they're fairly surmountable problems. All it needs is some targeted efforts in terms of value addition. And this is where actually our company is sort of positioned to help, because we have a fairly long experience in understanding where contamination comes from. So what we do is basically identify, trace, and mitigate contamination at the source. And the key word here is at the source, because as contamination percolates through the system, the impact of that contamination exponentially increases. What would take a few rupees or $1 to fix suddenly becomes a multi-million-dollar problem to fix if it shows up on wafer. So the goal of our company is to find contamination specifically in liquids to begin with, but we will be doing gases in the future, but specifically in liquids to find where exactly is the contamination coming from and how can we solve that at the source. So with that, I'll stop. Thanks.
Okay, so thank you all. We are at about 3:25, so we have 35 minutes more. So I'll ask each one of you a targeted question. We probably have 2 minutes per head, and then there'll also be enough time for the audience to go forth. So I'll start with you first, Ashutosh. It's kind of scary that you have to get to PPQ. And if the aim of this... No. He said PPT and then PPQ after that.
As well, correct.
All right. PPBV, PPT, and PPQ. That's what he said. And the aim of this panel is to figure out how we could set up a supply chain from India that could cater to the global demand. And also what your ask is of the GOI to be able to do that. So given where the Indian chemical supply chain is at, isn't it a daunting task? Because this will be a daunting task even for traditional supply chain people. So wouldn't it be an even more daunting task? And if that is the case, what's the solution in your opinion? 2 minutes.
Yeah, so it's definitely a daunting task. Don't get me wrong, not trying to minimize the problem at all. It's actually, it is actually a problem. We are at least 2 to 3 orders of magnitude away from where you need to be. But there are basically what the way I see, there are 3, I mean, there may be more problems, but there are 3 fundamental problems. One is the lack of technical know-how in how you handle chemicals. Like how do you take care of, how does chemical go from grade A to grade B to grade C, or whatever the grade is as you climb up the value chain. So that technical know-how has been lacking because there is no demand. Once there's demand starts rolling in, you need to start planning for it. Once you know that there's demand coming in, you will automatically seek the technical know-how, either through collaborations or by improving your manufacturing processes itself. 2, there is actually a lack of there also needs to be a fundamental change in understanding contamination, or basically doing a deep dive of the value chain itself. Like what does it take to make a chemical? Very often people focus too much on the quality of the final chemical itself, but they forget that, and this is a problem I think which happens even the big manufacturers, and I'm sure it happens in the local ecosystem, is that very often you're so focused on fixing the final chemical that you actually forget that the inputs that go into the chemical are actually your major contributors. And we, like as part of Integris, we wrote a paper which basically indicated that you could do all the hard work of purifying a chemical to the grade that you wanted. And in the step of dilution with water, that's where you end up basically ruining the entire quality of the chemistry. So what the industry needs to do is basically look at every single entry into the system, like to manufacture the chemical, and really do a deep dive in fixing that, because that's the only way you can really understand where problems come from and how do you fix them.
So sorry to cut you off, because
yes.
So bottom line is PPQ from India in a reasonable time frame, production and qualification is possible.
It is possible. It is possible, but it requires a lot of patience. It'll require a lot of back and forth, and it'll require upfront investment. That is undoubted. Like you cannot expect it for nothing. It's going to take a good amount of concerted and targeted efforts to get there, but it will get there if you are committed to that cause.
So my next question is to Digantas.
So I have given some thought to your question, because you had kind of leaked the question paper. This question, right?
No, so I'm going to ask you a different question
question.
now.
Okay.
Based on what you said.
I was happy that question was leaked.
I was hoping you would answer that question in the first round, based on which I could ask you the second round. Anyways, my question for you based on what you said is the decision on the rubber hitting the road, like you said, doesn't just have to be based on Indian considerations, right? You could even cater to the global supply chain when it comes to specialty gases.
Yes.
Because there's also this diversification given geopolitics that everybody is looking for. So why does not the inox air products combine move some of the both high purity bulk as well as specialty gases supply and production to India? What's stopping you from doing that?
Yeah, I mean, there are two things. High purity bulk actually doesn't travel. So you have to make it where it is needed.
Right.
So it's absolutely, if you need it in, let's say, Dorera, you have to make it there.
Okay.
But the other one, the specialty gases do travel. And as so far we have, as I said, around this region in Asia, there are plants already. But this focus here is on indigenization. And if we look at the supply chain, I was happy to hear this answer, comment from the professor in IIT Mandi that there are already some things that already things are ready for commercialization locally. So our aim would be to see if local ecosystem can be, if we can take that and commercialize it, if we can get purification technologies for ammonia locally, if we can get purification of nitrous oxide locally, extraction of silane locally. Because if you look at China, for example, which is the latest country to come to the semicon business, this is what they did. The industry and academia work together. They put in a lot of money, government of China, and the R&D system, and then they commercialize those products. So if you go to anybody today, supply chain in China, all of them are in the institute startup people. Most of the CEOs, if you see, they came from that route. So I also think that in India we can do it. We have a good ecosystem of academicians. We have the willing government, and this is asked from the government. The government has to then step up and say, okay, we give you some incentive or some underlying funds commitment to do this process.
But still, again, sorry to cut you off. What prevents the inox? The technology for purification of specialty gases exists.
Yes.
So what prevents the given current geopolitics and the want to diversify supply chains to move part of that production to India?
No, we are already doing, as I said in the beginning, two gases, nitrous oxide and ammonia. These two we are already doing in the process of establishing.
I see.
But there are 35 other gases
Correct. So
that
what
needs
about
the
those,
same thing. So those are in a smaller scale.
Right.
The technology is not that easily available.
Right.
So this is where we need the help.
I see.
The other help that we need from government of India is that if you put up a capex of, let's say, 500 crores to set up a facility to do all this, they should give us same incentive that they give it to the semicon producer. And why not? Why restrict it to only them? And we are the supply chain. Give it to us also. Right. So this is another ask that we could we request the government of India.
We'll put that in a document. Yeah. Are there any strategic reasons for governments to say that you can't move this purification technology to India?
No, so far there is no restriction. India is open market, so no restriction as such. But you have to pay the so-called technology transfer fee. Then whether it'll fit in the business case or not, that is a question to be seen.
Okay.
Yeah.
Okay. Thank you so much.
Thank you.
So Pierik, you said that you have a production facility in Korea. And I'm guessing by production, I don't know what is the extent of production facility you have in Korea compared to the ones you have in France. But would the announcement of a fab result in doing something comparable in India? Apart from a service facility, have a production facility for turbos and such?
Who knows?
No, but what would it take
I mean, for the moment, there is no plan to open manufacturing of pumps in India. But we will see what happens in the future. For sure, we are waiting for opening fabs. For sure, we will open workshops, local workshop to support all the products that will be installed in our at customers, turbo pumps, leak detectors, dry pumps, especially for the dry pumps, because this need to be very close to the customers, because the rotation of the product is more frequent compared to the other products. You are talking about Korea. The factory of Korea now is as big as the one in Annecy in France. We made a huge investment in the last 3 years, and the goal of Korea is, of course, to produce product for Korea, but also to produce product for all Asia. And in France, most of the product will be dedicated to Europe and US. What we see now is that we already talked about the pandemic consequence. The semiconductor has been very big in Asia for years and years, but now there is a big trend to come back in the US and in Europe. And we need to reinforce our capacity of production for these two territories. So for US and Europe, it will be made in France. For Asia, it will be made in Korea. So now concerning India, where will the product will come from? Are they going to come from Korea or from France? I'm not sure exactly, but we will have sufficient capacity to supply pumps for India. Now let's see. In 10 years from now, I don't know what will be the market in India. The doors are open for sure. Okay. We have the capability at Pfeiffer to open facilities, either for production, but also for R&D centers. For example, recently we opened 2 R&D centers close to our customers. One is in California, close to OEMs. So we call it Silicon Valley Innovation Center. And we got another one, Innovation Center in Korea, very close to our major customers. So where we have customers, we develop activity. We will see what happens in India.
If you don't move to India very soon, the diamond industry will start making turbo pumps here.
I mean, concerning turbo pumps, we have a very large capacity increase because the demand on the last 2-3 years has been very big from OEMs. So we have increased our capability for turbo pumps, and I'm sure that we are ready to supply all the turbo pumps needed for the next 5-10 years.
Okay, great, thanks. So a quick question to you, Prashant, as you talked about Project Tiger, and it's indeed true. I think some studies have shown that for every dollar that's invested by the government in the semiconductor industry, the economy grows by about $10 to $20 all around. Yes. Now you do what, and I'm going to give Vikas a hard time, even AMAT and LAM don't do in India. You build equipment here.
Yes.
And world over, I mean, equipment's parts are bought out from various people, they are assembled, and in the assembly lies the USP and the process you have on it. So let's say you have to cater to the global supply chain, you're already at a disadvantage because you're importing many of these things, assembling it here, and then supplying it to somebody out there. So what is it that you think the government could do to enable you to better compete on the global scene?
There are two aspects of this. One is that when you look at a tool or a system, it is the strength of a tool is about basically or I would say the weakness. The tool is as weak as its weakest component. So the component supply which goes into the tool is probably critical. So that is where you have to be very picky about what kind of components that go into it. If you have got component manufacturers today, it is today the biggest challenge of why we do not have the top end power supplies or the mass flow controllers or the thing is sheer volume. We just don't have the size of the industry out here. The industry is very limited. So and when we are importing that, we don't get the best prices. When when you're looking at what, I'll give you an example of a company which makes a power supply, which is one of the leaders in the world. The price at which they sell it in China is almost just a little more than half of what they sell it to us. So that is the price difference which comes in, because it's just that people buy it in that volumes in that country. So even when we are talking about buying pumps today, because with one vacuum company, I will not use names now, this thing, we have a special relationship, we get it at a particular price, but the same company in China gives it to somebody else at a much lower price, though we have a transfer of technology from them. We bought out part of the business, everything. In spite of that, they still charge us more than, it's just the volumes. Volumes make a big gain. And that's going to make a big difference even in India if you're going to be competitive to supply to the world. So that is why from a government perspective, it is about creating demand, which is going to come about, and pricing is all going to be about demand and supply. So in fact, that is where today on the solar side, they have been quite successful. They have created the market. They've the PLI scheme for solar has now said we have got almost about 10 big players who have signed up from it from end to end. And one of those things have been that, and a lot of them are really looking forward to the indigenization of the tools. So in fact, that is where our first foray is actually going to come in now, because we are already working on crystal growth furnaces for the Czechoslovakian pullers for the this thing, and the same puller can be used also with a very small modification for the semiconductor industry if there is a need for making wafers at this in the next stage. So we will be ready with that in a couple of years. Like I think you probably know that HHV and ASM Technologies have put together a joint venture, which is this thing out here. And these are the forays, because HHV and ASM together are going to be doing. ASM is a leader in providing engineering services in this thing, and they're good, very strong on engineering support. So putting these skills together, we are trying to put together crystal growing furnaces and large area PCVD tools, which are going to go in for the heterojunction. We are building on ourselves. We are not going to be highly diversified going into every other thing. We want to focus on this and go on that. But I think from a government side, they will have to find some way to support Indian industry by like a PLI equivalent or a subsidy of some sort if we are going to be exporting the tools. That will make us competitive.
How about concessions on the import duties on the components you export, given that you're now going to export the final outcome? Do you get that?
That really doesn't seem, because if you're going to export, you anyway don't pay customs duty.
I see.
So in today, the taxation is not a problem, because in the morning also somebody was raising an issue about spares and components. Today, there are mechanisms to do that. There are bonded warehouses are available where you can keep goods there and you can draw it at the time of required. You don't have to technically bring it into the country. They'll be held, theoretically, they'll be held on international space, and then they can go. All these provisions are there. It is just that we have to learn how to use it. It is also, it's about like finding your way around in this country. The ease of business is not very high, but if you've been around for a long time, you know your way around.
So it's essentially a volumes game right now.
It's purely a volume game which comes.
Okay, thank you. So Ravi, you are probably one of the world's biggest suppliers of materials for the semicon industry, and you're now supplying out of India. If you would be able to put a number, what fraction of your global revenue comes out of India, and what is your biggest hurdle in raising that even further?
So we operate slightly differently, which is that we are very, very decentralized. So when we do business in India, it is mostly for India, and which is why we're sort of slowly moving up the chain in India. I'm talking about, but we have facilities in Korea, we have facilities in Singapore, China, Taiwan, and so they serve those. I mean, our businesses in those countries serve those countries. So yes, we will export some materials to South Africa, Middle East, and surrounding South Asian countries, and we do also with Southeast Asia. But we are very, very decentralized. So our business model is a little different. So when we are bringing technologies to India, it is mainly to support the India ecosystem, so to speak.
And the Indian ecosystem itself has grown significantly in the last few years.
Dramatically.
The packaging industry.
Yes, absolutely. Yeah. And so that's why I'm saying that, when I look at our own plan and how far we have come in the last 6 years, it's very dramatic. We are a decent barometer for what's happening in the country. And that's why, as far as I'm concerned, as I said, I'm very, very bullish. I can see the signs that the country is moving upstream fairly quickly. I think, I forgot to mention what is the ask, as you mentioned. I do think I agree with some of the other panelists that if the government can help industry cross the chasm is the demand, right? And often what happens in these situations is that people end up with the chicken or the egg situation, is that, you don't invest because there's lack of volume. There's lack of volume because the investments are not going. And so somebody has to break that vicious circle, right? And I think that it's already beginning to happen, but I think it needs to move upstream in the supply chain, in the ecosystem building. And if that is done to a certain extent, I think it'll go a very, very long way. I would say the simple thing is that, as Vikas mentioned, I think the ecosystem has to develop first. And so taking those steps in a very systematic way upfront would be very, very critical.
Okay, great. Thanks. So Shubrata, you probably in a very challenging space. You're developing photoresists, which are probably among the most sensitive of chemicals that's there in the
all chemicals. Yeah.
Semiconductor industry, and you're developing it internally.
Yeah.
That's fantastic. So congratulations. Yeah. And I'm guessing you're also working with SCL to qualify these. What is the smallest feature size on which you've tested these chemicals?
So SCL needs DUV and I-line.
Right.
DUV 180 nanometer.
Okay.
I-line is much bigger, around 400, 450, 400.
Okay.
But apart from that, electron beam and helium ion beam we have been developing. So there, the latest feature we got 15 nanometer line space, the dense feature, 1.5. And isolated single nanometer. It's like around 7 nanometer.
Okay.
Yeah.
So as far as these chemicals are concerned, the first question is, I'm sure you have global competitors.
Definitely.
So
Definitely.
The first question is, what is your USP?
Yeah.
And the second question is, given that there would be a USP, how do you expect to scale up and then compete globally? And if, let's say, there is a pathway, what is your ask of the government of India? Because this is something that's very unique.
Correct. So of course, if I writers start thinking of competing with JSR, Sumitomo, and all this, I think it's a bit early to think.
Right.
But at the same time, as the first question is like, can we manufacture in India?
Right.
Mostly we are just getting from them, but we are not manufacturing. Now to do that, the first thing we need to do, it's a photoresist. If I just talk about photoresist, it's a composition. Now in the composition, there are a lot of ingredients. Now all the raw materials, first of all, we have to develop in country. And for that, for certain raw materials, we have been working with different industries. For an example, though it's a very old technology, but still, India doesn't produce any island resist. And for that, there is one particular chemical which has a kind of explosive units. And, I didn't really take a risk to start that, manufacturing of that raw material in my lab. So I was talking to different industry in Hyderabad and many other places. And ultimately, we could, establish a process through a company in Pune. It's a startup again. But now they're confident that they said they can give even 500 kg. So it says like it takes time, but thing is like first we need to establish those kind of ecosystem, and then I think the production cost will go down drastically, and probably we can start competing with them. Now, as you said, what would be probably the ask from the government? I think this is an area probably again the volume, that is what was not forcing, because now whole country we did a survey, and then we went to all the fabs, including we came to Sense few years back, and then the current statistics is the country is producing somewhere around less than 1,000 wafers per month. Now if we really talk about more than 30,000 to 40,000 wafers, if all fabs starts functioning in India, then it's like we can increase. Like now less than 20,000 liter or so, that's the chemical requirement. Okay, but it will be few lakhs of liter. Okay, so thing is like, but then if you see the investment in the academic institute has not been so much. So probably the first thing, some specialized, special investment on the specialty chemicals for semiconductor manufacturing. It is something it's very much needed.
So what's your time frame to get something out there?
Some of the
I know it
think
requires a
within,
lifetime,
within,
but yeah.
within a year probably. Yeah,
Great.
few compositions definitely will,
Excellent. Excellent. All the best.
Thank you.
I know it's a challenging space.
It's very challenging.
Yeah.
Those qualification and those. I
Yeah.
think Abhishek is there to
Yeah.
help us. Yeah.
I'm glad I don't have to work with PR anymore. My students have to, and all the humidity related challenges that we face here. So because you said that you put together a supply chain post-COVID in 3 years, and this was, I'm guessing, supply chain to build equipment in the US or to supply chain to bring something in into India?
Yeah, so before that, right? Before I answer
Right.
that, I'll just take you up on what you were asking, Prashant.
Okay.
And I've been in this industry like many of us for a long, long time.
Sure.
The value addition in R&D and engineering is much higher than manufacturing. So I don't care about manufacturing. I love the other countries to manufacture as long as the value is stayed with India. And that's what I focused on. To answer your question in supply chain, we are exporting everything from local suppliers, nothing to do with India. We are not waiting for the supply. That will come eventually. I've been patient enough. It will eventually come. And we are a global player. The equipment for those fabs will go from wherever it is. We'll add that more capabilities to support those equipment, etc., sales team, etc. But what we did in supply chain was we looked at the demand where it is. And from where we wanted to de-risk for the country. Like I mentioned, right? We were very concentrated like every other country. Bay Area, Malaysia, China. So how do I de-risk that? What are the capabilities that I could immediately start from here? And we were successful. It took time. I mean, it took me 3 years to reach what, $5 million now, which is peanuts in the spend that we have. But it is a great first step. Plus, most important, the company's executives now believe it's possible. I think that's a mindset change. You won't believe the number of visitors I've had from Jan this year. Every week there is somebody or the other who wants to see my suppliers, see what we have done. So it's a great start.
So given the fact that you established the supply chain from India for a certain capability in the US, what was the biggest challenge you faced in doing that? I'm sure you must have faced many challenges, but what is the biggest challenge?
Can't be done in India.
Can't be done in India.
NIH, not invented here, so cannot be done there. So that is, and all of us, we have lived on both sides of the world. So I know I've been in Singapore, I've been in US. That's a challenge. Showing them that this is possible here, that hurdle is an internal hurdle. It's not an external. There's no external factor in this. But it takes that perseverance, that's where our technical abilities, I think we all have done a basic education here. That technical ability that India has, as a natural thing, I would say, comes into play. The perseverance, our ability to analyze data, that analytical ability to really go solve those problems and show it overcomes. Finally, we are all engineers or technologists. Data speaks for itself, but it takes time.
So that perception challenge would have to be overcome from people across the supply chain board.
Absolutely.
And a few examples like these would help, I'm guessing.
Yes, it does. Like I said, I've been flooded with visitors. I have another visitor tomorrow from our variant branch. So, it takes a while. I don't want anybody, I think all of us recognized and mentioned, there's a big moat. It's difficult to get into this industry. And not because we don't like it, because we have learned over 50, 60 years. That knowledge is not documented somewhere on the internet. It's all in people's brains. So getting that, collaborating with people, showing them that we have the technical ability to do that is what it takes. And like I mentioned, right, this is not rocket science. And I spent the early part of my semiconductor industry visiting Taiwan and Philippines almost every month. They build that up. We can easily do it here.
Excellent. So what we will do is we'll throw this open, but before I do that, the 2 questions I asked you in the email, if you could send me a written response, it will allow us to put together a document that we can send across to the government sources that we are
Don't ask us to send you in black and white, man. Then I have to get my legal involved.
Okay, then you can send me a WhatsApp message. Don't worry. Okay, 15 minutes. So we don't throw it open to the audience. Manish is here, so go ahead, Manish. I think there's mic right there.
Thank you for the nice discussion over the panel. To add on to what Professor Subrata was saying and what Professor Vasu was saying, actually using the material and developing the material and qualifying the material for the fab application is a marathon. And any fab which is established, if you ask them, established in terms of process as well as qualified the material which they are using for the standard products, as somebody was saying in the morning, is very hard to move them. Okay, change the material. Even not change the material, change the source from they are sourcing the material. That's the biggest challenge. Now, if we are in the business of developing the chemicals, resist, one of the hurdle is, I think we have faced with Professor Subrata and his team, that we have to convince ourselves whether we can use this material in my fab or not, despite Dr. Asutosh and his team qualify on the particulate side first. If that is qualified, then I start developing the process. If process is qualified on one set, then I have to run for the short loop engineering. And then SLE is qualified, then the integration engineering. And the integration in engineering, then qualifying the whole fab and process to use that material and generate a change in material node. Okay, this material is qualified, and then go ahead for ready in the fab. So now the question remains whether we are following this very particular path where we will be qualifying this material, whether we should have a separate fab for that, or anybody like Vedanta, Foxconn, ISMC, or say Sense, or any center of excellence would take that responsibility to qualify these materials. I'm not saying on the chemical and gases part. It is also true for the material part, where I think Hindai Vacuum Applied Materials knows much more than anybody else in the country right here, sir. Qualifying a process module chambers part for the kind of a process where the chemistry is very vigorous, and qualifying its reliability for the long term. If they want to change their supplier, they have to qualify the supplier first. Same is the case with sir. If he has to change the material, it is a different ballgame. Only once he prove his product in terms of it is qualified for the particular side, then the process side, and it is ready to integrate in any fab line, that is the success story. But there has to be a mark and step in which we need to follow it to make it worthy, so that any production on the supply chain part, either on the equipment side, material side, has to be supported by a system who can really qualify the process. Now, the question again arises on us, sir. He qualified the material, say, for DUV resist, so a line is required for DUV. If he is qualifying the resist for the EUV, who will be the taker for that? So these are the questions where we need to be very, focused, and we need to, suggest to the governments, yes, we need this kind of a facility if really we are interested in venturing in this kind of a stuff. Because let me tell you, sir, everybody knows 65 nanometer node, they need 650 processing steps. For 28 nanometer, 800 steps. 5 nanometers, almost 2000 steps.
Manish, I just got a...
Okay, sorry. Sorry.
No, but that's a very valid...
Conclude actually whether we need this facility, how we need to nurture them for long term.
Next panel. But that's a very valid point. The concept of a fab for qualifying is something that I think has now been mooted in many panels.
We also face a challenge because we were qualifying the component for the space.
Right.
And the QC for the space people are not allowing me to change the material. This is only small for pilot line, it is true. Right. What was the scale of?
Can I respond?
30 seconds.
Yeah, so every big fab has developed beacons for this. So don't try to reinvent the wheel. Yes. Follow what these companies are doing, at least initially. Every one of them has an NPI group, new product introduction group, and you have to do the same thing.
Yes. access to that group, I think, is a challenge.
My point is that the way Samsung has an NPI group, you need to have an NPI group.
That's government need to take the part.
Exactly. Exactly. Go ahead.
Hello, my name is Jaydev. I'm consultant for clean rooms and utilities. Question is to INUP gas, not INUP theater. Okay. So we have a lot of confusion in procuring the gas distribution system, starting from phosphine to go to the ammonia. See, gas cabinet and panels. Basically, two concepts. One is SEMI-S2 standard certified. Other is SEMI-S2 compliance. So this is making a lot of confusion to people who are using that. In my opinion, SEMI-S2 standard certified is more safer than compliance. What is your opinion? If you want to produce in India, what is the plan IONIX have done?
Thank you for the question. I think very valid. So we are seeing already demand in the country for SEMI-S2 certified components, not compliant components. So as you know, after you build, it takes about 3 to 4 months to certify it. No Indian company has come forward yet for our products. So we are depending on, let's say, people from Singapore or Korea currently to do this. So that is the process that we are following currently. In future, if a third party develops here who can certify, we'll have to do it. But SEMI-S2 certified is the gold standard, not the SEMI-S2. Yeah, so this is what we are working on. As I said, currently we are doing from overseas consultants, but nobody in India is able to do it. But as the supply chain demand things improve, that will be probably the natural next step, because if the volume increases and competencies are developed locally to provide the certification, obviously, why not?
It is taking more than 8 to 10 months to import.
Yeah, 6 to 7 months to manufacture, and then 3 months for this certification process. And then in that, if you have any semiconductor part, that is another long supply chain.
Thank you.
Thank you. I think we are short on time, so we will close this panel here. So let's give all our panelists a big hand. It was a very nice discussion. Thank you.
Thank you. Yes.
Do I have to pose for a photograph? No? Yeah. Okay. Thank you. All the best. Thank you. All the best. Give me 4. Okay. Thank you. Yep. Thank you. No. I assume a memento for you.
Thank you very much.
Okay, thank you. I'm going to get 2 of these.
You will get. We'll take one back. Don't worry. Yeah. Thank you, everybody. It was wonderful, really. Again, gives us an idea of what we should do in the next version of it. So we'll move on immediately to the next session, also very packed. This is existing facilities and pilot plants. I will invite Professor Shankar Kumar Silvarajan, who is a moderator for the next panel session. Please. You can leave it here. Yeah. Oh, yeah, he's coming here anyway back.
Okay, let's move on without wasting time. So this is the next panel discussion, and also the last panel as well, which is going to actually cut across everything that we discussed in the morning, right? So building a fab, and having people to work in the fab, and then having a supply chain. Actually, we struggled with all of this, and we have built, and there are fabs already in the country at different scale, right? And serving different market or user. So this particular panel would like to discuss this existing facilities that we have in the country, and this include academic fabs, and then strategic fabs like ACL, and there is also a facility at SAC, and you have GATEC like facility from DRDO, Sitar also DRDO, and then we have this, semi-commercial fabs, not necessarily semiconductor. This is related to electronics and packaging as well. So the idea of fab exists, and we do have infrastructure, and we have been managing it, right, for different targets. And here with me, I have 7 panelists, right, to discuss and get us their perspective on what the existing facilities are doing, their motivation, their mandate, and discuss about the challenges and the opportunities that we have going forward, and put this in the context of the current ISM program as well, right? So how are we going to support the program? Because we are already here, we are serving a market, but then this is a big opportunity, and we all feel that we should be able to support, and if so, in what way? Let me invite the panelists. So we have a good spread from strategic to commercial and academic fabs. I'll go by the list that I have here. So I would like to invite Professor Bijoy Krishnadas from IITM. So IIT Madras EE in particular. So along with IISc, Bombay, and other fabs, IIT Madras also got a nano fab that is serving research and development in the area of micro and nano. Next, I would like to invite Dr. Manish Hooda, who is Head of Technology Development, the ACL, Chandigarh, which is currently with MIT. And next, I would like to invite Mr. Krishnamurthy, CEO and President of IISa. And then Dr. Santanu Sinha from Space Application Center, Ahmedabad, representing ISRO. No. So let me also request Vasu to join, who is, I will. So Vasu is going to represent gallium nitride, foundry ecosystem that he's trying to put up. So he's not anymore a chair till you complete this panel. And then I would like to request Dr. Muralidharan to join us. Was very rich experience. We're lucky to have him with us. So he has, seen things come up, developed fabs and ran fabs for strategic sector. So we'd like to hear from him, what it takes to run these fabs and what is the mandate and how we can learn from his experience. And then I would like to invite Dr. Vinod from Centum. Please. Right. So it's a well-decorated panel. As I mentioned, we have a very good, spread of people covering industry to academia, multi-user fab to very specific product line, fabs, and so on. So with that quick introduction, I would like each panel members, starting from Vasu. No, you came late, so you can start last in, first out. So, so why don't you briefly, give us an intro about this this gallium nitride pilot line that you are trying to put up, and the need for it, because there is already ACAD fabs in the country, and we ourselves have a fab. So what is the need for it, and what is your outlook as an opening remark?
Okay, can you hear me? Okay, so this has been about maybe a 20-year exercise now. And to some extent, it started with what Shantanu asked in the morning as to why silicon and why not some of the other things like gallium arsenide, gallium nitride, and whatnot. So I have been working on gallium nitride for about 23 years. And about 5 or 6 years back, actually, it's 23 now. So in 2015, to be more precise, we were graduating quite a few people, and then we asked the question, okay, all these, highly skilled people we are graduating, they are going abroad. And so now that we've set CENS up, the obvious next thing to set up in India is probably a fab where the skill that is coming out of CENS can be applied. That was one. And the second thing was we had gone as far as we could in terms of making both the material as well as devices in the existing academic fab. And we had kind of hit a limit. So we started talking about it and discussing it. And we asked ourselves, actually, back then, as to what is it that India should set up? Because we had been in discussions with the previous wave of, these fabs having to be set up in India and so on and so forth. And that's when we came to the conclusion that, look, it's going to be difficult for us to compete in the silicon space. And therefore, and this is back in 2015, now it's becoming difficult to compete even in the GaN space. In 2015, we decided that silicon photovoltaics was also very crowded. And if anything, India should look into setting up something commercially on the gallium nitride front for power electronics and RF electronics. So for those of you who may not be very familiar with GaN, you probably already used white light emitting diodes that go in your bulbs. But however, gallium nitride electronics is emerging. Gallium nitride RF electronics have always been used in radars since the late 90s. But of late, gallium nitride devices have started coming in for power electronics. If you have to convert DC to DC, AC to DC, and you want to increase the power density, increasingly people have started using GaN. So if you buy a highly compact cell phone charger, it might very well say GaN inside or something like that. That is the power electronics bit. And as far as RF electronics is concerned, anything to do with, let's say, beyond 3-4 gigahertz all the way to, let's say, 100 gigahertz. So all the latest 5G remote radio head units contain GaN in them in all likelihood. So these are two areas in which even back then we had anticipated GaN would find increasing demand. And therefore, we approached the government of India and said that, hey, look, we've tried to set up silicon fabs. It's not working out. So maybe India should try and set up a commercial GaN fab. And this was for something of the order of 100 to 200 wafers per day. So to give you a feel for that number, it's still relatively low compared to some of the higher end silicon fabs, such as the one TSE runs, which is northward of 1,008 to 12-inch wafers a day. So we went through it. And after 4 or 5 years, even though we were not able to set up a full scale commercial gallium nitride fab, the government said, okay, why don't we at least start small? And therefore, by the way, one of the biggest hurdles in all of this also the fact that to set up a fab, you have to buy land, build a clean room, which itself would have taken 4 or 5 years. And so if you want to do something quickly, why don't you set it up in the existing clean room in IISc? And that's how we embarked on setting up this quote unquote small volume production fab. It's not an academic fab, it's a small volume production fab, maybe up to 10 wafers per day. And we hope it will cater to at least a low volume requirement for RF and power gallium nitride products. We hope to be up and running by about October to December timeframe this year.
But you're yet to answer that question, the final question I asked. We already have a tool set to process this gallium nitride as a material.
Okay.
Why do you need a separate line?
No, okay. So I briefly touched upon it. I didn't elaborate on it. I had said that in terms of developing gallium nitride materials and devices, we had already hit the limits of performance that we could with the existing sense fab. So for example, we would make devices and then, one out of maybe 100 devices would work when the device size goes up. So the yield was very low. And as far as the material is concerned, the existing reactor we have is a 2-inch reactor, but a production scale reactor, we need to go up to 6 to 8 inch. So both to scale up the yield and quality, as far as GaN production is concerned, we had to go beyond what is possible in our academic fab. And fact remains, and many of you who use fabs will know that to get to higher yields, if you use a tool for one process, you'd better off only use that process on that tool day in and day out. But in an academic fab, every tool uses every possible chemical on earth. So progress is very slow as far as process optimization and establishing a process flow is concerned. And that is why we had to set up a dedicated small volume production facility for gallium nitride alone.
Thank you, Vasu. So let me move on to Dr. Vinod. So we know Centum is one of the success stories, right? So there's a long history and you are expanding, which is, we are all happy about it. Could you just briefly give the historic background going from electronics to now moving into the semiconductor space? So what is your perspective and how do you think the learning that you have is going to help you and where Centum is placed going forward?
First of all, thank you so much for making me a part of this wonderful seminar today, workshop. And I would also like to convey that I represent a narrow band of the semiconductor ecosystem, which is being talked during the entire day. When I say narrow, I represent not the design part of the semiconductor, not the testing part fully, but definitely the packaging part. So I would like to convey that I represent a packaging part of the semiconductor ecosystem. And it's also further narrow because the focus is clearly on the strategic side, not on the automotive or the telecom side, at least as of now. So with that background, if I have to answer the Centum's story in terms of how we have been moving and finally arriving at today at a spot where we are contributing to whatever is little happening in this area. Actually, we started as a microelectronics company, which means we started as a component company. We started as someone who started using the semiconductor devices in bare die form. And then, of course, as a part of our growth journey, we moved up the value chain and moved towards subsystems, systems. And today we talk about building payloads and platforms, etc. So while that has been the journey upwards, but the core DNA with which we started was the microelectronics. So the die bonding, attachments, probing, testing at a semiconductor level is right there, right from the day one. And it continues to be there because even at the systems, these continue to be core part of what we do today. And hence it continues to be there. The journey, again, the focus has come back. We are not left the focus on the components because we continue to be a part of niche module developers out of these semiconductors. We may not be packaging, though we package semiconductors per se. And like Professor Vasu said, we have been very proudly associated with some of the journey that he mentioned as being the industry partner for the packaging of the GaN related devices. And we have worked with Professor Muralidharan and Sense on packaging attempts for both RF as well as the DC device, the power devices. But today, focus on Centum, on semiconductor and its allied areas is to provide nicheness in the components, which otherwise were not readily given to India. I'll give some examples later in the program, but I think that is something which we are focusing. So we would be happy to contribute, but limited volume, medium volume, high reliability, high technology, niche applications. That's what we represent.
Why not large volume?
I think the large volume is a different game. If you look at it, it all starts from 100% inspection, traceability, recording, all of that to a statistical driven thing, from a very slow moving, slow looking process and a product line to a high speed product line. from an extremely high cost, high focus, high reliability to a high reliability plus very cost effectiveness domain. I think these are clearly two different ball games, and I think they need to coexist and not get intermixed, because if you try to mix one to the other, you will be not getting the best out of both. So I think that is something which we strongly believe, and there is a place for both these places. And right now, I think there is enough for us to do in low volume, medium volume, high reliability.
So my interpretation is it's a strategic decision.
Yeah, it is a strategic decision. Yes.
All right, good. Thank you. So let's move on. Very interesting thought there. So let's move on to Dr. Santanu, right? So Santanu, you come from very strategic, application-driven development, very focused. And we heard in the morning that how the embargo has affected a lot of businesses. But if you look at the two success stories, the atomic energy in the space, they thrived because of the embargo. So could you share, how these challenges, right, that you have in front of you have made the organization technically strong, and you're learning from that, and how, going forward, those learning could be used?
Yeah, at the outset, let me thank all of you for having me here on the panel. It's a privilege. So I am Shantanu Sinha. Thank you for the kind introduction. And I head the RF Devices and Packaging Development Division at the Space Application Center, which is one of the prominent centers of the Indian Space Research Organization. We are located in Ahmedabad in Gujarat, and our primary responsibility is the development of payloads and instruments for various satellite missions that ISRO does, be it communication satellite, navigation satellites, Earth observation satellites, weather monitoring satellites, or for that matter, even interplanetary missions. Now, we have been doing that since the last 4 decades. And in doing so, we have set up a range of microelectronic capabilities in-house within the SAC campus that have served us pretty well, in accomplishing all these missions. And I must also acknowledge, at the very outset, the contribution that our industry partners like Centrei have had in all these, efforts of ours. So talking of the facilities that we have at our disposal at the Space Application Centers in terms of microelectronic fabrication, we have a host of tools, right from thin film deposition to thin film patterning. When it comes to lithography, we have access to E-beam tools, laser direct light tools, and simple lithographic tools as well. We have a couple of dry etching systems, a dedicated DRI at that, which is a luxury, I would say. And all this, has served us or has put us in a good stead when it comes to future niche technology developments in the fields of advanced RF, quantum, and photonics devices. I must say that SAC started off as a design house, right? So we were very good at our designs, but we used to tape out all of our specialty semiconductor designs using foreign foundries. But that has changed over the past few years, particularly the last 5 years, with the realization that embargo, as we understand it, can be lurking anywhere, and it can hit you hard anytime. So we have started working on semiconductors, not because everybody else was also jumping onto the bandwagon, but because it was the need of the hour. Having said so, it's not only semiconductor manufacturing that SAC focuses on, it's also packaging and board level assembly of semiconductors to build entire systems for space use that we have a good handle on. We have facilities for board level assembly, dielectric thin film based RF module development, as well as assembly. And of course, it goes without saying that we have also all the right reliability testing tools for all of this, because space is unforgiving. Most of you would know it is unforgiving. And none other than Dr. Vinod would note so, So space can hit you really hard if you have not tested your products for reliability. So we have a host of reliability testing facilities also at our disposal at the Space Application Center. And I must say that we are really fortunate to be part of the SAC fraternity, in the sense that its designers, fab engineers, test engineers, characterization engineers, all rubbing their shoulders with each other in the same campus. and trying to stretch each other limits and challenging each other on a daily basis. So that's what, motivates us. And with this, I think we are well placed now to also, develop the next generation of semiconductor systems. Vasu mentioned that he's coming up with this very promising company that would do RF as well as power semiconductors using gallium nitride. We are also doing so in our own very small way. We are not competing with you, but it will be only dedicated for our very niche applications that we have for space. Yeah, that's an introduction to the Space Application Center.
Let me just follow up with one question. So the luxury that we have in a CAD fab, right, or even strategic fab that is looking at future generation and so on, you are tied to missions, right? And there are delivery timelines, and ISRO projects and programs are known for that, right? So how do you tackle this? You have to be innovative using new technology, yet you need to meet the timeline. It's very tough. Do you have any quick inputs on that?
So the philosophy has been, do not try to do something that is totally new. Go after indigenization of something that has already been proven.
Okay.
A case in point is our recent development of the low temperature co-fired ceramic based multi-chip module foundry. This is something that we were using for heterogeneous integration of our systems, disparate semiconductor technologies being put on a single platform. But for most part of the last decade, we were importing those modules from outside, particularly the US. This technology, by the way, was already proven by then. So we thought, okay, this is one technology now that we know is worthy of space use. Why not do it in-house as well? Given the fact that there are very few suppliers outside who can, scuttle the supply any day. So we'll build up a foundry at the Space Application Center based on LTCC. And those modules, I'm proud to say today, are flying in hundreds now in space. And the dies there in those modules have been assembled at Centum, many of them. Yeah.
Excellent. All you care about is whether you can take off and put it in the orbit. Nobody cares.
Reliability is the name of the game, my friend.
Okay.
Yeah.
Okay. Thank you very much for the opening remarks. Let's move on to Dr. Huda. So I think there is a recent change in the profile of SEL and so on, but it's one of the showpieces. If you look at the technology that we have, the fab, the size of the fab and what you run there, the tool set, the people. So there is quite a lot one can learn from that. Could you just give us, where SEL is placed as a fab today, and the technology that we have today, and the outlook towards future technology, and how this new semiconductor bus, right, is getting affected?
I have a few slides. Thank you for giving me opportunity to speak on this platform. And I use some slides to do some cross-sectional analysis, what we have been discussing right from the morning till the end. So if we go, is it okay?
Is it switched on?
Can you change from there?
You can change it from there. It's okay.
So we have been discussing that whether we should enter into the fab business or not. And there are a lot of naysayers, and people are saying that we cannot do fabrication in India. We have proved them wrong, though, over that period of time with the SCL, what they are being doing for the space application qualified component, which are being used for the space technology. So if we can build high reliable components, as Shantanu was mentioning, then definitely we can do the commercial business also. There's no obstacle in that. And why we need to do that, sir? Because the market demand is there. A lot of demand, which has been projected almost $540 billion by 2026, if it is so. And even for our country in India, it is touching around $67 billion. If we are importing everything, then there's no use. We are selling we need to work on the kind of a making component in terms of making our own component for own consumption as well as for the global market. So can we go to the next, please? I'll just go quickly on few aspects to set the stage. Government is saying we are going to the Digital India program, and we are pushing the technology to the next stage and using the technology to all common purpose. And without doing it on the semiconductor components, either it is compound semiconductor or silicon based, there is no use of talking that we are really digital in this world. And the strategies which we need to follow, of course, we need to create an ecosystem favorable. We need to create an ecosystem for product development. And of course, the ecosystem which should be supported by the resource as well as supporting the ESDM and electronic manufacturing cluster within the country, with a focus on electronics for the strategic application as an add-on to this, and focus on innovation and R&D. When we are talking about focus on innovation and R&D, we have been discussing right from the panel discussion 1 and 2, but I will give some one or two go ahead for this. In the next slide, please. Next, please. And we can leave this. Push and pull factor has been discussed. So the point is that the vertical of high-tech manufacturing and India's core strength, ideation, technology development, proof of concept, product definition, validation, supply chain, volume production, and product support. This whole has to be addressed in a sense where we need to realize where our strength and how to utilize them. And what the cluster we need to build over it so that we can really make it possible that yes, we can make the silicon component within the country. People used to say in the morning, we are good at the design. Of course, we are good at the design. We have, people are using our talented manpower. This is a blunt, sir. They are saying that we have the design house in India, but the IP is owned by other country. They are utilizing our brain, then sending the product outside and then selling it to India. So this is what the business is making of. You ask the people whether you are ready to load some of your design in an Indian fab. You know the answer. Next, please. Whether we are ready for this. Next, please. Understanding, go, scroll down, scroll down. Understanding what are the obstacles. Now we need to catch the bull with the horns, and bull is running towards us. He is pushing in the corner. Because if we are trying for R&D to the final product, we are following all the manufacturing and see the verticals. Everything is being imported. So everything is being imported, then can we be commercially viable? Then ROI question remains unanswered. If somebody is saying, putting a volume up to a certain stage, I will be doing the ROI within 7 to 8 years, I say no, it is not possible. It is not possible until fab is having its unique IP. One very beautiful question was asked in the morning, what is the IP status? Now, let me tell you one good example everybody might be knowing, sir. Intel Foundry Services has put in foundry services first time. When Taiwan TSMC was making the foundry, at that time they are saying that Intel was opposing to that. IBM was opposing. There should be no foundry services. It's not a workable model. And now TSMC, everybody knows. Intel was after MediaTek and Qualcomm to load its foundry from TSMC, product from the TSMC into their facility in US, which they are in the stage of building the foundry. And Intel can convince them though, and not fully to load the foundry for the IPs and product from the TSMC to them, but partially. Can India fab can do this kind of a agreement with the fabless companies to support Indian semiconductor mission? Biggest hurdle again. So apart from this, this is one of the IP. We need to develop our own IP over the period of time, starting with some of the IPs for the domestic market. And it will be good if we can onboard some of our design houses to load the fab for the kind of a component or the product which they are selling in our country. Policy has to be made in a sense they can really go on these design houses. Okay, if you are utilizing our brain, load some of the product with it, and selling the product in India, load some of the product in Indian foundry. Doable business. Next, please. And supply chain system. We are saying that bulk gases, specialty chemicals, wafers, all verticals has been discussed since morning. And in the previous panel also, it has been very elaborately discussed. Next, please. But the kind of a consumption required, these are the highly specialty gases or chemicals which are required to support a semiconductor fab, right from say 180 nanometer to say 28 nanometer, purity almost same. It's once 5N or 6N, not more than that even. Next, please. And if we say on the bulk gases side, we are good at using bulk gases like nitrogen, oxygen, hydrogen, argon, and helium. They are required for different application, and their consumption is normal meter cube per hour is given here. We are a very small pilot line, as sir was saying, the example. If I need to scale it up, what will be the consumption? Of course, sir, the purity level is required in part per billion again. So the level of purity available in the bulk gases system in and around India is, say, I would say 99.9% pure. We need to have the local purifier in the system because they are the bulk in requirement and cannot fulfill the requirement with the kind of a cylinder capacity to feed in the fab. So arrangement can be made for that. Next, please. And the purity level has been defined here, right up to say 14 nanometer fab. This is the purity level which we required for the fabs. This is for the bulk gases only. Next, please. And of course, if we are seeing all the verticals of the supply chain, which is required right from the source to the supplying the gases, chemicals up to the system, they all are being imported. Okay, next, please. And of course, if we are talking about the specialty gas, if we are producing in our country also, scaling up the production of existing infrastructure, we are not fully aware. We are to how to handle high chemical purity system, how to store them, how to fill them, how to transport them, if they are pyrophoric in nature. All that education has to be developed. Only then we can say that, yes, the chemicals and gases which we are making within a country can be utilized and can be delivered to the point of source where it is going to be used. Next, please. And on the clean room size, say wall panel, raised floors, ceiling grid, filters, everything is being imported in mostly United States. Next, please. And now the consumption requirements. I'm talking a simple, if we are at 1,000 wafers start per month at the max, our consumption in the bulk gases is this. If I am scaling up to 15,000 wafers start per month, the consumption rate is like that. From the bulk gases side, sir, we are fully aware that, yes, this can be supported, but the purifiers need to be installed at house. And of course, the generator and the storage plant has to be made in that sense so that they can really pump this kind of a requirement in the fabs. High volume manufacturing scale up has been shown here. Next, please. Supply chain issues.
Probably we'll stop here because supply chain is already discussed.
But I will go to the next one straight.
So I just want your view on SEL as a current fab. So you have a history.
Yeah.
But then you have mentioned that whole supply chain, right? You need to have R&D, development, packaging, and everything.
Yes.
So do you see SEL doing all this together, or do you prefer to do a certain part of this chain and let other specialized fab come up for packaging or doing R&D?
That is a very good question, but there's two ways for that. Whether we are really having any fab in India.
No, not today. I mean,
no. Just let's go step by step.
Right.
Whether we are having any fab in India, until unless that fab is there,
right.
Are you ready to lose your existing facility in India? Okay. Right. If any fab is coming, then scale this facility for the center of excellence.
Right.
Where you can increase the capacity of this fab, sure. Utilize all the verticals of this fab, right from the design, say fabrication, then reliability, packaging, testing, reliability, quality assurance, and packaging. All these verticals for IP development or scaling up the facility, new advanced node innovations.
So my understanding then is you want the whole ecosystem to be upgraded there.
Yes, upgraded so for high volume manufacturing.
Okay. So I'll consider that as your opening remarks and your inputs. We'll build on that in the next round. But let me go to Bijoy. So Bijoy, you are part of this an academic fab network, right? IITM is part of it. And being part of this network, there is also a mandate to have manpower generation, support startup and industry, right? So what is your thoughts on the current status and what are you doing there in IITM?
Yeah, thank you, Shankar. Yeah, and it's a wonderful meeting, and I also thankful for the organizer. So yeah, so thing is this all the nano facilities. Let us talk about a little bit what is the background of these all nano centers. I think Basu, all other know better. I think first two nano centers were established, one in IISc and another in IIT Bombay. And about a decade later or so, 5, 6, 7 years later, so then we at IIT Madras got another center, a little bit lower scale. Because these centers were mostly focused on sensors, CMOS electronics, etc. Then mandate was given to IIT Madras is that you go something different. So should be recognized, centers should be distinguished separately, one should not duplicate. It should be different. So we went for a Center for NEMS and Nanophotonics. So mostly driving was, our strength was MEMS, and also some CMOS electronics was there, but also photonics was brought in. I joined in 2006. So we were working with our microelectronics facilities, micron feature size. So once we got these centers, then we tried to build different area. Different type of projects we started working on. Photonics is one of the driving things. And one of the mandate is that we have to go for something prototype level research work. That is the demand from the ministry. And then at the same time, our demand is as a faculty, as a professor from the IITs and IISc, for example, that our main product is our student, research scholars. So their training is most important. So one thing is that our primary target was to create a lab ecosystem. So you need to create some kind of protocols, some type of recipes you have to develop, but this some research scholar, they will be working in different area, different type of recipe. You have to, you cannot rely on standard CMOS process facilities like SCL, whatever they are saying. So there are different type of exotic materials, different type of devices you have to work on. That is one thing we have to, we had to work. We still continue to work on that. And another thing is that, you know, this type of centers are very expensive in Indian context as well. So running these centers, running this high-tech equipment is very difficult. To retain the manpower, it is also even difficult. One point is that salary is not matching. Once they come and you train them for 1 year or 2 years, they get job elsewhere. For example, I can give you one example. We have a e-beam lithography system, and we try to train one project. We keep a project staff, train them. Within 1 year, they get job in Taiwan or Singapore. They are leaving. So that was one of the major thing. So how we are overcoming that? Now we are trying to just somehow giving better salary from many resources, and also we are involving our research scholars, PhD student, postdoc. They are getting involved, and we are trying to motivate them, involving them into research, so that whatever we are publication comes out, we are involving them also. That is how we are going through. And then another thing is that how we are trying, I think in IISc or IIT Bombay, there are centers when they come out with some certain kind of technology level in a certain area. So they go for startups and they go for different type of like gallium nitride, any other startups are there. So we are also doing in a certain different direction. Startup also already also in our mind, but what we try that, so while different research going on in the center, different areas, different projects running. If you see that certain area is moving very nicely, taking shape up something, so we cannot go for prototyping and up till technology readiness level 9 or so because of our lack of ecosystem. What we do, we create a center of excellence in certain area. So for example, we have 2 center of excellence that spin up from our center CNNP. One is AMOLED, that is for organic electronics. And then second one is silicon photonics. So where we are actually focusing product research, development, manufacturing model. So their entire ecosystem, we are focusing only on silicon photonics. So some process development, as well as some kind of what you call design, device design, and testing facilities, everything we are trying, and also up to some prototype level. And we are involving a lot of industry as much as possible, so that in future we can go for some, we can feed also whatever outcome comes out. If any foundry comes also, whoever it is getting trained, they can also be useful for them. And another good point is that, so probably this is my very personal, all of us talking about skill development, etc., all those type of thing, we need a certain kind of skill development. That's why that is very much needed for industry. But problem is that whoever we are training, whoever graduating, so from our centers, etc., they are not sitting, they are getting good jobs also. So we don't need to really training wise or whatever wise, we don't need to tweak completely different thing. Actually, whatever existing things are there, little bit 1 or 2 specialized course, if we include, that would be good enough to update, to keep up to the market. So that is my vision. That is my point, what I wanted to make. With this, I just, thank you.
Thank you. Thank you, Vijay, for your inputs and your thoughts. Let me move to Murli. Murli, you have run big labs, you have built big fabs reasonably, and you have run those, right? And now this ISM program is trying to do things of very large scale with the resources that we have. So you have seen things from the past, similar kind of efforts being taken, and some hitting and most misses. So based on your experience, what difference do you see now, or you don't see now, and what are all the missing points, right, that people are not giving a thought to make this mission successful?
Thank you, Shankar, for giving me an opportunity. I have been in the semiconductor research ecosystem in India for quite some years now. At least I would say more than 40 years. I started my career in solid state physics laboratory, which was perhaps one or two laboratories in India which were working on semiconductors. In fact, let me talk some history because I've been in this system. Our director, Dr. Sridhar, he wanted to start to work on semiconductors. He didn't have a he set up the Hall measurement system to measure mobility. He didn't have a semiconductor wafer. So he wrote to the then Nobel laureates, Shockley and Britton, and they sent him a piece of semiconductor with which he started working on characterizing a semiconductor in our lab. So the solid state physics laboratory from which started the compound semiconductor work in the country. In fact, we set up the bulk crystal growth of gallium arsenide way back in 1980s, and we had grown. I think we were too far ahead, and nobody was willing to scale it up. We had grown single crystal 3-inch gallium arsenide crystals way back in early 90s. So to put for this audience and for this podium, I would like to reiterate my experience in the fab with which I was associated, and I was fortunate enough to have some experience. This was a pilot production fab called Gallium Arsenide Enabling Technology Center, which is located in Hyderabad. It's a DRDO center, fully funded by Ministry of Defense. And this is the only compound semiconductor fab. And this is a space qualified foundry, which Shantanu knows very well that SAC and ISRO utilizes it extensively. And this is a vertically integrated fab in the sense that it goes right from design to process and then test, dice, package, even in some cases make a module, and also space qualified. And all these were possible and it was low volume. This was because it had a technology backup in the form of SSPL, which was an R&D laboratory. The technology for this low volume facility came entirely from solid state physics laboratory. There was no technology transfer from any other country. And the IP that has been generated in this facility is of immense value, both in design and products. And DRDO established this for captive consumption in the strategic sector. And it is not a commercial fab, and it is low volume, about maybe 1,000 wafers per month we can do. And it has never touched that any time in the history, because the volume requirement from the demand pull side is very, very low. And we at GATEC, they make only niche products with in-house design or the designs that come from Department of Space. Establishing such a facility, which the idea was mooted long back, and it was started in 1996, and the first product came out in first MMIC came out in 2000, and subsequently it has produced large number of MMIC space qualified, and it has been assembled in the form of radar and flown in satellites. The images have been successfully transmitted, and every mission, almost every mission in ISRO carries some device from GATEC or the other. Okay, so the ISRO was a prime to whom we used to supply these wafers, and DRDO also supported it extensively. And if you talk of commercial viability of such a fab, it was nowhere near. It was due to several reasons. For example, it's a government-run fab. The government assured the funds every year. And if you try to, because it's a low volume production, if you try to load all the, for example, the cost onto a chip, nobody would buy that chip in the commercial sector. So it's a kind of, and there was not a huge demand for compound semiconductor devices in the commercial space at that point in time. So even, for example, the compound semiconductor fabs, you can count them on your fingers all over the world. For example, there's a Win Semiconductor, UMS, there is Cree, there is Corvo, and a couple of fabs in, there is a Win Semiconductor in Taiwan, and there are only, you can count them, and there are about 10 fabs in the world. That is because the demand for volume was not very, very high. And it is a niche product. And so we had we were fortunate enough to work in that. But the key point or the message that I'm trying to give you is there is a solid semiconductor device R&D, material R&D backup in the form of a lab, which supported it in all forms, whether it is design, material development, or device process development. That is key to any semiconductor fab, which has to be, if you want to establish one. So that is that could be the source of success in gallium nitride, which Vasu mentioned, because we have a huge R&D backup in the form of device research, process research, material research that has been done in the country in several centers in the country, especially IISc, Solid State Physics Lab, IIT Madras, IIT Bombay, and many other centers. So the R&D backup which is required for a fab is very, very important. That is the message that I want to give. And there are also advantages as well as disadvantages in a government funded facility. The main advantage is that the basic funding is nearly assured. So the disadvantages is you are bound by the regulations of the government rules. You cannot, let us say, for example, you want to capture a market and you want to cost the chip to capture the market at a low value, capture the market and then increase it like Ola or Uber does. We can't do that. So, okay. So the fab is technically on par with other. And another thing, even if you want to import technology and absorb them, you should have the basic R&D fab running in which only you can absorb technology. Otherwise, you will run the fab on a licensed production basis, and that has been also experimented in the country in the past. And I don't want to name such facilities which became obsolete over a period of time. So the basic R&D backup and the knowledge base should be there, even if you want to import technology from abroad. So that is a key important point. And this here, there is a lot of talk about the ecosystem. I think my friend Manish Huda brought that out very effectively, but that's a chicken and egg story. You should have the fab or you should have the ecosystem first. The both has to be developed simultaneously. And the fab cannot exist without government support. All over the world, it has been proven. You can take books written, and then there is a recent book called The Chip Story or something, which explains in detail what has been the story of development of chips in US, Japan, and other countries. It's a fascinating read. So we have to take lessons from all of them. And I think I would like to take this opportunity to make a bit of an advertisement. Okay, so I would like to exploit this podium. We, Shankar and Vasu, we are part of the first semiconductor fab startup, which is called Agnit Semiconductors. We have got the IP. He talked of startups. This is one of the first, I think I would say the first semiconductor fab startup with which we are experimenting. We have already developed devices. We have packaged them. We are packaging them and trying to deliver it to customers. So this is I think this news, I don't know whether somebody announced it on this podium. I would like to take this opportunity and exploit this opportunity. Thank you very much.
Thank you. Thank you, Murli. Very interesting points. So now let me move to Mr. Krishnamurthy from IISc. So I want you to have the last introduction, because we still have a round to go, because you heard all of this, right? And you hear this day in, day out from industry, from academia, strategic, and somebody who is not related to the field at all, who are neutral observers and commentators, right? So what is your take? Right now we are, we need to take decisions right now, right? That's what it looks like. And decision looking at various inputs from different people, and we need to react, right? So whether we are going to quickly react and wait for more inputs and not make any decision, we don't know yet, right? So I would like to hear from you based on the discussion that we had so far today, and also your experience and this program that is there, please.
Thank you. Thank you very much for inviting me for this session, as well as for today's program. And I must congratulate the organizers. Since the morning, first panel onwards, it has been absolute learning for an old guy like me. I don't want to get into too much of presentation, but there are two foils I would like to share with you, which are only going to talk about what IISc is. Many of you are IISc members, so I don't have to explain. But those who are not, I just would like to take the first 2-3 minutes. Can I go to the next foil? Skip that one. I don't want to spend time. The next one. Yeah, that one. So we focus, IISc is an industry body. And industry body meaning it's a platform. It's a platform on which we have industry members from Indian companies, the Indian large companies, medium companies, growing companies, startups, MSMEs, they are all our members in the world of electronics. We also have MNCs, almost all the big MNCs are our members. And we also have academia members. We also have organizations which are our members. So it's a platform. And until now, until maybe last year, we were catering to the design ecosystem members. So that is the transition that's happening in 2023, is that we have started seeing a lot of manufacturing members coming on our platform. So what is IISc? IISc is a platform on which we host all the members. And there's a wonderful reason why that's going to be, we are going to play a big role as we move forward into semiconductor and electronics manufacturing. So industry is number one focus. Number two, government. They are our partners. So we work with Government of India very closely, Department of Electronics, MeitY, and also with the state governments. And what do we do there? Primarily, we give inputs into policy making. IISc is a knowledge partner, and I'm proud to say that when it comes to electronics and semiconductor knowledge in the country, our collective wisdom of all our members probably will have the biggest advantage of knowing what is the latest technology, what's the latest, what are the latest, what is happening in this industry. Probably we get to know first before anyone else gets to know. So we work with the government. The semiconductor policy that was announced on 15th December 2021, many of the inputs, I would say 80% of the inputs to that policy came from IISc. And then the state governments. The state governments would like to write the state's own electronics policy. Some of them do R&D policy. Some of them do manufacturing policy. Semiconductor policies have started coming out now. So we play a big role. In fact, a lot of policies we write and give the draft, and then they put it in the government language and publish it. And this is a service we provide with the government. The third focus is academia. We cannot take academia away and say that the industry is going to survive for even a minute. So this is something which I want to emphasize. And we have many institutes as our members, our partners, including IISc. And the last, of course, is a society in which we live. Can we make a difference? We can all say that, okay, we are part of the technical ecosystem, the technology grades, and we are a startup, or we have a manufacturing, but what is the impact we are making in the society in which we live? We are trying to bring in some facts. I did mention about the experiment that I'm conducting some schools in trying to get them interested to make some electronic products. So those are all some of the experiments at this stage, but I'm sure it will grow into a bigger scale things. The next. IISc, we have multiple, you can go through all of them, all the clicks. We have multiple stakeholders, and each one of them have a different expectation out of IISc. So that's the beauty of our organization. But the government, they want to collect the maximum tax, generate the maximum employment, get to know where should they give or whom should they support more at a given point of time. And industry, ease of doing business, how quickly can I move? Somebody talked about customs problem in the morning. So we start, in fact, next week, we are working with the first level field officers in the customs department, trying to tell them uniformly across the country, can you apply the law equally, right? When the officer in Chennai and the officer in Hyderabad and the officer in Bangalore, they don't even agree on certain rules and regulations. How can we homogenize it? So the expectations on each of the stakeholder with IISc, with us, are quite different. We are trying to cater to all those expectations to the extent possible. I wouldn't say 100%. When it comes to academia, okay, they want sabbaticals, the professors want sabbaticals, the students want internship or sponsored projects. A completely different set of expectations. MSMEs and startups, how do I get the funds? How do I access funds? Where do I get talent which I can afford, right? A different set of problems they have. So this is something which keeps IISc running at 100 miles per hour, because we have different stakeholders, which is good. So with that introduction, let me go into answer the questions that Professor asked. I just taken a few examples of the semiconductor facilities that we have in the country. The one in IISc and IIT Bombay. I did not include the one in Chennai because I don't think it has reached a level of IISc Bangalore and Mumbai yet, but it is. I'm well aware of what's happening there. SCL Chandigarh, I would say, is In Indian semiconductor manufacturing, they are the Pidamahas. Sitar and all the associated DRDO entities, including the GATEC and all that, and then Bharat Electronics. Now, coming to answer your question, semiconductor manufacturing or electronics manufacturing in a bigger canvas, but semiconductor manufacturing specifically, it is not just about manufacturing silicon wafers in 5 nanometer or 7 nanometer technology. The moment we talk about semiconductor manufacturing, people think, no, wafers after wafers need to come out of an assembly line. Semiconductor manufacturing is not. This is absolutely far from the truth. What is important to understand, and I also mention here the commercial side of it. The wafers that are manufactured in the latest FinFET technologies, I'm talking about 12 nanometer and below or 16 nanometer and below, the market size is still about 14% of the total volume or 15% maximum. Out of the $500 billion, $75 billion is all the revenue that comes out of the FinFET node processes. The remaining $400 to $425 billion are coming from 22 nanometer up to 180 nanometer. The 180 nanometer, which Dr. Fuda produces today, they have a market share out of the total pie. Just imagine the 100% total pie. 180 nanometers still consume, I mean, the world consumes about 30%, 35% of semiconductors are still made in the 180 nanometer, which FCL has today, right? And when it comes to 28 nanometer, we are covered almost 85% of the requirement. So that number you remember in your head for a moment. Then we look at it from a technology side. We have capability in this country for space grade products, which Dr. Sinha talked about, for strategic electronics like defense applications, which Muralidharan sir talked about. Now, getting a product qualified to MIL 883B or MIL 883S level, don't think that it's child's play. It's extremely difficult. So in this moment, I will break for a second to tell me about myself. I started my life, professional life in Bharat Electronics, Prabhakar, SLN Murthy sir, all my colleagues. Then, of course, after 20 years, I went to National Semiconductor, Santa Clara, Texas Instruments, and the last innings was in Rambus Incorporated. And then, of course, last 1.5 years back, I thought corporate life, enough of travel and all the difficulties associated with that, I took a break. So where did I learn semiconductor design? When I was in Bharat Electronics, in this very same campus, there was a program run by Delft University, jointly with IISc, a 10-month program. That's where I knew how to draw the poly layer of a transistor. That's where I learned. And 1986 is when I taped out the first 3-metal, 1 micron 3-metal CMOS ASIC out of India. The first ASIC to be taped out of India, which went into volume production, used in a military communication application. It was not easy. But what I'm trying to say is, when it comes to technology required for all these applications, the ability to create IPs, and the ability to design for the world, that all have been conquered by the people of this country. So there's no reason for us to think that we cannot build a fab and manage it. Please. What is the barrier? The biggest barrier till today was the huge amount of capital required. And as Muralidhar sir said, without government's intervention and investment, no fab has ever been built anywhere in the world, including TSMC. When TSMC fab was built, the Prime Minister of Taiwan called every single industry and asked them to put money. And they all put money into a bucket, and that's how TSMC was started. It's a well-documented story, right? So considering all these aspects, what would I suggest? Number one, we have all these entities today probably operating in islands. Can we find a mechanism to integrate? Well, many of them need not lose their identity, but can we create those IPs coming out of these entities? Number one. Number two, the only place where I will disagree with Dr. Fuda is that if we are able to produce in volumes and in quantities, there's no reason why these fabs will not be built, will not be filled by all the global players. Because 30,000 wafers per month at a price point which is equal or better than Taiwan, catering to a $65 billion domestic market, and even if you take 30% of that is only 180 nanometers, we are still talking about $20 billion worth of semiconductor products coming out of a 180 nanometer fab in this country. The business case is established. There's no doubt, is it not? And I've already seen the pump makers, the gas makers, all talking about what they can do. Where is Ashutosh? I saw him here. One of the world acknowledged experts in chemical qualification is sitting in this room. Probably there are only 10 Ashutosh in the world. I don't know how many of you know that, right? These are the kind of IPs that are sitting isolated in different parts of the country. And I was very pleasantly surprised when Professor Ghosh from IIT Mandi said he's developing photoresist. And I said, oh God, I didn't even know, right? So it's not that we are going to trip and fall down many times before we do it. Yesterday, a company from Singapore came. They said they want to establish direct drive motor manufacturing in India. Now, linear and rotary motion using direct drives gives you 10 times more accuracy of steppers. They want to start the manufacturing of those motors in India, right? I think one of the sponsors is the Japanese company. I forgot the name. Horiba, right. The last 1 year, 14 Japanese companies, and they are all our members, that's why I know the numbers exactly. They all have started India operations, either for joint ventures or for manufacturing their products directly, or they are already looking for space. Where will they set up the factory? They are talking to the state governments. State governments call us, hey, these people want to make motors. What is the connection with semiconductor motors and semiconductor? They said they are supplier to semiconductor equipments, right? So the whole ecosystem is getting created bits and pieces on one side. And let me tell you, it's not easy at all. And the person who designed and built the underground clean room, vibration-free clean room, is sitting in this room. Jaydev, will you please stand up? He's a man. You should visit, take permission, or catch hold of him. He will take you there. See underground vibration-free clean room. Now, can we build a class 10 clean room without importing materials? No way. It cannot be done. And the puff materials that are required, they are toxic. So Indian government, our pollution control board may not give license even. So don't even worry about that 20% of phosphine type of gases imported. 15% of those materials which are difficult and low volume, high investment kind of materials imported. But the bulk gases which Professor Huda talked about, I don't think that is beyond us. And today, out of the 200 different elements that are required in semiconductor manufacturing, I said in the morning, in a different context, 40 of them are already made in the country, used by pharma industry, used by paint industry, used for agricultural purposes, and they all can be up qualified with investments. And somebody talked about the subsidies that should be provided for the equipment manufacturers also. Under active discussion with the government, hopefully in the next 1 or 2 quarters, you will see announcements coming towards that. And we are very, very positive about it. Right. Policy, yeah. Policy, I would say it is in the draft stage. It has to go through finance ministry and approvals and all that. But all the equipment manufacturers will also get, chemical manufacturers will also get, provided they make the quality required for semiconductor manufacturing. It is capital intensive. That is the only barrier. Remember, it is not technology. It is not technologists. It is a capital investment that is required, which is a barrier at the moment. But as I said, in the context of chemicals and metals and minerals, India was producing agricultural grade, what is that chemical? I forgot the name, which goes into oxygen concentrators. Anybody? Zeolite. And came an emergency. IIT Kanpur figured out a way of upscaling the quality of zeolite into medical grade, and oxygen concentrators and ventilators are made in this country, 30,000 of them, right? So we can go into any number of examples. And finally, let me say this. India could convert the mustard farms of Gurgaon and Faridabad into an auto hub, just because Suzuki started making cars in India. So once one fab gets going, you will see the ecosystem evolve by itself. I don't think we need to break our head whether this is possible or not. I'm an absolute optimist. It is possible. It will happen. And and even if you have to continuously import 25% of the things required for a semiconductor fab, don't worry about it. The remaining 75% itself adds to billions and billions of dollars to the economy. And our calculation is by 2030, if we implement all these strategies, electronics and semiconductors will contribute 9% of the GDP, which is equal to what electronics contributes to Japan's GDP today, right? Today, I mean, India's contribution, electronics contribution to India's GDP today is about 2.5%. It will go to 9% by 2030, provided we execute all our plans. Now, what is a model that is good for us to follow? It is not Taiwan alone. I would say the best model for India to follow, based on my studies, is Japan Plus. Japan is not a major semiconductor manufacturer, but Japan manufactures all the ingredients that are required to cook the semiconductors. Almost everything. Equipments, chemicals, majority of them, they have a big say, right? And what is the plus that India has? Talent. So if you follow the Japan Plus model for the first 5 years, create the ecosystem, create the talent, allow the silicon wafer fab to come up over that period of time, I think we would have solved the problem. And the initiative by Professor Vasu to get the GaN fab and the gallium arsenide fab that is already existing, I think there's absolutely no reason for us to import a wall charger for a mobile phone today. The casing is a plastic injection molding casing. The pins are made of aluminum and zinc compound. India can do that. The semiconductor that goes inside is power semiconductor. And if you have 1,000 what's the capacity you said, sir? 100, 200? 10 wafers per day, 300 wafers per month, right? I think we should be able to convert all our wall chargers into gallium nitride based chip that comes out of this fab. And you know what the payback? 30% efficiency improvement in the power that you consume to charge all your phones. That's a difference. That is a society impact that you will make. With these words, I will stop here.
Thank you very much. Really appreciate your thoughts. I think quite a lot of areas that you have covered. I had few questions, but you answered also well covered. So we have 15 minutes, the max. So let me come back to Vinod, right? So you mentioned that there are some strategic reasons why we will stick to the market that we have right now. What do you think is going to be the future? Because even with that market, right, if that opens up, then how are you placed to generate your next generation of devices and systems and packaging? So how are you placed there?
I think your question is in terms of commercial
innovation,
viability,
even in the current market, purely on the strategic front.
I think being a relatively lesser cost pressure area, I think what matters there is the efficiency, operational excellence, and how we are able to manage the whole process. Sure. We are nowhere less there. I think that's something where today we can proudly say that we are quite competitive, in these markets in anything that we do.
But when it comes to innovation, right? So normally the things that we hear from SEL, and we cannot put the line to test. It need to run, right? There is a commitment, and same thing is true for you, though the volumes are low, but you don't want to take a risk in changing things that may affect your reliability, you don't know, and so on, right?
Yes.
So what is the plan there? How do you tackle this development and innovation?
Yeah, I think they need to coexist is what I would strongly say, because while we know that we can afford to buy technology today or tomorrow, but the strong thing that is going on in terms of being self-reliant, being make in India, all of that, keeping those larger perspectives in mind, it is better to have a coexisting team which works on relatively adjacent newer technologies, while same time consolidate what you're doing and improve upon and make it more efficient, make it more commercially viable, or competitiveness, all of that. I think these two in this question have to coexist.
Good, thank you. Santanu, you mentioned about this very specific products, right? Very niche products that you're developing, right? And at times you have to work with the existing facility and so on, right? So in your thought, what is this, the existing facilities can play a role in shaping up your program or adding value to your developments? How do you see that?
So as I mentioned before as well, these fabs which already exist can at best serve as incubators for new technologies. You cannot readily scale them up, particularly so because they are multi-user facility, and rather I should call them multi-technology facilities. Technology facilities are for prototyping, for proof of concept, to understand whether you can do the technology or not. But if you were looking at scaling up that technology to serve a mass market, it's probably not the way to go.
Right.
Once your technology is mature and you have proven its reliability, it's probably time to move on, have a separate dedicated line for each of these technologies, and then put your product for production. So that's the way to go. The current user facilities that we have in India, be them in a government setup or in the private space, I don't think you can look at production volumes to cater to from them. It's only prototyping at best that you can think of.
So you clearly see the existing facility to play a role in innovation.
That's
correct. The prototyping, and then once you want to scale up, you need to have someone step in who can give you the reliability.
And that's where the role of identifying an industry partner right from the word go is that much more important. It's just not about identifying the technology that we are going to do, but it's also about identifying the right production partner who is ultimately going to scale it up for commercial applications.
Thank you. Dr. Manish, how do you see SEL fit in? So you already heard that from Santanu that there are two verticals, right? One is the innovation and prototyping fab, and then we need to have a fab for scaling up. So where do you see SEL? Do you want to do all of this, or do you see that we fit in better in scaling up, or we want to do R&D?
Shankar, our vision is very clear. Actually, what the model we have been working over there, if nobody is putting a fab in India, we are ready for high volume manufacturing. See the kind of expertise we do have. Although we agree on that part that yes, scale high volume manufacturing required a different kind of a skill set, but that skill set has to be leveraged from the area where we know what to do and how to digest that, and then scaling up is very easy. But of course, if any high volume manufacturing is being set up in India by some partner, some JV, or any another announcement, then definitely SEL would like to play a pivotal role where they would like to act as a center of excellence, where they can work on training the manpower, which is ready for the fab, and working on the R&Ds, industry-driven R&Ds for the node developments, unit process, and technology development along with the IP. And of course, can work with the kind of a consortia where the silicon validation of the IPs and lead design, which is required for loading this fab, can be done there at a single platform. Thank you.
Thank you. Thank you very much. Vijay, So you are running the fab for some time, and you're offering service to academic users of that kind, and then perhaps industries and startups, right? So what is the pain point that you have in the operation?
So yeah. So major pain point is one thing is that, okay, manpower retaining, that is one important things, because within IIT system, we don't have a position, technical position who can run these facilities. That is one of the major hurdle we are facing. And second point is that even for, as you know, all the IITs, anything, we just go for purchasing anything, new equipment, all those type of things. So much hurdles.
I just want to add, when you say, in IIT system, but then at the end of the day, Ministry of Science and Technology, or DST, defines, these project positions or program positions at the end of the day. So it becomes a policy driven, right?
Yeah, so that is one thing, but they have, and also they have also salary cap.
That's what I meant.
Certain thing, yeah. So that is what is really painful. With that salary cap, you cannot retain. No way you can retain, because the industry, the depth of training they are getting, the depth of training they are getting much higher salary.
True.
So that is one thing. And recently, I think Basu used to tell that they are losing a lot of staff to industry. And recently we found that our own staff also lost to your center, because you have given better salary. So yeah, so that is the major pain point from my point of view.
Okay. So manpower, you say, but you did start about procurement.
Yeah, procurement is another thing, because all this process going through things.
Yeah, I think Basu will be better placed to answer the pain points in procurement and the policies, right? So if you want to build new fabs, these are going to be there, but even the survival of the existing fab depends on this procurement. So what is your experience so far?
Well, it depends on what regulates the usage of the funding. If the government rules apply, then it's a sensitive issue, but it's painful. There is no other way to put it, and I think all of us agree with it. And especially given the current scenario where the government is trying to improve fiscal discipline, but that has to happen across both sides of the spectrum. For instance, we are supposed to now return all of our money if you have not used it, but then if you have 25 crores stuck in an irrevocable letter of credit, how do you, it's called an irrevocable letter of credit for a reason, you can't return it back, right? So that will always be there so long as the government is the source of funds. But even if the government is not a source of funds, regulatory frameworks such as what we heard today morning, AU import, now you have to have a license for it. We are facing the brunt of that situation because we don't have an AU license yet. And sometime back, for example, we needed to get a license to import stainless steel tubing, forget AU. So maybe what IISc should tell the government is, for the semiconductor industry, if these are the things that are required, then remove all possible embargoes and regulations and give them a free run.
So that has been raised with the minister on this Saturday.
Right.
And they have taken a positive note on this. I think this will be improved. All the verticals.
I hope it happens really soon.
All right. Thank you. Thank you, Vasu. We'll open up for a few questions. Yes, one here
already. Good evening, everyone. I'm Tulsi. I run a startup incubator based out of the department Insense. This question is to Shantanu. You mentioned that you have a lot of facilities to do end-to-end for the space. Given the role that startups play, can you open up your labs for our startups to use?
Well, it's not about me opening it up. It's about the government making it open. I think there's some positive thinking already in that direction. And with the new space policy that's already in place, I think it's not many months, if not years, before we see government labs being opened up to academic as well as industrial players for use for incubation. So that's something that I feel is there in the offing, not too far off. Yeah. To the startups as well. Yeah.
If I can add one additional input to that question, the linkage of academia with the R&D fabs and R&D labs that are there in the country, particularly the deep technology ones, I think that's being in an advanced stage of discussion with the government. And we will see hopefully some announcements coming within the next month or two. And one of them is to enable campus incubated startups to access the R&D labs and R&D fabs. It's a common problem that's being faced.
One there.
Hello, good evening. My question is regarding the SEL facility. So we have the technology partnership with Tower in SEL. And also, sir, you mentioned about, all of the abilities well within our reach. But even for a manufacturing, today we need a technology partner. So just want to know, for example, because already we have a partnership in SEL, where are we placed and how far along are we in terms of independence? Can we do without them today?
There is one correction, understanding of the subject. Tower is not a technology partner of SEL, number one. Tower is a technology provider of SEL who used to provide the baseline technology in SEL. Then thereafter, there is no role of Tower. SEL has absorbed the technology, mature it, and qualify it for the different applications. Now, Tower is only supporting the kind of equipment maintenance support because the equipment which we are having, they are from the OEM. The very much question which in the morning was being asked whether we should go for a third-party refurb equipment issue. OEM support will not be there on this. Okay, so that's the big issue. But of course, as you said, you get the technology. If you are starting right from today, inventing the wheel for the technology node and absorption, there are a lot of unit step involved. This unit step has to be first developed, then qualified, then integrated, and then you have to make the PDK qualified based on the modeling of the process. It's a time-consuming process. Go ahead signal is that take a technology node which is starting with having catering on most of the volume segment demand, run your facility, run a R&D facility line in parallel within that facility or somewhere else, and start developing the new edge of the technology, new unit processes, new PDK, new IP development for advanced nodes. It is not say 65, then go for 45, again buying it. If you are absorbing 65, okay, start developing the 65 products, manufacture them, parallelly work in it 45 and 40 and then 28 or maybe 22. Any node you can go, but that leverage has to be done with a kind of knitting all the dots in our country on a single platform, working together in small verticals, integrating to a large one.
Last one. Rather than this is a question, is my suggestion to, or maybe request to Vasu, Mr. Krishnamurthy and Huda. See, we have a lot of resources available in our country. Let us wait for the dream fab to come. Before that, why can't you utilize all these resources available in the country? Just Mr. Krishnamurthy was telling, sent a message yesterday to find out how many fabs are there, class 100, class 1000. I collected some information that about 5 organizations have class 10 clean rooms, but 18 organizations class 100 clean rooms. You can put these clusters together, optimally utilize starting from CNSC, SCL, and IIT Guwahati, IIT Kanpur, IIT Mandi. Why can't you make utilizing the existing facility until we get the team fab? This is a suggestion. IISc can suggest also.
Sir, this task has been done. Over the map of India, we have identified the clusters and the kind of a facility which they do have. We have shared visa also with the government, also with the work workforce development part also. And we have mentioned them what kind of a technology, know-how, or a skill set these lab or fab can develop. So level 0 to level 5 has been identified and given to the government. So that's
Thank you.
Thank you.
All right. Thank you very much. We are at the end of this session. So if I have to summarize briefly, right, the detailed summary will follow, that the existing fab are doing their own job, right? And it was already mentioned that even with the existing fab, we should be able to meet some of the requirements, right? Really hard requirements. When I say hard requirement, these are all products that can be sold in the market. We don't need huge fabs for that. So we need to explore potential of the existing fabs, right, for the productization. And the other thing is to create an ecosystem. That was the last point that was mentioned, right? We have our own way of doing things. We need to create an ecosystem or consortium where we could exchange, what we do, how we do, and appreciate, each other's limitation and take advantage of how others can step in and help you, right? So that is something that I think is essential. And innovation is the core, right? We can talk all of this, but at the end of the day, what sustains these fabs or existing fabs and pilot lines are innovation. We need to keep innovating, and the innovation will only come when you're going to tackle new problems, right? And we need to be aware of that and work with the supply chain. So though we say that supply chain are there to make the operation going, no, it should not stop there. We should work with the supply chain, like the resist or gas or any kind of fluid that's being used in the fab. We need to work with the supply chain to make it to the level, right, that it will be qualified for large fabs and so on. So the existing fabs, I think they have the responsibility to bring these existing supply chain to the level that we need. So with that, I would like to thank all the panel members for openly discussing and putting it out there. Quite a lot of things I noted out, so we will share, and I might get in touch with you. So thank you very much for the committee. So I'm supposed to give a bag to them. I don't know what's there. So if you don't like it, it's not me. I mean, thank you, Vasu. Should I get it back? Thank you very much. Thank you very much. Thank you very much. Thank you very much. Appreciate it. Thank you for leading. Thank you, Vijay. Appreciate it.
Thank you, Shan.
Thank you.
We have another 15 minutes where we have opened all the panels for questions. After that, we will close the conference.
So what he is trying to say is now it's open. You have, whatever comments, opinions that you may have, you can.
Hello? Yeah, exactly. We still have not done yet. Yeah, you still have a lot of questions to ask to the panelists. I thought we have half an hour now. No? Okay. People are leaving. Then Vasu, please, closing remarks.
Well, on behalf of the Center for Nanoscience and Engineering, let me first thank all the participants, especially the panelists, like I said in the morning, who spared their valuable time to come here, discuss and share their thoughts and ideas with us. But above all, such a event cannot happen unless a few people decide to bend their backs. And in the case of SENS, it is like I even said in the morning,
This event is not organized by our faculty. Faculty normally organize conferences, but this event was organized by the SENS staff members and our industry affiliate program. And I think among the chief organizers were Dr. Vijay Raghavan. Can you give them a hand? Dr. Tulsi Gandikota is here. Dr. Savita. Dr. Suresha. And I think Professor Sushoban and Professor Shankar played a role. If I'm missing anybody, I'm very sorry. But in general, Divya from our outreach, committee. But like I said, I used a broad brush when I said it was organized by the SENS staff members, about whom we are extremely proud of, and without whom, A, we would not be able to run SENS, and B, of course, not organize conferences such as these. Yeah, so all the staff members and the other volunteers other than our staff members? Huh? Okay, so we have volunteers other than our staff members. So a big thank you to all the volunteers who helped make this conference happen. All right. Great. Anybody I missed? Huh? Oh, that's okay. I provide the umbrella. Okay, so I'm supposed to do the honors. Sushoban, why don't you do the honors? Come on over. You're dressed. So can I request Vijay Raghavan to step over? Suresha? Savita? Tulsi? Oh. Okay. So Suresha, over to you for the official vote of thanks. Here you go. Oops.
Thank you, Professor Vasu. So on behalf of the organizer, I would like to thank officially, as Professor Vasu said. So first of all, we would like to thank our chief guest, Dr. Ramana Reddy, ADC, Government of Karnataka, for accepting our invitation and coming here with his busy schedule and spending his valuable time. We also would like to thank our divisional chairman, Professor Naukant Bhatt, for opening remarks as well as moderating a session. We thank our chairman, Professor Vasu, for his encouragement and motivation in organizing this conference, and so chairing, moderating a session, opening remarks, as well as a panelist. We thank the panelists for making this conference successful, and not the least, the moderators for making this conference sessions in time and keeping the time up, as well as keeping the session lively and informatively. So special thanks to Professor Sushoban for all the support and directions, and so making this conference at such a big level. So we also thank INUP I2I and IISc for co-hosting with us. So we also thank our IAP members. So we thank our sponsors, Platinum, Thermo Fisher, Prefer Vacuum, Horiba, KS, UHP Technologies, Tescon, Wright, and Park Systems. So we also thank Division of Biological Sciences for providing the venue for the occasion. and all the biological sciences auditorium and the staff of the biological sciences auditorium for their support. We also thank Digits team for all the help in Digits and making us possible to go live. We also thank IISc administration, all the MNCF, NNFC, packaging lab, Incense volunteers. Special mention to Bindu and Divya. So I spelled it correctly. So all the admin staff for their support and all the help which is rendered throughout last few months. We also thank the press for covering our event. So not the least, we thank all the audience. We had got overwhelming response. We had about more than 500 registrations. So we could not admit all of them. So we could, because the hall limitation is only 200, we could able to accommodate them. So sorry for not accommodating the others, but hope they have watched the live streaming and participated over the online. So we visualize this conference as a forum where various stakeholders like government, industry, academics of the fab ecosystem can congregate and interact. Hope you have find it's a productive and engaging. So we plan to, so as pointed out by the Professor Vasu in the morning, we plan to produce a report out of this conference that will be shared with the relevant stakeholders and also with our IAP members. We look forward to continue working with you. Any comments and suggestions, feedback, please get in touch with us. Write to this email ID. Thank you. Thank you, one and all. If I missed to thank anyone, please apologize. If anything you find it inconvenience or anything happened, we take the responsibility. So we apologize for the same thing. We do it better next time. Thank you.